Testing John, can you hear me? Testing John.
Yes, I can. Yep, you coming through loud and clear. So one thing I will ask is just at this time, it looks like we're getting close enough. We don't quite have all of our morning presenters
Testing
on.
John or Kenny, can you hear me?
Yes, we can hear you. Can you not hear us?
John, I'll
I
text
can hear you,
and
Mike.
let him know.
Yeah, we'll keep the test if possible off of the main channel here. So what we'll have is the morning session presenters. If you're here, I'm going to assign you to the speaker ready room. And Kyle,
Yeah.
if you see any of the remaining morning session presenters coming in,
All right. I will.
just have them go over to the speaker ready room.
Will do.
All right. And if you need me, ping me on Slack. This is just a quick reminder for everyone coming in right now, because we do wish to verify the attendee list. I'd ask that anyone whose default Zoom name is just your first name or your last name to please rename yourself to your first and your last name so that we can check against our attendee list. Thank you.
Okay, we're going to get started here, folks. We got about 3 minutes to the top of the hour. And I know there'll be some folks streaming in here throughout the morning, but first of all, welcome to the 2021 NWA Extreme Weather Virtual Symposium. This is presented by the Central Iowa chapter of the NWA. And my name is Kenny Pedrazik. I am the president of the chapter. And so this is really the second year we've been doing this virtual symposium. Last year we had to cancel the in-person one. Obviously, you well know about that 2 weeks before we were going to have the conference. So next year we hope to have the in-person one back in full style. So that's so save your dates on that. It's March 24th, 25th, and 26th of 2022. That's in Ankeny, Iowa. So definitely save your put that on your calendar for coming into Iowa if you want to come in late March. I want to thank all the invited speakers that were willingness to participate today. Looking forward to some really great talks and presentations today. It's fantastic stuff. I also want to thank all the members of the Central Iowa NWA for their hard work and dedication in putting this thing together, making it happen. So a couple of announcements. Unfortunately, James Spann had to cancel today. If you actually watched some of his broadcasts yesterday of all the tornadoes, you'll know why. So I believe his house was impacted by one of the tornadoes, unfortunately. So and to end this here, at the end of this session here, we're actually trying to find another presentation to fill his spot this morning, but we may have a few, a little bit, the agenda may be a little bit different than what we have online there. So just be aware of that. We'll provide some announcements throughout the day. So, all right. And then at the end of the session here this morning, Mike Fowle, he's the SUE here in Des Moines, but he's also our scholarship chair for the chapter. He'll be presenting the Tim Samaras and Pam Dale scholarships winners. That's going to be set at 11:45. So stay tuned for that at the end of the session here this morning. So I think we have our first talk here is Dr. Jeff Trapp from the University of Illinois. And our favorite thing to talk about here in Iowa is QLCS tornadoes. So without further ado, let's start it off.
Okay, can everyone see my screen okay?
I can see it great.
Excellent, thank you. Well, thanks for the organizers for this opportunity to be with you this morning to talk about your favorite topic and mine, QLCS tornadoes. I want to acknowledge my two graduate students, Jeff Marion and Michael Sessa. So I'm presenting this today, but this is mostly their work. So the last time I talked at this conference was in 2006. So I dusted off this little gem yesterday to see what I was thinking about at this time. And this is just a little bit after some work that Morris Wiseman and I were doing, developing this concept of damaging mesovortices, which was then followed by the BOECHO and MZV experiment, BAMX, where we were able to gather some information that helped confirm the modeling results. And then this led to some work on QLCS tornado climatology and a little bit of work on QLCS tornado genesis. But we still have quite a ways to go. I would say that if you look in the literature, it's still pretty clear that much of the effort continues to be devoted to studies of formation, especially within supercells. And then comparatively less effort, in my opinion, has been devoted to studies of tornado intensification, especially within QLCS. So that's going to be the focus of the work that I talk about here this morning. So this may be justified if you look at some of the statistics, some of the work that we did that's been followed by really nice work by Brian Smith and others, and then with Walker Ashley and others, that you'll see that QLCSs are responsible for only about a quarter of all U.S. tornadoes annually. However, this percentage, if you look at the statistics, varies by season, region, and also time of day. So as an example, overnight, during the cool season in the Southeast US, when and where populations are more vulnerable. So that kind of argues that we should be spending a little bit more time on this topic. I'm sure the operational folks out there can attest to the fact that the prediction and timely detection of QLCS tornadoes are more likely to pose significant challenges to forecasters. We started to think about this back in the late 90s, and then Jerry Brodsky had a paper about warning verification that really shows this. And this is because these events offer less lead time. They form so rapidly, maybe one volume scan of radar data before the tornado actually forms. They tend to be fairly poorly sampled in terms of radar signatures. This is probably because they're relatively shallow, but also that they tend to lack a really well-developed mid-level meso. On the other hand, if you look at the statistics, they show that QLCS tornadoes tend to be relatively less likely to be classified as strong to violent, although there are some exceptions. And so the question that we really want to try to answer in this work is why? What controls what limits the intensity of QLCS tornadoes, and when and where and why can they be stronger at times? So I want to sort of reverse and think about the contrasting case of wide, intense supercellular tornadoes. And I have my little line drawn through here about genesis, because pretty much everything I'm going to talk about here this morning regards intensity and not genesis. So I just want you to keep that in mind. So we've been doing some work over the last several years focused on relating intensity to the characteristics of the parent mesocyclone and the parent storm. Some of this work has been published in JAS back in 2017 and 2018. And I'm going to let the wonderful Miss Nancy Kerrigan demonstrate the very basic concept of this work. And our embarrassingly simple hypothesis is this: that wide, intense tornadoes, such as those that form out of supercells, should form more readily out of wide rotating updrafts or mesocyclones. And so the basis of this idea, this is, I think, one of the only equations that I'm going to show, so relax, is what's known as Kelvin circulation theorem. This is just another way of expressing conservation of angular momentum that we all learn in our dynamics classes. It basically says that the circulation of the tornado, and in particular the radius and the tangential wind speed of the tornado, should depend principally on the circulation of the mesocyclone, in particular the radius and the intensity of the mesocyclone. But because a mesocyclone is, strictly speaking, a rotating updraft, we argue that these characteristics, the radius and the intensity of the tornado, should in turn depend on updraft width. So that's been an ongoing focus of our work over these past several years. So I want to make a note here, because this has been a source of confusion, I think, in the community as we're talking about this. This conservation of circulation, Kelvin circulation theorem, is just vortex stretching. This is just a re-expression of vortex stretching that a lot of us are perhaps more comfortable with. But the problem with this concept of stretching is that it's more difficult to directly evaluate using operational data streams. On the other hand, that's not the case with circulation, because we have data that allows us to evaluate the intensity and the radius or the width of mesocyclones, and then relate those to the intensity and the radius of tornadoes. So that's going to be the focus here. So I want to start by talking a little bit about how we try to gain some observational support of this idea, this hypothesis. And our objective here is to relate tornado EF scale, so intensity in quotes, with the pre-tornadic mesocyclone width. And I emphasize pre-tornadic because if one evaluates the attributes of mesocyclones while the tornado is ongoing during the lifetime of the tornado, then that mesocyclone will reflect the attributes of the tornado itself. So we have to be very careful about trying to evaluate the pre-tornadic characteristics. What this also allows us then is an opportunity to be able to use these attributes to be able to anticipate rather than doing it in real time. Okay, so this is based on some work that we published in Weather and Forecasting last year, where we looked at a reasonably sized data set here, 102 tornadic mesocyclones. We used level 2 data, went through and manually analyzed, not me, but Michael, manually analyzed these mesocyclones, in particular the analysis of pre-tornadic width, as well as pre-tornadic intensity, and this is just simply differential velocity. So I want to make an important point here that all this analysis is conditional on the existence of a tornado. So in other words, this focus here is on the potential tornado intensity given the existence of a tornado. So this is not meant to be a study of tornado genesis, but rather a study of tornado intensity given the existence or given the formation of a tornado. So important distinction here. Okay, so you can find all the details about this methodology within this paper, but I just wanted to kind of mention just real quickly that the way that we evaluate width is simply the linear distance between the peaks and the velocity couplet. We evaluated this over 3 elevation angles with at most 4 volume scans prior to the tornado formation. So you can already see that there's a potential issue with QLCS tornadoes because often it was just maybe 1 or 2 volume scans before tornado genesis. And then we also did some work where we looked at the characteristics after genesis so that we could use that information. So this is just an example of how we would have measured width. And then again, intensity is just the delta V. Okay, so let's just get to the results. So this is over a range of convective morphology. So what I'm showing you here represents supercell tornadoes, QLCS tornadoes, and sort of an other category that we call multicell, but often these are sort of clusters and so on. And what we were able to conclude immediately here is that pre-tornadic mesocyclone width is strongly correlated with tornado EF. We demonstrated this with a linear regression with these R-squared values of 0.75, which is quite robust. We can also present this in a different way. So this is presented in terms of a box and whisker plot. And this strong correlation is also shown in this presentation of the data, again, where width width separates quite well the significant tornadoes from the insignificant tornadoes or less significant tornadoes. In particular, once we go above EF2, we see a really clear separation. So this is really exciting for us in terms of a potential looking at some characteristic of the mesocyclone before the tornado forms to give us a sense of what the potential tornado intensity could be. I'll note, by the way, that this result is independent of range if less than 100 kilometers. And then once we get beyond 100 kilometers, then it gets more difficult. So we're talking about QLCS here. So I wanted to separate out supercells from QLCSs. And when we do this, what we find is that the R-squared values, that's some measure of how well width and EF relate, is significantly higher with supercells than with QLCSs. So it's the supercell mesocyclones that contribute the most to this overall robust relationship. So that leads us to ask why. And some of you are thinking, well, Trap, it's probably because of the EF ratings of QLCS tornadoes, and we definitely think that contributes to this. However, we also think that there's some physical differences here in the intensification process in QLCS tornadoes relative to supercell tornadoes. So that's something that we want to investigate. This is harder to do with observations. And so now we turn back to modeling, in particular, idealized numerical modeling. And so what we've done here is used simulations of tornadic QLCSs. These are going to be in warm season, relatively high CAPE 2000 joules per kilogram of CAPE environments using this model called CM1, Cloud Model 1. This is George Bryan's model. You'll see this a lot in the literature. It's an excellent tool. And so what we've been doing is conducting experiments with two general types of wind profiles, a straight versus a quarter circle hodograph. And these represent relatively high values of shear. And then what we also did was conduct experiments with two different mechanisms for convection initiation. So this is a pretty standard way of initiating convection in models. It's a so-called warm bubble procedure where literally at the beginning of the simulations, there are warm perturbations that act to initiate storms. And the way that we get the QLCS is have a line of bubbles, and these bubbles result in individual storms that produce cold pools that then interact and eventually allow for this convective line to develop. So this is more of an upscale growth kind of mechanism, but we wanted to make sure that our results were relatively independent of this way of convection initiation. So we also did some experiments where we initiated convection with a cold blob. So this is basically a line of cold air. And so this would represent more of a linear forcing type of initiation. And so we wanted to see whether our general conclusions depended on this way of initiating convection. Okay, so I want to give you a couple example results. You can go to this paper. This is a paper in JAZ that I think will be coming out soon. You can find this in the early online release. And see all the details about how we define these things and so on. The grid resolution of these experiments is not small enough for us to say that we're explicitly resolving tornadoes, but we do claim that these are tornadic-like vortices. And so I'm going to use this term TLVs, tornado-like vortices, throughout rather than claiming tornadoes. Anyway, here are two cases. On the left here represents one of our low end intensity cases. Here, you could find the statistics for all the environmental variables in this paper. I'm just showing you one here. The 0 to 1 SRH is 120 meters squared per second squared, in contrast to this high end event, which had a 0 to 1 SRH of 266 meters squared per second squared. Okay. So what we were really interested in, though, is trying to look at the characteristics of the parent storm, characteristics of the parent vortex, and try to understand whether or not those had some control over the TLV intensity. So that's going to be the focus, is quantifying different characteristics of the storm across multiple experiments, and then trying to see if we can come up with some correlation between TLV intensity and the quantification of that storm. And by the way, we're going to quantify TLV intensity in terms of vertical vorticity. That's something that we can analyze, but this generalizes pretty well to quantifications of wind speed or whatever. All right, so here we go. A number of hypotheses that we pursue here. So the first is the intensity of the QLCS updraft. So if you read the literature and I'm trying to reset my clock here, read the literature and so on, there's a lot of discussion about updraft intensity, and I think that's intuitively what we would immediately think in terms of the control of the QLCS tornado. And so what we've done here is evaluated the peak vertical velocity at three different levels. This would be considered the low levels, so 1.5 kilometers above the lowest model level, 3 kilometers and 6 kilometers, so sort of mid-level and then low level. And what we find in terms of this correlation and a linear regression of the peak vertical velocity at 1.5 versus the TLV vertical vorticity, our measure of intensity, is that there's some correlation between TLV intensity and the low level updraft intensity. But as we go above that, if we go to 3 kilometers or 6 kilometers, the correlation becomes much weaker or essentially non-existent. So we can kind of conclude here that there is some connection between QLCS, TLV intensity, and updraft intensity, but it's relatively modest. What about the tilt? So there's a lot of discussion about the tilt of QLCS updrafts. And so we were really curious if that was going to be the case, if that was going to be the smoking gun that distinguished strong TLVs from weak TLVs. And so what we did was measure the horizontal distance between the updraft maxima within each individual associated TLVs between 1 kilometer above the ground and 3 kilometers above the ground. And what you find if you look at this updraft tilt versus TLV intensity is that there's relatively no signals. There's relatively no correlation here. The correlation coefficient, the regression coefficient here is 0.05. So basically no correlation between this updraft tilt as we've quantified it and TLV intensity. And we were really puzzled by that. But then we kind of ultimately argued that that updraft or lack of updraft tilt is pretty much already required for TLV formation, and therefore most TLV updrafts are already upright, and so then we can reason out that I guess it makes sense that there wouldn't be a much of discrimination between intensity based on tilt because they're already relatively upright. I want to make a note here, by the way, that these points represent what we quantified as TLVs. There are a lot of vortices in these simulated QLCSs, so we only looked at the strongest ones, or the ones that sort of met our basic criteria as a tornado-like vortex. So what about the area? So that was the focus of our simple hypothesis. This was the focus of this work that we published in JAZ that focused on supercells. And here what we did was quantify the area, so contiguous grid points where the vertical velocity, where the updraft exceeded 10 meters per second at 1.5 kilometers, so the low level updraft. And what you see here is that there's a strong correlation between the area of rotating updraft cores that we can call mesocyclones, I put it in quotes, and TLV intensity. So here's some suggestion that this mechanism, this simple hypothesis that relates updraft to area of mesocyclone to tornado intensity holds for QLCS as well, at least in the models. What about environmental wind shear? So we would like to be able to use the environment to be able to say something about TLV intensity, in particular the hodograph shape. You'll notice that, or you might recall that we did two different sets of experiments, one with a straight hodograph and one with a quarter circle hodograph. And what we find when we look across this space of environmental wind shear, in particular hodographs, is that the number of TLVs in a QLCS were relatively independent of the hodograph shape, although we did find that there were more TLVs with stronger shear. So some connection between the strength of the shear and the number of TLVs, but not necessarily intensity. But it turns out that when we separated out by shape, we found that the strongest TLVs were associated with the curved hodographs. And then we were really curious about why that was. So we kind of dug into the analysis. And what we find is that this connection here is linked to differences in TLV duration, such that the TLVs that had a longer duration were more intense. This in turn was linked to the characteristics of the cold pool. So we have a link here between hodograph shape, curved hodographs, and the duration of the TLV, and then also to the cold pool. So I want to talk about that just a little bit. So we find that when we evaluate the cold pools in QLCS is simulated in environments with straight hodographs versus curved hodographs, that the cold pools in the straight hodograph environments tended to be relatively deeper as compared to here. So these are vertical cross sections of potential temperature perturbation, and also relatively stronger. And this results in a stronger duration, or a shorter. This results in a shorter duration for contraction of the circulation, or a shorter duration of stretching, if you prefer, as we show here. So TLV duration versus hodograph shape. Not a clear distinction, but it's shown here that we get longer durations over the kind of the range of the experiments in the quarter circle hodograph than with the straight hodograph. So we have a little cartoon here to talk about this, just to kind of help us understand sort of the basic processes. And we know that cold pools are important. We know that we have cold pools in supercells as well as QLCSs. But we also know that cold pools within QLCSs tend to be more widespread because they're being contributed by multiple cores within a QLCS. That QLCS cold pools do tend to be, in general, stronger and deeper. And our analysis shows that cold pools affect TLV duration as well as updraft duration, or updraft longevity. We went back to sort of more colloquial discussions of terminology and so on, and we're attempting to relate this terminology to our analysis. So first, on TLV duration, that this would be sort of another way of saying gusting out, and our analysis shows that the deeper and stronger cold pools within straight hodographs are resulting in negative horizontal vorticity advection that limits the duration of TLVs. These storms also suffer more from undercutting, but in particular, what they're doing is they're suffering from dilution of updraft parcels. So two contributions of the cold pools that negatively affect TLV and updraft longevity, especially in these environments simulated with straight line hodographs. Okay, so I want to kind of make a couple sort of concluding remarks based on these simulations, at least. We find that tornado intensity is influenced by updraft intensity, but not significantly. And we also found this, by the way, in our studies of supercells. As in supercells, we find that QLCS tornado intensity is significantly influenced by rotating updraft core width, or mesocyclone width. But this is more complicated. There's sort of more moving parts, so to speak, in QLCSs than in supercells, because of the more significant role of the cold pool, making a note that this is sort of the driving dynamics of the QLCS in general, as opposed to the rotational dynamics of a supercell. And it's the cold pool that then restricts the TLV and updraft duration. So I want to talk a little bit about our next steps in this work. The first is that we want to go back to the operational data. We want to go back to the radar data and also to the environmental data. So the work that I showed, this is this paper by Michael Sessa with the radar analysis. You'll note that there wasn't any environmental information. And so what we're doing now is applying some machine learning techniques to both the radar and environmental data over a much more expanded radar data set. And so stay tuned for that. I will tell you that we're finding the same basic results with the radar data, even with a data set of 300 cases as opposed to 100 cases. And then the next step now is to go out to the field and collect some data. And so this has been an experiment that's been discussed for 10 years or more, a study that is devoted explicitly to QLCS tornadoes. We went through a number of names to this field campaign. Some of you may know that the kind of the initial discussion for this was something like non-classic tornadic storms. So now this field campaign is called Perils, which is the propagation, environment, and rotation in linear systems. We were hoping to be able to go out this spring and collect some initial data, but the funding agencies were concerned with COVID protocols. So this has been pushed back to spring of 22, 23, pending some final decisions by the funding agencies. This will be conducted generally within Southeast US. This effort is being led by Karen Kasiba, who's now affiliated with the University of Illinois, with NSF collaborators of me and Steve Nesbitt, and then collaborator Matt Parker at NC State, and then numerous NOAA collaborators that are funding investigators at different institutions. So I just want to give you a quick glimpse of one of our operation plans. These are all the various assets and how we think that we're going to try to deploy these assets. This will not be a highly mobile chase kind of experiment. This will be an experiment where we deploy in fixed locations based on convective allowing model forecasts and best guesses on the evolution of the convective system. But this is just a schematic that shows this. So we're really interested in blanketing the QLCS with multiple radars. We have C-band radars, so there are the C-band smart R radars, as well as now something known as the COW, which is a C-band version of the mobile radar, of the Dow mobile radar. We also have a Dow here or there to be able to sample some of the leading edge kinds of vortices. Attenuation limits how much we can use with X-band, but it does allow us to see things at the leading edge. We're really interested in the environment, and so lots of soundings. We have a 915 megahertz profiler that we'll be bringing to the experiment. Mobile mesonets, stick nuts, and so on. So what we seek to answer here is our questions related to the genesis of these vortices. We want to be able to address the processes that would control a tornadic versus non-tornadic mesovortex, where the non-tornadic mesovortex could still be damaging. We're really interested in the variability of the QLCS environment, and to the extent that may affect locations where we have vortices and locations where we don't. And then we're interested in the forcing, so the role of frontal boundaries and the role of cold pool processes. So stay tuned for that. Hopefully there will be more announcements of this project as it goes through. There's lots of discussion on Slack right now about dry runs and so on, but hopefully we'll move forward with this experiment starting next year. So I'm going to stop here to take your questions, and then I have to run off and teach. Thank you for your attention, and I'm happy to answer any questions that you have.
Excellent. Yeah, if anybody has any questions, please ask them in the Extreme Weather Symposium channel on Slack. And we do have one question in there from Dr. Gallus. He says, Jeff, excellent presentation. My question likely is outside your research area, but do you have an idea of what determines how wide the mesocyclone will likely end up being in supercells and or QLCSs? This seems important since you found the meso width correlates with tornado intensity.
Right. So we've done some work with supercells and a range of experiments. And what we see is that the environmental control, at least, or the biggest environmental control to the updraft width and therefore to the meso width, is environmental shear, at least to the first order. It's a combination of both CAPE and shear, but in our experiments, we find a pretty significant correlation between the lowest part of a curved hodograph, say the lowest 2 kilometers of of that with the updraft as tempered by the Cape. And we see something similar here with the environmental shear within QLCS updrafts. And so we have an explanation for that we've discussed in a paper in JGR that basically invokes kind of the dynamics associated with the pressure. But yes, environmental shear, as modulated by Cape as an example, seems to give a pretty good explanation for updraft width and therefore for meso width.
Excellent. Very
Bill.
good. And just this more of a comment, it sounds like this Perils is similar to Vortex and Vortex 2 from a few years back. It looks like it's a lot of the same players, which is fantastic. You guys did, I mean, that was a really cool project. So looking forward to seeing what comes out of that over the next couple of years. So
yeah. Well, it'd be great for us to have some data, because that's something that we've been missing is some solid data that we can just dig into and try to figure out things like the mechanism for genesis and then in particular this topic of intensity.
And you said you chose the Southeast, right? You know, how come you're not up in here in the Midwest or other looking? I'm just curious.
Right. I understand that. This is in part because the funding is related to the NOAA Vortex Southeast program.
Gotcha. Okay.
Yeah.
Very good.
But then we also have looked at the climatology too, and there's a pretty high frequency of QLCS tornadoes in the Southeast during that sort of months of March, April, May. But yes, I acknowledge that there are other places around the country that deal with these events. And I'll note that we have a mobile radar facility now at Illinois, and that's something that we're interested in doing in the Midwest is some opportunistic data collection. As an example, if we had this facility last August, we would have loved to have been able to learn more about the derecho events. But yeah, so we have this on our radar, so to speak, to be able to collect some data in the Midwest as well, outside
Very
of
cool. Very cool. Okay. Well, appreciate your time today.
Yeah, thank you.
Teach some kids, if hopefully they're attentive this Friday afternoon or Friday morning.
Yes. Right. Okay. All right. Thanks, everyone.
Thank you. Have a great day.
You too.
Okay. We do have one announcement. I know since James Spann had to cancel due to the tornadoes from yesterday. If you haven't checked it out, check out his Facebook page. He was pretty much wall to wall yesterday. Did a fantastic job helping people save lives. And unfortunately, I believe his house got hit by a tornado, so that's why he's not here today. So we had a little switch in the agenda. Roger Erickson from the 1 o'clock slot. He's going to be talking about the Hurricane Laura. So he'll be sliding into 10:10 to fill in for James. And then we'll have another derecho talk. So it's going to be all afternoon derechos. And that'll be Rod Donovan. He'll be talking at sometime one of the first two slots there. I think at 1:35 we'll be talking. So, and then my talk and Lee will be the first ones to begin the session for the derecho. So that's it for that. If you have any questions, again, please ask them in the Slack room there, Extreme Weather Symposium. Up next, we'll talk with Greg Hansen, the WCM from Boulder National Weather Service. He's going to be talking about the troublesome, in more than name onlys, the East Troublesome fires in 2020. So take it away there, Greg.
Okay, good morning, everyone. Let me get my screen shared.
I see it. Looks good.
You see it. All right, very good. Okay, well, thanks for having me. This is, and now for something completely different. We're going to be talking a little bit about wildfires in the West. Last year was a big year for Colorado. And one fire in particular, the East Troublesome fire. If you couldn't have a more appropriately named fire, I don't know what that would be. But yeah, so here we go. Let's see, get my pointer going too. All right, so overview, I'm going to talk about the 2020 year we had just in general, and then get into the details of the East Troublesome fire, what the decision support services that the Boulder office did, And there's 3 real times to key in there: the end of October, a day of very explosive growth, the night when it jumped the Continental Divide, and then it made its final run before some snow ended it. So three times in there. These were the fires that we were dealing with last year. Of course, there's the East Troublesome Fire, named after East Troublesome Creek up here on the west side. It's called troublesome more for its flooding issues than fire, but this year it was fire. A couple of key things: Grand Lake, the town of Grand Lake up here, town of Estes Park here. The actual largest fire in Colorado last year was the Cameron Peak Fire. That was a little bit to the north in Larimer County. Towards the end of its life, it just got into the base of the foothills. Didn't really threaten Loveland and Fort Collins, although it gave them some pretty good views. Also, the Mullen Fire, mainly up in Wyoming. We had the Calwood Fire just north of Boulder that was an amazing thing to see out our office window, and then the Williams Fork Fire. So quite an active late summer actually in our area, and we'll talk about that. So in 2020, we burned the most acres in history in Colorado. Our 3 largest fires in the state happened in 2020. So prior to 2020, the Haven Fire from 2002, I believe, was the largest fire. Then the Pine Gulch Fire got going out on the western slope near Grand Junction. It eclipsed that, became the largest fire, and we thought, wow, what a year. And then later in the season, Cameron Peak and East Troublesome both blew up, and Cameron Peak won the honors with the largest fire. It was an interesting year for us. The Boulder areas, the image I just showed you with the fire outlines, that had a normal snowfall in the previous winter. So we were thinking, we'd probably be okay, maybe some fires, but nothing on the scale that we saw. The problem was our summer monsoon, our typical Rocky Mountain afternoon showers and thunderstorms never materialized. And so the fuels just dried out. Everything got really dry. The winter snowfall played out by early summer without the continuing scattered showers and thunderstorms to keep things a little wet. Things just really took off. And there are huge swaths of dead standing timber available as fuel. The pine bark beetle has just decimated a lot of our forests. And so there is just a tremendous amount of dead standing timber that's just waiting to burn. So those have been dead for years and years, so they are certainly dry. And that's been a big factor in how these fires behaved. And just the late starts, we're talking October, that should be, our season should be over by then. But instead, these fires that got going in late summer were able to keep going because of the drought we were in, the ongoing drought. So this is a graphic of our 1,000-hour fuel moisture. So the forest fuels are divided up into how quickly they dry out. So 1-hour fuels are the fine fuels, the grasses, small sticks that can dry out in an hour, basically. The 1,000-hour fuels are the ones that take 1,000 hours to dry out. So think, large timber, big logs. And so this shows that we've had a very dry year with our fuel last year. The green line is 2020. Okay, so we've got May 1 over here. We've got the end of October over here. The green line is 2020. So you can see starting out with that decent snowfall. The gray line is normal fuel moisture for these large fuels. Started out pretty normal, and then pretty quickly going into June, trended below normal, kind of bounced around. The blue line is the record minimum. So you can see here in late August, those 1,000-hour fuels dipped below the record lowest moisture content. And then later on, as we head into October again, they dropped below that record low. So very dry fuels, record low setting fuels for those 1,000-hour fuels. So that kind of gives you the scale of how dry things really were. So moving on to the East Troublesome Fire. It started, again, this late start, October 14, 2020. That's when we should be putting fires to bed. We should have some snow up in the Rockies by then to help put things down. So instead, this thing started October 14th instead of wrapping up. Wasn't declared contained or over until November 25th. And in between there is when it had some really big growth. Overall, it burned almost 200,000 acres, cost over $15 million to suppress, destroyed 580 structures. For the most part, the areas where it burned through were pretty rural areas, but then the night of its big run, it did get into that Grand Lake Village, a lot of vacation homes and businesses, big summer and winter recreation area there. So it destroyed 580 structures. Sadly, 2 fatalities with that. The day of the big run when those happened, a couple actually got word they chose to stay put and shelter in their home. They had kind of almost like a tornado shelter, a bunker in their basement, and they sheltered in that, but didn't take into account just the heat that was generated by the fire. So really sad deal. They could have gotten out and they did not. The fire jumped the Continental Divide. This is why it's so notorious for us. That's had been in the past considered to be an effective fire break. A mile of alpine tundra and rock, and 1,000 feet additional vertical feet for the fire to go over, but it jumped that. And the Continental Divide there is 12,000 feet at the pass. So, timberline is going to be about 11,000 feet or so. So quite an impressive feat for the fire to loft burning material across the divide and into the Rocky Mountain National Park on the east side. So here's an animation of the fire throughout its lifetime. I should say it ends on November 25th. But you can see a few days there early on. Of course, that's the big jump. You can see that little splotch in the upper right. This is where it made it east of the divide, and then its final run there on the 25th. So that's really where it ended out. So here's the beginning. Here's East Troublesome Creek. For the most part, it stayed pretty well. It was almost, we had people on, we were very aware of it, but it was not misbehaving. It was staying put over there in a more rural area. And then that October 21, 22 time period happened with incredibly dry conditions, and it made its run. So quite a day. And you can see that the day that it was really spreading was something to be a part of. I want to talk a little bit for the non-weather service people. I'm going to imagine we've got a few heads nodding here, some students in the audience. One of the positions in the National Weather Service is an IMET, an incident meteorologist. Those folks provide direct support to fire suppression efforts. So they are embedded with the fire teams. They work with the planning section, the fire behavior analyst, to forecast what the fire is going to do so they can attack it safely and effectively. So it's a really important position we have. Something people don't really know a lot about if you're considering career choices as a student. This is, if you like being outdoors, this might be a good fit for you. They have additional training, survival training, practice fire weather briefings. Some of the survival training is how to shelter using the last ditch fire shelter you carry on your hip. How to, some things about fire behavior, fire weather forecasting tips, 150 fire weather related tasks that actually have to be signed off. Pretty rigorous training with that, but very rewarding. You are face to face with your user. Your feedback is immediate, and lives are on the line. So there really it's just a very important position we have. We did have 2 IMETs assigned to this fire. An IMET was on site with this fire October 14th through November 16th. This is our IMET, Lisa Creederman. She was on the Pine Gulch fire. She supported the East Troublesome fire remotely while the IMET on site was given a break. So pretty active year for incident meteorologists. All right, so decision support services that our local office provided, just kind of in general. When these fires first start, before an IMET gets there, the fire may remain small, and counties or communities will use local resources to try to fight it. Once the fire gets beyond their capacity, or if they see immediately that it's going to grow, they call in the larger resources. And so along with that comes the IMET assignment as well. But until then, the forecast office is issuing what we call spot forecasts. So those are detailed forecasts just for the fire what's the humidity, what's the smoke going to do, all sorts of things like that. So the Boulder office was doing that sometimes twice a day, in constant contact with the people on the ground there. Once the IMET reports on station, that's their fire, their forecast, but there's still a lot of collaboration that goes on with the advent of the chat software and everything. We're able to collaborate much more greatly with the IMETs on site than we have in the past. And so, we're very careful to coordinate our red flag warnings. The local knowledge that we have about the terrain in the areas can help the IMETs with their job. So we're communicating that as well. So we're still providing support to that fire, mostly to the incident meteorologist. And then we have larger partners kind of outside the firefighting effort that we also answer to and support. So while the IMET is concentrating just on that fire, we're talking to the state and county emergency managers. We were doing daily briefs with the state, the county emergency managers for like evacuations, that sort of thing. The Department of Transportation got interested because they've got state and federal highways going through the area. So we were talking to Colorado DOT to give them a kind of a rough overview of what the fire was going to do, where the smoke was going to go, so they knew what to do with road closures and that sort of thing. And then a big thing, probably we were responsible for a lot of nice red sunsets in Iowa, where the air quality and smoke forecast, the HER model, the smoke forecast from that has been a hit. We were posting that on social media, loops of that all the time. Really helpful to everybody to understand, where's the smoke coming from that I'm seeing. People get pretty nervous about it when all of a sudden they see smoke. Is that from a fire in California, or is that from a fire that's just over the ridgeline coming my way? So the ability to show the source of smoke, where it's going to go, a lot of air quality issues along with this as well. So that's come up to be a big thing, and the HER smoke has been a huge help to us. All right, so now let's talk about the day of explosive growth on Wednesday, October 21. So yeah, it underwent explosive growth on that 21st. 19,000 acres the evening of the 20th, Tuesday evening, to over 125,000 acres late on the 21st. So just tremendous growth going west to east. And this picture is an example of what that beetle kill forest looks like. So a lot of standing timber, a lot of fine fuels on that. So a good ladder for the fire to climb up into the tops of the trees, and then it's racing along in the crowns and the upper parts of the forest. And when the wind can really pick that up and move it. So just a very, very fast fire, and burning those large fuels as well. So we had wind gusts. We had a red flag warning out for winds above 25 miles an hour is the criteria, and humidity levels 15% or lower. So that day, we did have 30, 40 mile an hour winds, but then the fire itself induced wind gusts up to 50 to 70 miles an hour from the southwest with that main fire surge. The smoke plume grew and tapped into 500 millibar winds and brought them down. We actually had the smoke plume collapse like a collapsing thunderstorm, and produce a lot of wind damage as well in the forest. So just quite an event. A lot of questions if we did or did not have a fire tornado with this. It doesn't appear that we did. Talking to the IMET on site, he was able to get out and look at the damage. And the pictures I've seen, most everything was blown down west to east. I did see one picture aerial shot with trees kind of laying every which way. So it's kind of hard to tell, but for the most part, it looks like everything was straight line wind damage out of this. But just an impressive day. Humidity levels around 15%. But folks, this was at night in October in the Colorado Rockies. 10,000 foot elevation or so. It's just an unbelievable thing that happened that day. So this is from 0400 on 10/22. So that's 10 p.m. That night of the 21st. So let's see. So just get your bearings here. This is the county line. Oops. I gave away my teaser there. So here's the county line, also the Continental Divide. This is Grand County over here Larimer County up here, and the white boundaries are the county lines. Red lines are the roads. So this one here is Trail Ridge Road. We're going to talk about that a little bit more. This goes through Rocky Mountain National Park up over the divide, comes down north into Grand Lake. Here is, actually Grand Lake is right here, the village. The fire area was mostly up in here. So here's where the fire started. This is the Troublesome Creek here. And really, one thing to note about this county is there are 3 ways in and out of this county. So from a management standpoint, decision support, you know, that they don't have a lot of options for evacuation. So when this fire started to run, you know, the fire is here, so you can't really send people along this road. The south way out is only about it. The Williams Fork fire was down in this area on the other side of a ridge. Didn't really threaten Highway 34 here, but for the most part, you know, it's right in here. They did allow, Trail Ridge Road was closed as the fire was making its run. They didn't want people driving in here, but they actually opened it up for evacuees from the north to get out to the north. So tough part from an emergency management standpoint, public safety, how to get people out of this area, which is, you know, we've heard that in some of the Western fires too, where folks got in trouble. It's really amazing to me. We're very fortunate that as tragic as it was, there was only 2 lives lost. This is the heat signature then from 10 p.m. This is the GO 16 RGB fire temperature. A little bit of parallax with this, you know, because we're sampling maybe the smoke plume, but there shouldn't be too much because, you know, the fire's on the ground, so there ought not to be a little bit of parallax. But if there is, this signature might be shifted a little bit north and west of the actual location. But I don't think there would be a lot of parallax. But what I want to show is right here then this RAWS site, a gust to 59 knots. 67 was the temperature and the dew point in the single digits. And even away from the fire, still, you know, 54/6, gust to 29. Even on the east side of the divide, some downsloping going on, a little bit of warming, but temperatures in the 50s, and a west wind, and still gusting pretty well. So just quite a night. It was something to listen to the radio traffic, you know, through Broadcastify, to hear the dispatch and the firefighters as this thing moved, to hear what was going on. So this next set of slides is the fire growth from 22 UTC. So yeah, about 4 p.m. And then we'll just take it hour by hour and watch it grow. So again, you know, a pretty dry day. It was already pretty active. Wind gusts here on the western flank of the fire, 26 knots, 16 knots, and a few of the hot spots there. Going forward, 23Z, 0Z, and then again, this is 7 p.m. at night in the Rockies. We should be cooling down. Wind gust 32 now, 50/8. 58/14, just very warm, very dry for an evening in the Colorado Rockies. Step forward a few more. So now we're back at 3Z. Here's 4Z that I showed in that previous one. So just a tremendous movement of the heat of that fire. You know, and going back to the radio traffic with this, listening to the fire crew chiefs, the captains. One of them was posted up in Grand Lake Village as this thing was coming in, you know, and the decisions they're making of what neighborhoods to try to continue to fight, what ones to let it go. And then when they realized they couldn't do any more and get out now, the traffic on, you know, what crews were safe, what weren't, who was accounted for, the crew chief or the captain that stayed in Grand Lake until he knew all his people were out, and then they were the last ones out. So pretty powerful stuff to listen to that night. Yeah, and then going on to 5D, 6C. Finally, it calms down a little bit. But, you know, there's still movement. It's still heading towards the divide. And then the western flank there flares up again there in the middle of the night, midnight, 1 a.m. And this will take us up until the very early morning. So still all night long, you know, a really good heat signature here in the northwest part of the fire now. This area is pretty well uninhabited. You can't say that entirely. You know, there are homes, vacation cabins, ranches scattered all through that area. but certainly the most dense population area is around Grand Lake. All right. So that day, our immediate decision support services, again, the red flag warning was in effect. We had winds, gust forecast of 45 miles an hour, and we saw that happen. Forecasting relative humidity as low as 11%. We initially issued that at 3:35 p.m. on the 20th, so the day before. So a lot of lead time, letting the locals and and that was also coordinated with the IMET. The conditions were going to get very bad on the 21st. We also did 2 what we call civil emergency message (CEMs) to evade the evacuation notification. We do those in collaboration with the counties, with the alerting authority. We don't do those. We don't make the call to evacuate. That's done by the local folks. We can help amplify that message. It was a tough night. We called, actually, I was working at home. Forecaster Bob Clylo was on. He called me and said, we've got to do something. I can't get a hold of anybody. We had an emergency manager in this county that I had worked with all of summer, who all of a sudden was not working there a week or 2 before this flared up. So they had no emergency manager in position. They had a emergency management specialist that they had just hired, excuse me, that I hadn't known yet. And so we didn't have this process nailed down very well. Very, very new people on the job. So I was able to get through and call and kind of offer the CEM. I will just say that we probably didn't follow policy to the letter, but we did what we had to do. We got the messaging out, and we did the civil emergency messages. That carries on weather radio, so anybody with a weather radio tone alert can hear it. We use the language that was right from the language that was the Grand County Sheriff was posting. So this is just copied and pasted into the CEM. But we were doing everything we could on our end to amplify the message for evacuations. And so here's the go south on Highway 34. At one point, then they opened up both lanes of Highway 34, yeah. So it was we were doing everything we could. Again, for you Iowa folks, grab these from the IAM. Wanted to give a shout out to that fantastic service to be able to go back and find Weather Service text products very easily. So the CEMs were a big part, and then social media. We were very active on social media that night, talking about what it's doing. East Troublesome Fire. We mentioned the evacuations, leave the area now, where to go for the official evacuation notices, throwing on these heat signatures. Even if you don't know what satellite is, you see a big splotch like this or this big red and yellow stain, it's going to get your attention. So a few more of our social media posts, evacuation again, evacuate now, and then we retweeted Grand County, what they've been doing, and just on and on. Really trying to amplify the message of the local folks. And at this point, everybody just needed to be leaving. So the good news is they got everybody out, again, except for those 2 fatalities. But even on that radio traffic, you'd hear, there may be a couple of loggers in a pickup truck, trapped by a downed tree on this road. So much uncertainty about what was going on. It was a couple of days before we really found out what the impacts were going to be. All right, on the west side, I'm going to speed up here a little bit because I know I'm getting close to being out of time. The Rocky Mountain National Park actually spills over to the western side of the divide. And so this is some of their area near where they had some facilities, the Comanche Valley. And then this is the western entrance to the park. So it took a tough hit. They had some historic structures that burned as well. But again, none of their people were injured or hurt. So that's the good news from there. So again, combination of the wind and the heat from the fire causing a lot of damage there. This is what a lot of the aftermath looks like. All these trees, you can see them pretty much bent in the same direction. But you can just imagine what the heat and the force of the wind was as that fire came through. And you can see that the burned soils, the hydrophobic soils, that's the gift that keeps on giving for us after the wildfires. All right, now the 22nd, when the fire jumped the Continental Divide. So we're picking up now that morning. So the previous loop I had, went up until about 11Z, 5 a.m. This takes it on from 5 a.m. to 7 a.m. So the next morning after that happened, my MIC, Jennifer Stark, and I came into the office early just in case there was any kind of aftermath. And we're on there with the day shift that also reported. And we're watching this, and all of a sudden you see that little pop there east of the divide, where before we'd seen this, and then right around 12Z, 6 a.m., we see this little jump here. Took us a little bit to get our bearings, and we're talking about parallax, and then we realized this fire is probably on the east side of the divide. It's jumped the fire break. And so that got our attention, and that's kind of how we spent the morning then. So again, the GOES East satellite, the fire detection capability. Again, this is the RGB fire temperature, but the other fire product showed it as well. The infrared also. So this is where it made the jump. Again, here's Grand Lake, the village, the lake itself. 34, that evacuation route. As it goes north, it becomes Trail Ridge Road. That's here, Trail Ridge, and this is Trail Ridge as well. So remember, the heat signature, that fire actually came in here, split this area in half. So that's when they started sending some evacuees north on 34, down Trail Ridge Road, or south. And then it pushed up over here. This is Sprague Pass right here. And so this is the area that it jumped, and then down into the Spruce Creek drainage. And you can see it's pretty much a straight line right into Estes Park, a downhill run once it makes that jump. So this was pretty scary stuff, that it made that jump in the middle of the night, ignited somewhere in here, and we weren't really sure. And so we started making some calls to Larimer County Emergency Management, to the dispatch, and got in touch with the Rocky Mountain National Park dispatch. Got a little animation here of what it looked like going over the divide. So again, a pretty large jump there over alpine tundra, rock, nothing to burn there, and then made it down into this area, and this is where it caught and took off. So pretty impressive. This is the area again. For Rocky Mountain National Park person gave me this picture. You can see the blackened area here. So this is where it started. So something, a burning ember, the way the winds were going, it could have been a tree trunk, flew up over here, landed down here, and ignited the fire. Just pretty impressive. So this Mike Llewellyn was the one we were talking to. So we made the initial call to dispatch, very incredulous, you've got to be kidding kind of response. They were in cool air. They were kind of socked in on the east side down lower, so they couldn't get eyes on the fire immediately. The winds are still roaring over the top. Couldn't fly helicopters, couldn't get aircraft up there, for the infrared heat signature. So a lot of uncertainty, and we weren't even certain. With the parallax, we weren't sure if the fire had jumped, but we were confident enough to felt like we needed to call, and sure enough, it did go over there. So. Yeah, this is right about 7 a.m. We gave them a call. They said, "You're kidding." By 10 o'clock, they did have eyes on the fire, and that's all wilderness area too, so it's not like you can drive up to it. They evacuated the park, and think about all the hikers, the recreationists out there just on the trail. They're out there to get away from things, and you got to go find those folks and get them back. They were able to recall all the hikers. They closed roads, kicked people out of campgrounds, accounted for everybody. And even down in Estes Park, before 10 o'clock, they started the evacuation, knowing, knowing there really wasn't anything to stop this fire as it moved east. And then this is that area on the east side, the aftermath of what it looked like. Talking to Mike, he said that night he got up on Trail Ridge Road and looked down into that valley where it was burning, and he said it was like something out of Lord of the Rings. He said he was looking into Mordor, just this pit of fire burning down there even at night, the night of the 22nd. But they were socked in. They had a hard time getting eyes on the fire that morning, but it's still pretty impressive. They got somebody up into that rugged terrain by 10 o'clock to see that. So this is the morning after. Again, very warm, very dry, 58. These are the relative humidities now. So 16% RH in Grand Lake. So, up in this area that morning, the the fire still burning in its main burning area. I guess if any good thing, it's already burned everything over here in the population center, so it can't do much more damage. But over here on the east side, we've got right around freezing, low 30s, and again, these are the RHs, so 82% in Estes Park, 86%, 94%. So we're socked in. Luckily, about that same time, we had a cold front come in on the east side of the divide and piled up cool, cold, moist air against there. So this is a Modus Aqua image from the 22nd. Here's the East Troublesome Fire, the smoke plume coming out. This is the Rocky Mountain National Park area. Long's Peak is on the south side of the park, so that's kind of a good anchor reference point. Continental Divide up here. So the timing of this cold front saved the town of Estes Park, I have no doubt. They were socked in with east winds, high RH, and so that kept the fire up here for a day, so it could not advance further east. Here's a view from the Alpine Visitor Center on Trail Ridge Road, looking back down the valley, so you can see the cool air looking back. This is a different valley than what the fire was in. The fire was over this ridge, but still you can see what the fire was running into. That kind of humidity really helped things out, kept it from spreading that day. Meanwhile, in Grand County, of course, it's still hot and dry. The fire continues on. They're still concerned with that. Still extreme fire activity on that East Troublesome Fire. All right, so then the final push. Again, red flag warning day. The winds forecast to come up. We again got out ahead of it and recognized, actually had it from 7 o'clock the night of the 23rd through the 24th with the red flag warning for that whole area. So our social media posts, everything really pushing that out. So we knew it was going to be another big day. And this was the day when it made its push towards Estes Park. So we were all over it again with social media. At this point, the IMETs are on it. All the locals know. So it's down to the boots on the ground fighting the fire. Not a lot we can do from a tactical standpoint, but the fire continues to move on east. Evacuations on the western side of Estes Park. So this is the final fire boundary. That's where it reached on the 24th. Made a run down into this area. This area really flattens out. It's got a few creeks around. It's a little boggy, but it's very close, just a mile or two from all these little dots are population, homes, residences, businesses, buildings right in its path. So very close to Estes Park. They pretty much evacuated the whole city by then. The good thing was, and I think the difference was Rocky Mountain National Park, there's nobody living in the park. It's all federal land, so they're able to manage that. So they had done a lot of timber clearing. They hadn't cleared out everything in advance of the fire, but they had previous work that they'd done, with controlled burns. So they had areas they could anchor their fire lines to. So they were able to try to divert the fire around features and fight it on their own terms. The fire also burned through in this Fern Creek area. There'd been a burn there a few years prior, so that was burned through already, not as much available fuel. So good forest management there. Where that's not possible, Grand County is, it's individual plots of land, just harder to do that sort of thing. Rocky Mountain National Park had the resources. So they were able to successfully fight the fire, kind of held it off here. They had some good breaks with the roads and things as well, but still got very close to Estes Park. But really, the other thing that saved them was the snow coming in. It was a foot race between the fire and snow. So finally, on October 24th, we had a fire season-ending snowfall that came in that night, and transitioning. So we were forecasting red flag conditions and a winter storm warning at the same time. So pretty interesting few days for us there in the office. And then that afternoon, 1:50 p.m., you can see that tweet talking about the radar echoes starting to come in. So, just help was on the way. And meanwhile, while this was happening, also the Cameron Peak Fire was making its run. It got down just into the foothills, and so it was quite an alarming sight for the folks in Fort Collins and Loveland as well, and just pouring smoke into those communities. And then here's our snowfall forecast. Turned out to be really pretty good. We had 9 inches for Estes Park for late Saturday into Sunday morning. Snow came, put the fire down. But even for days afterwards, there were still hot spots in there, even though you'd think that, that much snow with an inch of water content would be enough just to put the fire out. But actually there were hot spots that remained. Fire crews kept working, trying to tamp those down. But then the snowfall on the ground also interferes with their work. So it makes it harder to fight the fire. But this was late enough that this snowpack remained, and that was the end of it. So this is from somebody in Rocky Mountain National Park. We got her to measure the snowfall. They had 15 inches at the Beaver Meadows Visitor Center, which was like a mile and a half away from the final fire line. Longest day ever. Storm was a blessing. And then to wrap up, again, the gift that keeps on giving. So now our DSS is shifted to burn scar flooding, flash flooding, the threat for debris flows, working with our partners to work that problem over the next 5 years. So with that, I'm done. Thanks for the opportunity. Hopefully I didn't go over too much. Yeah, it looks pretty good. If we have time for questions, I'm happy to talk.
Yeah, we had one question. Fantastic talk, Greg. That's really just amazing stuff. There was one question from Barb Reppin. Why didn't Colorado have a controlled burn of the dead trees to prevent fires? I know you mentioned a little bit of fire prevention from that park and Rocky Mountain National Park, excuse me. But I don't know if you have another answer on that one. But
yeah. The problem is so vast. There's just so much of it that needs to be taken care of. There are houses, homes, businesses interspersed in there, so it's not like, if you set the whole thing on fire, we get what we got here.
Right.
Some of the areas, that is ongoing, and actually Cameron Peak Fire, so they cut in the summer and pile it up and then burn in the winter when there's snow on the ground. And Cameron Peak Fire actually burned some of those piles they were going to burn this winter. So there is work ongoing, but the problem is so vast, and the resources are so limited. You just, there's no way to do it all.
Yeah, it's thankfully they cut it off before it got to Estes Park. I know I've visited Rocky Mountain National Park many times. It's a gorgeous park. So, well, thank you again for your time. We appreciate your willingness to present today. Thank you very much. Very good stuff. All right, our next talk. Thank you, Roger, for switching slots here. It's unfortunate James Spann had to cancel, but understandably. So he's going to be talking about the NWS Lake Charles Decision Support Services before, during, and after Hurricane Laura. So go ahead and take it away.
All right. Thank you, Kenny. Our opening slide here is just showing infrared satellite imagery of the eye as it's moving inland across southwest Louisiana.
We unfortunately don't have your slide.
Yeah, you need to share.
Oh, I'm sorry.
Yeah, you're fine. You weren't part of the testing this morning, so.
Okay. What do I need to be clicking on?
It should be.
There should be a share screen button in the lower middle part of your screen in the Zoom window.
Well, let me find it. I don't see a share button on the computer.
There's a option up at the top. It's a view option. So if you click on that, speaker view, maybe try that, and then it should be at the bottom. It kind of pops up if you scroll down.
Okay, is this in the actual Zoom meeting box?
Yes.
Yes.
All right. All I'm seeing is share screen. All right.
There we go.
All right.
Awesome.
You see my screen now?
Yes.
Thank you.
All right. Sorry
Fantastic.
about that.
That's okay.
All right. So opening slide here is just the infrared satellite imagery of Laura as it's making landfall. Picture on the right is the one of the last pictures of the radar before the Lake Charles radar was destroyed by the eye wall of Hurricane Laura. So just to kind of put things in perspective, since I'm talking to people up north in the Iowa area, and by the way, there's a small town down here near Lake Charles called Iowa. So if I say it wrong sometimes, I apologize. But Lake Charles down the Gulf Coast, we're between Houston and New Orleans. The map on the left here shows our forecast area. We got 6 counties in Texas and 16 parishes in Louisiana. So we're going to talk about things that happened before, during, and after from the perspective of the DSS. So the first part of it here, for the before perspective, our biggest problem associated with Laura coming in towards us was that wasn't actually our main priority. We actually had another system. Marco was forecasted to actually come to our area first. And anytime you have 2 systems coming into the same area, there's going to be confusion from a messaging standpoint. This is a graphic that I made. I was not happy to make this slide. Local officials wanted to have an overlay of both tropical systems on the same map. I was like, it's going to be confusing to look at. They're like, well, we want to see it that way. And so, outlined here in yellow, the 12-hour, 6-hour, 12-hour forecast for Marco. The ones in red there was for Laura, and they were happy with it. I wasn't, but that's what they wanted, and so that's what they got. The whole thing started 11 days before it hits us. It was just a tropical wave coming off of Africa. The 20% area that's outlined there, the little X, yellow X to the right, that's near Africa, that's Laura. 11 days before it hits my area near the Texas-Louisiana state line. And the 30% area out in front of it, forecasted to come into the Caribbean, that's actually Marco. So at this stage of the game, no armchair quarterbacking. We weren't doing emails or notifying anyone of anything, because at this stage of the game, we didn't know if anything was even going to come in the Gulf. Typically, we start emails and notifications to our partners when there's actually a threat into the Gulf of Mexico, because we know that if something's coming in the Gulf, there's a chance it could come to us. Even though we don't know for sure it's coming to us, that's when we typically start it up. So 11 days out, we had not started it. The next day, 10 days out, the probabilities increased for both systems. Still not talking about it yet from our office perspective. 9 days out, the future Laura bumps up to 90% probability. 8 days out, both systems, Marco and Laura, future Marco and future Laura, are both up in the high probability range. And finally, 7 days out, future Laura is now Tropical Depression 13. And so we're finally able now to start maybe showing some idea of where we're expecting systems to be coming into the Gulf. So here we are looking on Thursday, August 20th. The storm makes landfall in our area early Thursday morning, August 27th. So this is 7 days out before we get hit by Laura. The big picture on the right is the picture of the Laura track. It's not Laura yet, it's Tropical Depression 13. It's forecasted to come in, skim somewhere along the Florida coast, potentially as a hurricane, and then come into the Eastern Gulf. That wasn't the thing that we were focused on. We were focused on the graphic there on your bottom left, Tropical Storm Marco potential. Marco was not, it was Tropical Depression 14, but it was forecasted to come in the Gulf by Sunday and then make landfall by the middle of the week, somewhere in my forecast area. And by the next day, on Friday the 21st, it showed it as Marco being potentially a hurricane coming into my area. So that's the message, Marco, 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 because we're advertising a Category 1 hurricane coming into our area by late Tuesday evening. Meanwhile, Laura on the right side there, you can see the forecast track shifts a little bit further west. And now it's showing a landfall potentially on Wednesday in the Florida Panhandle region. That's Friday, August 21st. Saturday, the 22nd, the Laura forecast track keeps shifting west. So now it's a problem area for me. Meanwhile, Marco's still a problem area as well, still potentially going to become a hurricane before it comes up in my area. So I'm trying to message 2 different tropical systems at the same time, 2 different impacts, timing of impacts can be very confusing for a lot of perspectives. This was on Sunday. Now we're talking about potentially Laura becoming a major hurricane. So that really gets people ramped up. Category 1 hurricane, people probably don't get as excited about down here, but you start talking about Category 3 or stronger, and they do. And you can see by this case here is Sunday the 23rd, 4 days before landfall, they were talking about potentially a Category 3 running into Louisiana. Marco, meanwhile, still was forecast to become a hurricane before it hits Louisiana as well. So 2 systems, 2 potential hurricanes coming into Louisiana within a couple of days of each other. Pretty crazy bad luck, if you ask me. So the problem was Marco weakens. It ends up not becoming a problem at all for Louisiana. It weakens to a tropical depression before it skims southeast Louisiana. But people are remembering our messaging from 2 days before, saying Hurricane Marco, going to be a problem. Laura is going to be to our east. Meanwhile, Laura is forecasted to go further to the west, still potentially a Category 3. So the trick is trying to convince people to, okay, let's forget about Marco. Let's focus now on Laura. And so this is just some screen captures of different TV meteorologists across the area. They also overlaid both systems on the same graphic. To me, it's just a difficult map to look at from the perspective of the public. I got a lot of negative feedback from the public. The emergency managers wanted it. The public did not like these graphics being overlaid on top of each other. So I kept it separate, but I also had to make a graphic for the emergency managers that showed both of them. So this is Tuesday, 2 days before landfall, showing major hurricane Laura coming into the area. Meanwhile, people are still focused on, what about Marco? Well, Marco's not even a tropical system anymore, right? It's a post-tropical cyclone, 30 miles an hour. But does the public or even the emergency managers know what post-tropical cyclone means? I mean, they're still thinking hurricanes come to skim the Louisiana coast. That's not the focus, guys. The focus is going to be on Laura. So it's just a bear to kind of keep people on track of what the messaging was going to be for this event. 16 hours before landfall, the forecast for Laura jumps up to a Category 4 for landfall, which is a big deal, obviously. This is a very ugly slide. Basically, we got 2 columns here, one for Marco, one for Laura, showing the combination of where are we expecting landfall. Marco starts out near the Texas-Louisiana border, switches to Texas, switches back to Louisiana. It changes from Tuesday, Wednesday timeframe to a Tuesday to a Monday, Tuesday timeframe. Starts out as a tropical storm to a Category 1 hurricane, back down to a tropical storm, eventually a tropical depression. So just a messy forecast in terms of keeping people up to date with what's going on. Hey, yesterday we were saying a hurricane, today we're saying a tropical depression. It's real difficult. You think about social media as well. People are looking at everyone's post, whether it's the TV meteorologists, whether it's the National Weather Service. They're seeing all these messages out there, and they may or may not be paying attention to the time that social media post was pushed out there. So one of the things that we do here at Lake Charles, we do say outdated posts, see our latest message on here. It's something I encourage everyone, the TV meteorologists as well, to really be focused on that, so that people aren't looking at an old post on social media that's really not the current story that you want to be pushing out there. The graphic on the right shows Laura starting out as a Category 1 hurricane heading towards Florida for the Monday, Tuesday timeframe, switching to Louisiana for Wednesday, switching to potentially Texas or Louisiana for Wednesday or Thursday, and eventually bumping up to a Category 4. It was within 5 miles an hour of a Category 5, so a pretty phenomenal system to go through. The major hurricane winds extended 70 miles inland, Category 3 wind speeds, 70 miles inland. Category 1 hurricane wind speeds extended 190 miles inland. So this was not just a coastal phenomena, this was a huge Gulf Coast event phenomena that occurred. So what did we do during the event? We evacuated. We evacuated 16 hours before the storm was making landfall. The decision was made kind of a collaborative effort between our office, our regional office. A lot of work's involved when you do have to do an evacuation in terms of getting backup offices to take over your forecast responsibility. When you're dealing with a tropical system, there's a lot of hazards that you're working on, from the water perspective, the storm surge perspective, the rainfall perspective, the wind perspective, a lot of hazards going on. and you just hate to dump that on someone else to do it for you. This was a picture that I took of the office as me and my boss, Andy Patrick, were leaving just before noontime as we were going to go downtown. This is a graphic that shows the forecast at that time that shows how deep the water was potentially going to be across Southwest Louisiana. The red blob on here is over 9 feet above ground level. You can see the star that I put on the map here where our office is located south of Lake Charles. We are actually in that orange to red zone, so anywhere from 6 to 9 foot or more water above ground level. So that's the reason that we had to evacuate the office. It wasn't so much for the wind perspective, although people were nervous about that. We had to evacuate for the surge perspective. Now, on a side note, I've been in this office since 1995, so I've gone through a lot of tropical events. 2005, we had Hurricane Rita, also had the eye wall come over the top of us. We did not evacuate the office. We were not forecasting the storm surge to get into the building, but we went through a category 3 eye wall as we continued operating through that. And we all said that was the stupidest thing we ever did. We changed policy from a regional perspective to let offices evacuate when you have a category 3 or stronger going to be impacting your office directly like that. So here's a picture of me and Andy downtown at the EOC. We were in a 12-story building, and we always recommend don't getting in tall buildings during high wind events because of the damage that can occur to them. We were on the 2nd floor, so we were above the storm surge zone. We knew that the 1st floor could flood, but we're in this building with probably 300 or more people, law enforcement, fire department, EMS, search and rescue, you name it. This is a building chock full of people that were ready to respond to Southwest Louisiana after the storm passed through. And so we hunkered down there in the office. The remainder of our forecast office dispersed to safe locations with our families. So this is where we, for category 3 hurricane strength. And so we felt like we were as good as it's going to get down there in this building. And I guess I should also say, not only was it local officials, we also had state and federal officials here as well. State police was in the building with us. The state DEQ type people were there with us. We have a big hazmat area in our forecast area, specifically Lake Charles and further to our west in the Beaumont, Port Arthur, Orange areas of Texas. So a lot of big refineries in the area. So there's a lot of things that you got to be watching on very carefully in an area that's going to be impacted by a major hurricane like this. We also had federal partners with us. FEMA was actually in the building with us. I want to say there was like 3 to 5 people from FEMA that were here as well to have boots on the ground first thing when the storm passes and they can get out and start pushing the information further up the food chain to get people and resources in here for it after the fact. We had a big problem, and you guys, if you studied, were aware of it back in 2005 with Hurricane Katrina over in Southeast Louisiana, where the federal response was delayed for a variety of reasons. FEMA is very proactive nowadays, where if they know there's going to be a big disaster, weather disaster like a hurricane coming in, they're going to stick people in the area beforehand and hunker down and be ready to get resources into the area from a federal perspective as well. So here's some of the data that I'm using in my briefing. One of my things here, it's just this is during the nighttime hours that the thing made landfall. So, I'm doing infrared satellite imagery with just the hour by hour location of where the system's located. And then I'm showing the radar picture as well, showing, this is what it looks like for the rain bands coming into the area across the region. Got a plot of the winds. That's really the only focus that we were on here. I wasn't showing temperatures or anything like that, but we're showing the wind direction, wind speeds, wind gusts in red on here. So you can see all sorts of data coming in for that. And then finally, the tide levels. A big story of the surge coming into the area as well. We were forecasting all of Lake Charles to go underwater associated with storm surge. And so we were briefing everyone on this is what the tides are doing right now. Now, unfortunately, as you go through a disaster like a hurricane, data starts to fall offline for different reasons. Now, the satellite data, no problem. That stayed up throughout the event. This is 6 o'clock in the morning. You can see the eye of the hurricane is well inland now, but we're still got a 105-mile-an-hour hurricane going through Louisiana. The radar data, we lost the radar data shortly before 1 o'clock. I think it was 12:30 to 1 o'clock when the radar went out. So I need to show radar data to the people what's going on. So I can't show the Lake Charles radar. I can't show Fort Polk, which is 60 miles north of us, because they are tied into our office for the communication perspective. So once comms goes out of my office, we lose 2 radars in the area. So that meant we were resorting to the Houston radar, which is the picture there on the left, and the Slidell radar, New Orleans, Baton Rouge area radar on the right. And so I couldn't use just one radar for the forecast area because of the distance of the radar site from the hurricane itself. It wouldn't necessarily pick up some of the low-level features. So for instance, the picture on the left has a very nice depiction of the eye as it's moving inland across the river in the picture here. The picture on the right shows the rain bands with potentially tornado signatures coming in across my eastern forecast area. That was a better pickup with the Slidell radar. Here's what the observations looks like. You can see a bunch of dropouts, including Lake Charles. The ASOS in Lake Charles was decimated by the winds. We don't know if it was just the wind speeds itself or was it debris flying through the air that impacted the ASOS site, but all of the equipment was lost. We had to rebuild everything after the fact. And it wasn't just Lake Charles, ASOS, it was all the other AWOSs in the area and other weather stations. So boom, you're losing all sorts of weather stations that are really, you kind of need in the middle of an event to say, well, this is what the wind speeds are going on right now. So you can see we have winds recorded on the outside, on the outlier area of where the hurricane's located, 60 miles away, but in the core where it was moving, we didn't have any data. And then finally, still keeping up with the tides or the river levels. You can see here, this is for Lake Charles. We had a dropout for some reason earlier in the system before it made landfall, a gap there, but you see the rapid rise of the water coming into Lake Charles early in the morning on Thursday. All right, so here's some videos of what it was like downtown. The graphic on the left, I'm not sure if the audio comes out very good. I'm hoping you can hear that creaking sound. That creaking sound that you're hearing there is actually the window creaking, trying to pop out. Me and Andy were sitting in this office and I heard this creaking sound and I thought my boss was nervous, like maybe he was rocking in his chair. So I turned around, I was like, are you okay? And he's like, yeah, I'm fine. I was like, well, what are you creaking your chair for? He goes, I'm not. And we were like, what is that creaking sound coming from? And we discovered the window in the office that we were in was doing the creaking sound. By the way, we were in an EOC, 300 people in this building. It's COVID, right? So we're not in a room together. Normally the EOC is just one big room. It's like a big mosh party, I guess you could say, with everyone running around with their heads on fire, so to speak. Everyone's got some emergency that they're working on. We didn't do that for this event. The way it was worked, we all were shuffled into individual offices. So the weather service, we were in this one small office here. FEMA, another small office. The fire departments, everyone was in their own different individual offices. And if you had a question, you could pick up your phone and dial the extension and talk to them. So that's the way we did this during the event. Of course, we had to keep our masks on. We had stuff to keep our hands clean from the perspective of the gel. Picture here in the middle. This is an exterior door on the first floor. And you can probably hear the debris hitting the door. And you may or may not be able to tell, but there's water being pushed around the edge of the door as well. Water was coming into the first floor of the building. The second floor we were at, the windows were creaking. Oh, and did I also say we lost water? 300 people in a building with no water, which means no toilets. 300 people having to use the restroom all at one time, or I should say over several hours. It becomes a really nasty situation quickly. We went from like 12 o'clock, 1 o'clock in the morning when the water went out until we were able to evacuate the building after the winds died down enough around 7 o'clock in the morning. So we were stuck in a yucky situation for 6 hours down there. Also, when the water went out, that also affected the air conditioning units, which were, by the way, on the top of a 12-story building. So we did not have air conditioning. So no air conditioning, we weren't getting cooled off. This is the middle of August or end of August. No water, no way to flush toilets. So it was super, super nasty. Picture on the right, another exterior door with a window that you could actually see out. Now, I didn't show it in this video here. We had storm chasers in the area, and there was a storm chaser right outside that window in their vehicle. The vehicle spun around. It was a small vehicle. It wasn't an SUV. It was a small vehicle, like a compact vehicle. It spun around, got pushed off the road. We were ready to go get them in the building with us, but while we were waving at them, they were just working on getting the car straightened back out, and they drove away. It was pretty incredible to see the storm chasers. While we were hunkered down in the building, storm chasers were driving around outside, checking out all the damage. All right, so now we're switching to the after phase, where this shot here is from my radar. The radar got destroyed, so we're looking east in this picture here. We don't know if the radar dome was just simply destroyed by the wind, or again, if it was from debris. Looking at this picture here, there's a church in the distance here that lost a good section of the roof. We don't know if the roof, you can see the material in the yard between the radar and this building here. We don't know if that came up and impacted the radar dome or how it happened, but we lost a lot of equipment. The picture on the left is our RSOIs to keep track of, help us initiate our upper air. We are an upper air site. The second picture is the upper air station. Got damaged. We lost both of the doors to it. We had to switch from the hydrogen tanks to helium when we finally were able to start up again, because it was too dangerous to use hydrogen without any windows, without any doors, I should set up. The third picture here is how we get the data into AWIPS. Even when we came back in the office, we weren't able to fire back up right away. It took us several weeks because we lost this dish. We got a new dish probably 2 months later. We did eventually get a portable dish to be able to get our AWIP stations back up and running. Here's the before and after shots of the radar. Pretty incredible story. We don't have time to share it all here today, but this radar came back online in 5 months, which to me is pretty phenomenal. To be able to get cranes in the area in the middle of a disaster, to have the crew, the radar rock, National Air Resource rock came in. They removed all the equipment at the top there. They started reinstalling it, and we were back on in 5 months. So pretty incredible story there with those guys. A lot of thank yous for all of our backup offices: Brownsville, Texas, Houston, Texas, New Orleans, the Slidell office. They did our grids and our watch warning advisory products. The Tampa office did our TAFs. We were assisted by Shreveport and Houston in storm surveys. Shreveport did land-based surveys for the wind. Houston helped us out with surveys near the coast for the storm surge. These are the tallies for fatalities in our forecast area. We had 3 from the wind, 0 from surge. And then, the bad part is we had more fatalities after the storm than we did before. 14 from carbon monoxide with our generator running, 7 from the heat, and 7 from accidents. By the way, this is another view of the building that I was in there in the background. Here's what actually happened from the storm surge perspective. You can see a big purple blob on there. That's 14 feet of water above ground level or more, with the dot of the Lake Charles office up there above it. The good news for us was that the storm surge was a little bit further east than what we forecasted. We thought the storm was going to make landfall west of this body of water here. This is a big lake out here. If the storm had made landfall west of that, all this big storm surge value, the 14, 16 foot, even 18 foot storm surge values would have backed up to this lake and come into Lake Charles, including our office. So we just got super lucky. The storm made landfall about 10 to 20 miles further to the east, and it kept the storm surge in a much more rural area of Cameron Parish. These are the winds through 4 different dots to kind of give you a perspective of how far inland we're talking. At the coast, 140, 145 mile an hour wind gusts. In Lake Charles, 135 to 140 mile an hour wind gusts. Further inland, DeRidder, which is 75 miles inland, they had 125 to 130 mile an hour wind gusts. Leesville, 95 miles inland, 115 to 120 mile wind gusts. I mean, category 3 wind gusts, almost 100 miles inland. So pretty phenomenal in terms of these wind speeds that we saw, not just at the coast, it went really far inland. So you put it in perspective, you know, all of us in the office were impacted at our homes from these incredible wind speeds. Here's the rainfall. The rainfall was not the big story, but you do see areas of 6 to 10 inches, 8 to 10 inches, and even some white spots on there of over 10 inches of rain. And then unfortunately, we got to do it all over again. 43 days later, we had Hurricane Delta come into the area. This was the storm surge that occurred with Delta. Here's the wind speeds. The office, we had very close to 100-mile wind gusts at the office again. And the rainfall was a little bit higher values as well in the area. So it was a big deal. We're still recovering. A lot of people in the office are working hard while their homes are being rebuilt. This is actually my house. Part of the roof got pulled off. That was one of my daughter's bedrooms there. The roof has been repaired, but the interior work is still to be done here. I have not gotten money from my insurance company. Here we are, however many months after the fact. I'm still waiting on money from my insurance company, and I'm not alone. I'm just one of umpteen people here, tens of thousands of people here in the Lake Charles area that haven't been paid by their insurance companies. I would say in the area here, where probably 50% people have their roofs fixed, the other 50% are tarped. So we still got a lot of work to go in the area. In the office, there's me and another guy that have the most serious damage that we're still in the rebuilding process of the houses. So for more information, you can see a lot of the weather data on our LoRa website. And also, of course, you can contact me. That's my email address there, as well as the phone number with my extension. When I'm not in the office, it forwards to my cell phone. So I don't mind people contacting me through email or phone calls. You can contact me. We can talk more about what happened. A lot more of the DSS. This is a briefing that we had condensed into a 35-minute presentation. This could probably be an hour presentation easily, but I appreciate everyone listening to the presentation today.
Excellent. Thank you, Roger, and appreciate your willingness to switch time slots today. Let's see if there's another question here from Barbara Reppin. Says, after this disaster, did you make changes to avoid damages in office, or will this happen again, etc. at the radar tower? Did your local EM office make policy changes for evacuation procedures?
Yeah, that's a good question. In terms of the office, we are, 12 feet above sea level. I mean, we need to move the office. And I'm a WCM. I'm not a higher level person in the federal government. So I mean, that's for higher ups to figure out to get us out of the storm surge zone. I know that the Slidell office is moving probably within the next year or two to get to a better location. Our office is vulnerable as well. Hopefully they'll have us on the list to move to a safer location from the surge perspective. From the wind perspective, the radar towers are designed, I want to say, to like 125 miles an hour. That's for anywhere, all of our radars all across the country. So that's what we got to work with. Puerto Rico lost their radar from a hurricane system a couple of years ago. One of the stations out in the Pacific lost one. So in terms of hurricane perspective, we've lost 3 over the years in the last, 30 years now. So they say that they're not, there's nothing, at least in the short term, to make that radar any more sturdy than what it was. The tower itself held up great. It's just the dome that failed on us.
Yeah, there's really nothing you could do about the debris too flying around too. That's kind of hard to protect against that. So,
and the EOC downtown, those guys, this was their first event going through it. For Hurricane Rita back in 2005, they evacuated. So they made this hardened building for them to stay in. They felt good about it. They obviously need to do something differently with the air conditioning unit being on a roof of a 12-story building. That's not the way for it to operate. So they're looking at what to do differently for future events. The building itself held up pretty well, other than the fact that it was freaking us out with the creaking sounds. And I didn't mention also the whole building was swaying, even though it's only 12 stories. the whole building, when you're sitting at your desk, you felt nauseous because the things on the desk were rolling around while you're working. I mean, it was a pretty surreal event to go through, and not something that you want to go through for sure.
And it looks like we have one more question here from Alan Curtis. Regarding the provided DSS, is there anything you would change if this were to occur again?
Well, this is the first time we had two tropical systems coming in at the same time. So,
right.
I try to keep the two systems separate, and that's how I was doing my briefing starting out. But I got too much feedback from the EMs that said, we want to have it overlaid on top of each other. So, you got to do what the customers want. And so we switched up for that. Personally, I didn't like that. And, like I said, the feedback that I got from the public was it was terrible. So that's probably a question for the social scientists down the road to see, what is the best way to message multiple tropical systems, not just multiple hazards, wind, surge, rainfall, tornadoes, but multiple tropical systems into the same area. How do you message that out there?
Okay. Well, I think that's enough time we got. I appreciate, again, your time today, and great talk, fantastic stuff. So we will move on to our next talk, which is Chad Crilly, a broadcast forecaster from KRCG 13 in Jefferson City, and the meteorology behind the Joplin tornado. And he works with one of my good buddies, Zach Paul, from down there.
Hey guys. Yeah, hey, good morning. How are you? So
Fantastic.
I'm having some issues getting my camera working here on Zoom.
Okay.
So I think I'm still able to share my screen if worse
Yeah,
comes
we
to
can hear you
worse,
good
but,
if you just share your screen.
Perfect. So then we'll go from there. Let me go ahead and share it. Just give me just a second. And are you guys able to see that okay?
Yes, there we go. Looks good.
All right, perfect. So yeah, I want to chat with you guys a little bit about the meteorology behind the Joplin tornado, and then also kind of my own personal experience. And I'll go into a little bit about both. Obviously, we don't have time to go into everything, but I think I can kind of get a good grasp and touch on both those topics a little bit. So first, just a bit about me. Right now, I'm a forecaster over at KRCG 13, which is the Columbia Jefferson City market in Missouri, and it is a CBS affiliate. However, I'm not originally from Missouri. I was born and raised out in San Diego, California, about 20 minutes to the north in a small town called Encinitas, and it's a beach city. I'm one of those people who my interest in meteorology and in weather started when I was about 3 years old. And so instead of watching cartoons or playing video games, I was always super fascinated by either watching the Weather Channel or watching the local meteorologist on TV. I think it was something that I was born with. And as I kind of got older, by the time I was 6 or 7, I realized that I could make that passion into a career. So I decided that was something that I wanted to pursue, and definitely something I wanted to do. And I was lucky enough to have teachers throughout elementary school who fostered that passion and let me get up every single morning in front of my class and in front of my school and give the weather. So I just loved it. And you can see a picture on the right. That's me. I was young. I was probably about 7 years old with one of the local meteorologists who let me come down and watch his live shot in downtown San Diego. So that kind of leads
Just
me
a quick,
yes.
Just a quick little thing. Would you be able to present to have a full screen view so that it can show up a little bit larger across the stream? Excellent.
Absolutely. Let's see. I just want to make.
Yep, just on the right side of that bar. Yep, or there.
Okay, there we go.
Excellent.
So that kind of leads me into a little bit about how I ended up in Joplin on May 22nd, 2011. So at 11 years old, I was in middle school. I was in 7th grade. And for somebody who's fascinated and interested by weather, San Diego's weather had become a little bit boring. Anybody who spent time there knows that a lot of the year it's sunny and 71. You'll get the marine layer that'll come in and give you a little clouds and drizzle and a coastal eddy, but that's about it. And sometimes during the winter we'll get some rain. But overall, San Diego's weather was boring. And so I wanted to experience something different and get a firsthand look at some inclement weather. And so I emailed a number of TV meteorologists across the Midwest and asked them, hey, can I come out and shadow you, see how you do your work in an area that's susceptible to inclement weather? And one of those meteorologists that I emailed was Doug Hetty, and he is the chief over at KOAM TV. The station itself is in Pittsburgh, Kansas, but it serves the 4 states region. So Southwest Missouri, Southeast Kansas, Northeast Oklahoma, and Northwest Arkansas. And so out of all the people I emailed, he was the one who got back to me right away. And this is in early April of 2011. And he said, hey, yeah, come on out. I'd love to have you visit. I can show you how things work. And with any luck, you'll get a couple of springtime thunderstorms that you can see. And so I told my mom that this guy had responded back, and he invited me out, and she said, absolutely. And both my parents are always super supportive of my passion. And so we decided, hey, let's pick some dates. And so we looked at the calendar, kind of correlated with his schedule and with my school schedule. We chose May the 22nd through the 24th for that shadowing experience. And so all the flights were booked, and we got the hotel booked. And so we took off for Joplin there on early in the morning of May 22nd. Our flight left San Diego at about 6 a.m. So I'm going to touch now on the weather setup, and then we'll go back a little bit to my own experience. But obviously 2011 was a super volatile year for severe weather across the country, especially in April. Obviously, you had, the April 27th so-called super outbreak, a lot of outbreaks before that, too, across the South and the Southeast. But the large-scale pattern got kind of quiet in early May, and there wasn't a ton going on for the first couple of weeks. However, as we got towards the middle and end of May, things kind of started happening again. A more active pattern took place. So there was, specifically there on May 22nd, there was a slow-moving low across the northern plains, pretty strong cold front that extended down to the south. And later that day, the front was expected to intersect with the dry line. Specifically, from a regional perspective, the storms in Southwest Missouri were expected to develop along a boundary from the previous night's storms. So that's how things looked. And in anticipation of this, the Storm Prediction Center issues a moderate risk 13Z on day one outlook. It did feature a 10% hatch for tornadoes. Despite this, early that day, it looked like hail was still going to be the biggest issue, at least across the 4 states region. And so there's the outlook from SPC. You can see the moderate risk there extends from the Great Lakes area down through central Illinois, central Missouri to southwest Missouri. And on the right-hand side, that's the tornado probability legend. And you can see the hatch there for the 10%, and 15% is obviously where some of the better ingredients were. So it looked significant early that day, but if there was to be a big tornado, it appeared it may have been a little bit further northeast. But still, some of the ingredients were kind of coming together, and the atmosphere was becoming primed for storms. And early that Sunday morning, there was a cap in place. But by the lunchtime hour, temperatures in southwest Missouri were the low 80s, and dew points had exceeded 70 degrees. So you kind of get what's happening as this cap is starting to erode. And now we're getting to the point where we don't have storms yet, but they're going to form shortly. So the Storm Prediction Center issues tornado watch number 325, which was valid from 1:30 until 9 o'clock. And you can see it there. So it encompasses a large part of southwest Missouri, eastern slice of Oklahoma, parts of northwest Arkansas, and southeast Kansas. The other thing of note is you can see that there are other tornado watch boxes that extend further up to the north, but specifically for this one, in the hazard category, you can see that for tornadoes, it was high. So we're now getting to the point where it does look like there are going to be tornadoes somewhere in that watch. And there's also a moderate risk for EF2 tornadoes, as well as severe wind. And then on the right-hand side, you could see that, as I pointed out, it still looked like hail was going to be an issue too, with both a high probability of severe hail and 2-inch in diameter plus hail. So that's how things were looking. So by this point right there, after the watch was issued, NWA Springfield launches a special weather balloon You can see their findings on the right, which basically indicated that instability was continuing to increase across much of the 4 states area. Wind shear, which had previously been unimpressive earlier in the day, was now enhanced by a low-level jet, and a secondary low developed. And so winds were now gusting out of the southeast. So things are becoming more favorable. The ingredients are coming together for a pretty significant severe weather event across southwest Missouri. Obviously, still at this point, nobody knew or could have imagined what was to come yet ahead of that storm. So this is just a general timeline here as the situation kind of becomes more serious. So we have the tornado watch in place. The special weather balloon was launched. Now we're just waiting for storms to develop here that afternoon on Sunday, the 22nd. And by 5 o'clock, sure enough, we get a supercell thunderstorm that develops near Baxter Springs, Kansas, which is in the southeast corner of Kansas there. By 5:09, the National Weather Service issues a tornado warning for western Jasper County, which is the county that Joplin's in. However, at this particular time, that tornado warning, which goes until 6 o'clock, only included the northeast part of Joplin. And the reason why is a storm movement, which was coming out of eastern Kansas, was moving almost directly due east at that point. So it looked like most of Joplin would be missed, and that watch polygon, or excuse me, the warning polygon was in effect, and for good reason, that part of northeast Joplin. However, by 5:11, we're seeing rotation that's beginning to increase with that cell, and something interesting kind of starts to happen as we're watching other cells that are developing across southeast Kansas and northeast Oklahoma. They're basically feeding into this Joplin cell, so they're merging into it. And so now you have just this big blob HP mess of a supercell thunderstorm that's coming pretty much straight line for Joplin. And so by 5:17, a new tornado warning is issued for southwest Jasper County. This now does include the city of Joplin until 6 o'clock. And so there's now the warning in place. You have some lead time. And by 5:34, there you go. A tornado touches down on the southwest side of Joplin. And as soon as that thing touched down, rapid intensification. I mean, almost immediately do you get some very serious intensification with that storm. And by 5:38, the sirens sound a second time as damage begins. And that's something we learned later, is that second sounding of the sirens would save a lot of lives in Joplin as that storm came through. So that's kind of the picture of what's happening from an atmospheric perspective and from a radar perspective. But now back to my story a little bit. So I let you know we took off from San Diego early that morning. I was aware that there was some severe weather looming. So naturally, I was excited to see some storms. And I'll go back to the fact that I had no idea what was coming. But we landed in Joplin there about 2 o'clock in the afternoon. And we rented our car. And after that point, we went and checked into our hotel, which was at the Hilton Garden Inn in Joplin. And we decided, hey, let's go grab some dinner. And there's a lot of places that we could have chose from. And it was a decision that ultimately probably saved our lives. So we went to Applebee's for dinner, my mom and myself, instead of going to some other places that unfortunately did not fare as well and had some fatalities. But we chose Applebee's for dinner, and we're sitting down. As a weather enthusiast, I'm noticing these thunderstorms that are starting to develop on radar. And I have my radar scope on my phone. I noticed that first tornado warning goes off the first time the sirens go off. Instinctually, I went outside. I started recording myself. And that's what you can see on the right-hand side of your screen. And that picture is facing due south. However, that excitement that I kind of felt of, hey, I'm going to experience some interesting and some active weather really quickly turned into fear. Because on my phone, I saw how organized the storm became in literally a matter of like 2 radar scans. I saw the hook developing, and then you see the debris ball. And so I ran inside really quickly, and I told my mom, this is not good. This is not good at all. You know, we have a very dangerous situation unfolding right now. And so she kind of looked around, and to gauge some perspective from what the locals and some of the people who lived in Joplin were thinking. And so that first time that the siren sounded, a lot of them said, hey, you know, this is just part of growing up in Southwest Missouri and living here. We get these storms, we get tornado warnings during the spring and summer. Usually they don't mean a lot. The second time the siren sounded and the power went out, we started getting some golf ball size hail. It was huge hail where I was. We went right into the freezer with the manager of Applebee's and everybody else. And you know, the next thing that I noticed is that my ears were beginning to pop. And so that's a telltale sign, the pressure change, that something is there. I mean, and it's close too. And you could hear just a distant rumble. It was like a low rumble. And I was just incredibly scared, as were the people who were with me. And I think knowing what I saw on radar too just added to that fear. So this is the first tornado warning that I was telling you about for Western Jasper County, including Northeast Joplin until 6 o'clock. You can see the storm moving in from the west. And then this is the one that includes Joplin until 6. And that is at that point when I went and seek shelter. And you can see some of those storms that are moving in from the southwest too, kind of merging and meeting with this blob now of a huge HP supercell. You can see the hail core in there as well. To the west of Carl Junction. So by 5:48, the storm has now reached peak intensity as it crosses into that EF4, EF5 threshold on the south side of Joplin. The storm would ultimately cut a path of destruction through the city. By 6:12, the tornado lifts east of Joplin. So this is, and it's crazy going back and looking at it, but it's almost as if this tornado touches down right as it comes in to Joplin, reaches peak intensity, and then as soon as it gets to the east of the city by 6:12, the thing lifts back up. But in turn, the EF4, EF5 damage path is 6 miles long. And at its peak, the tornado reaches 1/2 to 3/4 of a mile wide. So it was definitely a pretty big storm. So after that, after the storm had lifted, shortly thereafter the 6 o'clock hour, and the sky started to get a little bit less dark, we could see from inside of our windows of the Applebee's. We walked outside, and at first glance, you know, there were some trees down. There was a couple of shingles missing off of the roof, but I thought that the city had escaped the worst of the damage. And I thought maybe we had some straight line winds or perhaps a very brief and weak tornado. So we went back to our hotel, probably there close to the 7 o'clock hour. And the hotel was less than half of a mile away from the Applebee's. So we get there, and it became apparent pretty quickly that something really tragic and really horrible had happened. And the reason why is because people started flooding into the hotel and just saying that they had lost everything, that a lot of the city of Joplin was gone. And it starts to sink in the true scope of damage that the storm had produced, even though I hadn't seen any of it yet personally. Just these stories of the people had nowhere to go. So the only thing that they could think to do was go to the hotel and seek shelter there away from the elements, because it was still raining out that night too, on and off. And so at that point, you know, you try to go to bed late that night, but the night ahead was long, and all you could hear throughout that night outside of the hotel was sirens and fire trucks going by. And we woke up the next morning, my mom and myself, and we called Doug and we let him know, hey, you know, we're here, we're safe, we're alive, but we got to do what we can to help. And so, I mean, that's all you really can do when you're looking at catastrophic damage that's less than a quarter or less than probably a quarter mile away is when you start to get the damage. A little bit more than that is when you get to the catastrophic damage, and all you can do is help. And so the actual distance between the Applebee's and the EF5 damage was 1.3 miles, and that was it. And so that's something that really sunk in with me the following days after. So a couple pictures here. On the right-hand side, you can see me that following morning. That's May the 23rd. We went out, we tried to help, but also as an amateur meteorologist and somebody who's interested in weather and reporting out in the field, I started sending some of this video back in front of the damage back to our affiliates in San Diego, and they actually aired some of that, get some of that information out. The top right-hand side, the top part of your screen in the center there, you can see myself. To the right is the chief meteorologist, Doug Hetty. In Joplin, the station was not impacted. As I mentioned, it's in southeast Kansas, so a good deal away from the city of Joplin. On the left is his weekend meteorologist. And then on the bottom center of your screen, you can see myself and then my mom on the far right, and a family that we met who had tragically lost everything, but they had themselves. They were alive and their daughter was alive. And we became very close with them in the following days and weeks. And they came out to San Diego and spent some time with us just to escape, the sheer destruction that they had experienced and some of the trauma that they ultimately had gone through. And so that kind of leads me into my next point here, which is what I really want to touch on, is the lessons learned, because there's a lot of lessons that I learned from Joplin and from that day. Number one, I knew that I wanted to do weather before I went to Joplin and did that shadowing experience. However, being there and seeing firsthand what Mother Nature can do and the damage that it can cause both with property and with human lives kind of changed my perspective a little bit. I realized I wanted to pursue broadcast meteorology to help save lives in the face of severe and dangerous weather. And I became increasingly interested in the social science aspect of severe weather. Examples, what makes people act one way or the other when storms come. That's something that I saw in Joplin is, hey, this is just an average tornado warning. We had nothing to worry about. This happens all the time. Versus the sirens are sounding a second time where, hey, we have some big hail. Maybe this means something, is what's going through people's brain when they are receiving and perceiving these warnings, because I think that plays a big part in how they act when threatening weather is moving their way. And so, now that I'm in this field and working on TV, is how do we convey a message on TV and on social media? And this is something that I think about a lot, is each time a tornado warning, it doesn't even have to be a tornado warning. It can be, this can apply to a lot. It can apply to hurricanes. It can apply to wildfires. That was something big where I grew up. But each time you have big weather coming in, is how do you take that warning seriously without contributing to the false alarm narrative or scaring people? There's a lot of people who genuinely have fear of tornadoes and of storms. And I think that in the weather enterprise, we've come a long way with that. Specifically with the National Weather Service, they've done a ton. PDS tornado watches and tornado emergencies, something that I think saves a lot of lives. I mean, we saw it yesterday. It saved a lot of lives. And so that plays a big part. And, obviously there's still ways to go with that, but, I'm thrilled to be part of that progress. And on the right-hand side of your screen, you can see me. That was in November, and that was the first time that I did solo wall-to-wall tornado coverage in my market here. It was a Saturday night, and we had some discrete supercells that kind of formed into a line, but a lot of that coverage and what went on that night brings me back to Joplin, and a lot of what I do on a day-to-day basis. I think about what happened there and some of the lessons that I take from that experience and apply it to try and become a better forecaster and a better information sharer in general, to try to get people to act appropriately with weather. So I know I'm a couple minutes early, but that is most of the information that I want to share with you. And I appreciate you listening, and hopefully you got something out of it.
Fantastic. Great story. That definitely will get you involved in meteorology for sure. So I appreciate you taking the time and putting it together. And I don't see any questions from anybody in Slack. So just to kind of stay on course here, since we are kind of running behind, we're going to go with the next one. So thank you again, Chad, for your hard work in putting this together. And I'm glad you and your family were safe from Joplin. I know that's living memory for a long time. So appreciate you doing that. Up next here is Keith Stammer. So another look at Joplin tornado, its impact and recovery. He's the Emergency Management Director for the city of Joplin. And Chad, could you stop sharing your screen?
Oh yeah, give me 1 second here.
No problem. And then so he can share it. Okay. Keith, are you there?
I am here.
Awesome. And I'll let you know when I see your presentation show up here.
Okay.
And while he's working on that, we have our Pam Dale and Tim Samaras scholarship announcements right after his talk here before lunch. So Mike Fowl will be presenting those two winners after this, and so stay tuned for that.
Well, I seem to be having trouble getting it shared.
All right, the share screen should pop up on the little bar at the bottom. It's on the same thing as where the participants are: stop video, mute, chat window. And I'm under the view, speaker view, excuse me. And that option is at the top right. So you have the option of speaker view or gallery view or full screen. Sometimes that little bar at the bottom goes away, and then if you scroll over, it should pop up. There we go. I think I see it.
Does that work?
Yep, I see it.
Excellent.
Very good.
Thank you.
All right. Thank you.
Can you hear me okay?
Yep, very good.
All right. So let me know when you're ready.
Yeah, go for it. Start
Okay.
whenever.
Thank you so much for inviting me. My name is Keith Stammer. As he said, I am the Emergency Management Director for the city of Joplin, Missouri, and the surrounding Jasper County. I am a former firefighter, former medical first responder, used to be director of a 911 dispatch center in Kansas. I've been in emergency management for 27 years, have participated in 14 federal disaster declarations in my own jurisdiction, and of course, the Joplin tornado, which you just saw some information on that before. Thank you very much, Chad. I appreciate that. This is a presentation that we've done several different times. Some things obviously are of interest to many of the viewers here. Something are more interest to me. You are going to see this from the standpoint of the emergency management perspective. And that's the only one that I've got. And so we'll just start in talking about this. You've seen the maps where Joplin, Missouri is down in the very southwest corner of the state. One interesting statistic: Joplin sleeps 50,000 people at night. In the daytime, we see upwards of 250,000 people. This tornado happened on a Sunday evening when most people were not out and about. Had this happened on a Monday evening at the same time, it would have been much different, I think, in terms of casualties and injuries. We went under a tornado watch approximately about 1:30. We sounded the sirens, of course, had a warning issued. We show a touchdown of 5:41. I think Chad had a little bit different number on that. To be honest, the time of the touchdown depends a lot on where you were standing on the west side of the city. So anywhere in that particular area. Here's a quick satellite image of the storm system itself. I understand everybody on this particular conference is weather savvy, so I won't bother you with all the stories and the radar and whatever. I have a whole series of lessons learned, and some of them obviously are more important than others. If you would like to mark this one when the slides come up later, to me, this is one that is extremely important. In my looking at tornadoes and severe thunderstorms for which we would activate sirens, we're averaging in Southwest Missouri about 10 minutes from the time that we would see or receive a tornado warning to when we have an actual touchdown. The problem, of course, is people's thought process. And here's 7 steps in a thought process that people go through. You may see this variously expressed as 6 or 7. I've even seen 8. I kind of like this particular numbers that are here. But first of all, people have to hear or receive the warning in some manner. Then they have to understand it, actually believe it, personalize it, A big one is they then seek other forms of confirmation, as in Facebook. They go outside and look, they call the family members to see what's going on. They finally decide to do something about it, and then they have to do the right thing. My experience has been in that 10 minutes of time between the warning siren and touchdown, by the time people go through this 2 or 3 times and back up and try again, they've used up 7, maybe 8 minutes, and therefore is no time to go to a separate shelter. That's why we advocate in our area shelter in place primarily. This is a map of what is known as the expedited debris removal area. It was provided to us by the USGS. It is going from west on the left to east on the right. You can see how the tornado outline of destruction began to work toward the middle, where it finally went. It's 6 miles from left to right, approximately 3/4 of a mile from north to south at its widest point. The red area in between is the path of greatest destruction, including the Joplin High School. And I've had many requests from various emergency managers for copies of this map, and they dropped it over their own city and said, this is what happened to Joplin. So what could happen to us if this similar type thing happened? As Jad pointed out, it began to spool down on the right-hand side. You can see a little push down on the very right-hand corner there, where it pushed down into Newton County. Some things about local control. We always advocate that all disasters are local. Disasters start locally and they end locally. You may get a lot of really nice people and equipment and funds that are come and help in between, but at some point, all those good people are going to go away. So I would suggest that you make every effort to maintain local control and oversight of all of your own resources, rather than just turn them over to someone else to do for you. I have a lot of pictures, and I've reduced some of them for this particular presentation. We have thousands of them. We did have a lot of fires. We lost, the old saying is on an EF4, everything is destroyed. On an EF5, everything is gone. And it smoothed a lot of houses right off the foundation, including the natural gas and the water. So we had several structure fires going on right after the tornado came through, and an extreme lack of water because all the water was off. So they had to shut off the gas, they had to shut off the water. We had to do tanker operations. This is 26th Street, which is the main east-west corridor, give you some idea of the type of destruction you saw. I had one interviewer tell me that usually in a tornado, they find the one spot of greatest destruction and all of the media line up back behind it, and they do their presentations from there. They said here, it was anywhere you wanted to go for 6 miles from west to east. A lot of power lines down. We lost all the electricity in that particular area. A lot of houses pushed over, pushed down. I saw houses that had been pushed in from the west side as the tornado went by, and then pushed in from the east side as the tornado bypassed them. We had a lot of cars damaged. On the bottom left-hand side, you can see a vehicle that was damaged. That is St. John's Hospital in the background there. We'll talk about that some more. A big box store on the bottom right-hand side. We'll talk about that in a couple moments. A lot of flags that were out. Top right-hand, that was a Catholic church. That was the only thing that remained of that particular Catholic church. Bottom left there, we had the National Guard come in. Firefighters, of course, as you can see there in the pictures. One of the lessons learned that we had was in dealing with police, military, in other words, the law, if you will. They're very effective, particularly in terms of being there on site and being seen. We maintained property rights. We did not declare martial law. One of the things about property rights is that we could not go on to people's property to help remove debris until they signed a waiver to allow us to do that. One very important lesson is that you can't always control the scene. We tried to do some blocking off an area, but since people still own their houses, they were there from sunrise to sunset trying to salvage what they could. But you can always be at the scene. Our health department was there. They didn't realize that there would be at least 40 different areas within the city where people just did pop-up restaurants. They get out a grill, they start serving hamburgers to people. My joke here is that it seemed like every person in that entire area, particularly in the apartment complexes, had a cat. and we had to do a lot of animal control. We had some scavengers and some scammers come in, but honestly, only about less than 100. And I advocate that it was due to the fact that we had a lot of police and military. One of the big things I appreciate from the then police chief that was there, Lane Roberts, he told every law enforcement agency, you must respect the rights of all citizens regardless. From the most respectable high-end citizen down to the lowest of the low, they all deserve our respect and they all deserve our service. Some of the areas there that happened, just a lot of destruction. You can see that the streets are cleared. That's because our public works came in the first thing that evening and again on Monday morning and just put their blades down and shoved everything to one side so that we could actually get all of our rescue units in to start looking for people. Another shot of St. John's Hospital and some of the destruction. You can see that the wind picked up that vehicle and put it on top of that building. Some advice that we have is don't go it alone. Our city manager immediately said, start calling your compadres, those police, fire, ambulance, legal, public works, or whomever, and start checking with them places that have had tornadoes before and see if they learned any lessons. We had an ice storm in 2007 where we called the city of Springfield, who had previously had an ice storm. We learned a lot. In 2011, not more than just a few weeks before our tornado, Tuscaloosa, Alabama had a tornado, and we called them and they said, yeah, we can tell you 3 things that we thought that we found. Number one, we had people calling and telling us that there were cars on top of buildings, that there were multiple bodies in water and we were not able and willing to get them out, and that somewhere we had hidden a trailer load of unidentified bodies. We had a reefer load of bodies. And we thought, okay, that's good advice. We'll keep that in mind while we start our search and rescue. And so that is what we started to do. Here is one of our schools. We'll talk about that in just a minute, as well as one of our power stations just off to the right. Lesson learned with schools. Our schools were an example of looking to themselves for help. They had their own call down tree. It wasn't very long before they found out exactly where all of their school students were, where all their teachers and staff were, how many they had lost, and who they were. 10 of the schools in the Joplin school system were affected by the tornado. We actually had 6 that were totally destroyed. The nice thing about it is they called me up in the emergency operations center and said, what do you need? I said, I need buses. And they said, not a problem. And that's decided what they did. Another thing that I found exemplary was they decided they were going to hold classes. Come August, it was going to happen, and they made it happen. For those of us that have been in the emergency management for a long time, there's always been the old advocation that whenever there's a tornado, we push the students out into the hallways and they do the duck and cover. I guarantee you that's never going to happen in Joplin, Missouri again. They have a video of an inside of one of their schools. And in that video, you can see a pop machine that was actually full of water bottles, pushed by the wind some 75 feet down the hallway, back down another hallway some 30 feet, and then over into a freight elevator just from the wind in the halls. If those hallways had been packed with children, it would have been devastating. So the Joplin school system said, we're not doing that anymore. And they cleaned out closets, they cleaned out storage areas, they cleaned out their basements. They added a FEMA certified storm shelter, a FEMA storm shelter to every one of their buildings. And ever since then, anytime people have asked me in schools, where should we place our children? My first words have been, not in the halls. Let's go looking for rooms and areas that you can place those children in safe places. A lot of vehicles. I've got some numbers for you on that in just a moment. We had some big box stores. There's the example of the Home Depot, which brings me to this lesson learned, design and construction. Building design is critical. Our big box stores suffered greatly out on east of the area on what's called Range Line, 26th and Range Line. Basically, they were tilt-up, pre-stressed concrete walls with beams across the center. Once the tornado came through, pulled the roof off, the walls collapsed. We lost several people underneath those walls. The city of Joplin changed the building code for individual buildings. We have advocated the use of hurricane clips in order to hold the roof down to the side support structures that cost a whole $1 a rafter. We have closed up the spacing for tie-down rods. Any place where buildings use concrete blocks, they're now required to fill those voids with concrete. The National Institute of Standards and Technology came in almost immediately after the tornado and began to interview individuals and several of us in an effort to try and advocate for the strengthening of building codes, not just in our area, but also nationwide. And they published a tome, some 500 and some odd pages that you can look up on their conclusions on that, and also with a lot of examples from what happened in Joplin. This is just an aerial photograph. Joplin used to be known as a city of trees, still too, but you can see the scoured area there. Any place where there are no trees is where that tornado came through. One more shot of something very similar. We had approximately 7,500 residential dwellings that were affected by the tornado, a total of some 4,000 that were destroyed. Joplin has long been a city of rentals. It's an old mining town. We had a city block might have as many as 12, 14, even 16 houses on it out in the western section. Those were gone totally. We had some 9,200 people that were displaced totally from their dwellings, and a total of 17,000 people that were affected directly by the tornado. Some immediate needs that we had was distribution of the basics, food, water, and clothing. We long had a relationship with the American Red Cross and our faith-based communities. We set up a multi-agency warehouse where we brought in all of the donated supplies, and from there, we had points of distribution. Honestly, they were basically churches. We had several what called mega churches with attendance in excess of 1,000 membership. And they would come to the multi-agency warehouse, do daily pickups, and then take them to their points of distribution, and had people there that would distribute all the food, water, and clothing. It's very important to manage your contribution of goods and services. We even established a multi-agency resource center. That was a large building where we had people gather who wanted to help. Good example is legal services, financial services, banking services. And we are a multi-agency. We even had some people from the local Buddhist organization that we had dealt with in the 2007 ice storm. And they came in and said, we have available emergency backpacks. We said, thank you. Could you please go to the mark? And we'll set you up a table and you can begin distribution. We had some 553 different businesses that were either destroyed completely or damaged, involving somewhere in the neighborhood of 4,500 to 5,000 employees. We had over 1,000 people that were injured. We really don't know. The other hospital that we had there in Freeman Hospital told us that they had a couple hundred people within about 45 minutes, 600 people within an hour. Within 18 hours, they were looking for work. Best estimates, we had maybe 1,200 plus people that were injured. 161 people actually died as a result of the tornado. A little lesson learned was that in the 2008 Mother's Day tornado in the county south of us, their local health department set up places for people to come and get vaccine shots, but people wouldn't come because they wouldn't leave their property. So learning on that, our health department set up strike teams that then went to the location and handed out tetanus shots. My story on that is that if you saw somebody dressed in white come up to you with a needle asking you if you had a tetanus shot, you best say, yes, I have, because by the time you got done saying no, you already had a tetanus shot. Some advice to those of us that were involved in this: we ran 24/7 for the first week. We then went from 7A to 7P for the next 6 weeks, and were involved in this for the next 36 months in a very intense manner. Take a deep breath. Take a deep breath. You all know the old confidence definition, don't you? Confidence is that feeling you have just before you fully understand the situation. And that was the situation with us. Sunday evening, people were calling me saying, how bad is it? And my comment was, I don't know. Wait until the sun comes up on Monday. We're working all night Sunday. Maybe I'll have an idea of what's going on. Give yourself lots of time to gather sufficient and accurate information so that you can make a valid assessment. Go ask other people their viewpoints and their opinions. If any of you are trained in the incident command system, you'll note that these items come up time and time again. Our priorities had already been preset, and we know what those are. Number one, we look for people. We take care of them first. Number two is scene management. And then finally, we worry about property preservation, but not until the first two are taken care of. This is a picture of the St. John's Hospital. That is a helicopter lying on the ground with its top rotors facing towards you. A lot of rumors about what happened to St. John's. It was not moved. The top floors were twisted. The big thing that happened to them is that debris from the top of the building fell down into the radiators of their generators that were on the bottom of, or on the ground level, destroying the radiators and totally wiping out their ability to be able to supply themselves with power. The entire building had to be evacuated and then abandoned soon thereafter. We like to tell people, and if you've been involved in sports, you know this, you need to play like you practice. Not more than just a few years prior to the St. John's Hospital destruction, we had a total disaster drill where they evacuated some 50 volunteers in about 2 hours. And I thought, job well done. At the time of the Joplin tornado, they evacuated some 150 plus people in about half that time. It's amazing what you can do when you need to. Not more than the Wednesday before the Joplin tornado, we had a full-scale earthquake drill statewide and had everybody in the Emergency Operations Center. So we felt like we pretty well had a handle on what everybody was supposed to do, not realizing that just a few days after that, we were going to need to do this for real. Some have asked me, would there be something I would do different? And my first comment is, yeah, have a disaster drill that's bigger than you and your capabilities. Up to that time, we had actually just practiced disaster drills where, okay, we lose part of the city and we have to respond and occasionally call for help. We never once had a disaster drill where, as a friend of mine used to say, we were hurt before we knew it, where we had to call in on others to come and help us immediately just so we could help ourselves. Temporary medical, we had a MASH type facility brought in that was supplied to us by the MONG, the Missouri National Guard. The top right there was our Memorial Hospital, our Memorial Center that was used as a hospital. Within a matter of just a few hours, many medical facilities and personnel had been set up there, and they were actually doing surgery on the basketball floor. Some thoughts about pre-planning. Pre-planning for medical response is a major plus. We learned this from the 2000 ice storm. I've mentioned the thing about the tetanus shots. We have a committee called the Joplin-Jasper County Emergency Healthcare Coalition, big name for a group of organizations, all medically related, the local and the city and county health department, the hospitals, doctors' offices, FQACs, all of our different agencies that are there from a medical standpoint. We meet on a regular basis to sign and complete mutual aid agreements and to work with response agencies. It certainly helped when the tornado struck. Some things we lost as a city: electrical outages, missing distribution points, lots of gas leaks, missing fire hydrants, damaged houses, sprinkler systems went down, our phone system went down, cell phone messaging was spotty at the top. At the time, we lost some 12 different cell towers involving probably some in the neighborhood of 14 to 16 different cell distribution companies. We could do some texting, but we certainly had a difficult time for a little while to do any kind of video work. Infrastructure, 95% of the primary and secondary streets in the destruction area were totally impassable. We lost street signs, street lights, traffic signals. We had 110 public works departments. That's from all over the area respond. Some people wrote on the streets. Some people put up signs. It's kind of interesting to me that, you know, how much you relate the area around you, the landmarks as to where you are. I had a request from CNN to do an interview. I said, sure, where are you? They told me. I said, no problem. I know where that is. I drove right past it. The service station that you always turn right on, the stoplight that you go through and then look for the alley afterwards. All that was gone. I had to get out my GPS just to find a location that they were set up at. And that was in a town that I knew pretty well. Search and rescue. We had some 5,000 different personnel from over 435 different agencies. My comments earlier about information that we received from Tuscaloosa, Alabama, they said they had rumors that there were people in water, in rivers and whatever. We brought in dive teams and we dove every body of water from west to east, which body of water we could not see in, and went looking. We found a lot of vehicles. We did find some bodies. Tuscaloosa said that they had rumors that there were people on building tops. We brought in a helicopter and flew every single building top and tree top to see if we could find places. We brought in some 45 different dog search teams to come and check our area. This happened on a Sunday evening. We found our last live person on Tuesday afternoon. We ran all the way through Saturday, took Sunday off, and then on Monday, we went back in with the bulldozers and started pushing debris off the top of houses and looking around. We're happy to say that we did not find any additional people. Everybody that we had looked for in those 6 full passes from west to east and then back from east to west did find, in fact, all of our live people and all of the victims. Search and rescue certifications on our firefighters, on our dogs, on our volunteers was very needed. Something about don't move too quickly. One of the pieces of advice that we got from the former manager of Greensburg, Kansas, where they had an EF5 was take your time, keep going back and forth, advertise your efforts, let the public know what you're doing. Don't let anyone think that you are rushing this and that you're going to overlook. We took what we thought was as much time as was needed and then some. Our emergency operations center was set up. We had several mobile radio units and satellite units because we'd lost our phones. We set up there in our area and ran from our emergency operations center, which fortunately was not affected. Police and the emergency operations center was on the north end of town. Most of this damage was on the south end of town. Some things about doing emergency operations, pre-disaster relationships are a must. The old saying is true and worthy of repeating. The disaster scene is not the place to exchange business cards. I can tell you that in the first 72 hours, I had no one who was either a department head or an agency head come into my EOC whom I did not already know and had not already met. Of course, after the 72 hours, people have to go home and get some rest and take a shower, and we started swapping out people, but that was so important in those first 3 days. Incident action plans rule. Every morning we would have a council of war where we would hand out the incident action plan for the day. Here are our goals. Here's who's supposed to do them. Here's where the equipment is. Here's where the food and the porta potties are. Very important. Here is who is in charge of media. This is our frequency plan, a communications plan, and a whole list of things. And then every night when we were done, we would gather together that evening and talk about what happened, and our planning section of the incident command system would work all evening to create a new incident action plan for the next morning. Vehicles, we don't really know. I can tell you that the state of Missouri Insurance Agency said that they knew of claims for approximately 7,600 vehicles that were damaged or destroyed. There very well may have been a lot more. All I can tell you is the car dealers were bringing in truckloads of new and used vehicles. Some examples of the big box stores that we had and how they were totally destroyed. We had apartment complexes that were destroyed. We lost several people who were in the upper floors of the apartment complexes, were not able or unwilling, I know not, to get to the lower floors, but those were concentrations of people. Here's an apartment complex from March and another aerial picture from May as well. You can see how that's destroyed. The city's resources, we lost 2 fire stations, one of which had personnel, citizens and firefighters in it in a concrete block storage room when it was hit by the tornado. We lost fire trucks, our senior citizen center, 5 parks and an aquatic center, our trolley system, curbs, streets, sidewalks, lights, signs, signals. I personally, part of mine, I lost 3 emergency sirens, one of which we never found. A lot of communications antennas were gone. What do you do? Well, again, if you've been involved in emergency incident command system, you know the first thing you need to do is identify your needs. I remember being in the EOC that night. We got out of a wall chart and said, let's write down everything we know is damaged. And we did that for about 5 minutes and said, okay, this isn't working. Let's write down every place we know is not damaged. And you begin to identify your needs. And that told us something about our resources. And then we matched the two. The old saying is adjust, adapt, overcome. And that's what we did for the next several years, or several days, I'm sorry, is identify needs, identify resources, and match the two just on a day-by-day basis. Sometimes it was hour by hour. The media was there in force. They were there within 24 hours. They were in and out for the entire week. And of course, when the president came on May 29th, they were there as well. May I present to you 3 terrible truths? And terrible truth number 1 is manage your message. It was the media who called for help and said that we were totally destroyed and we needed all kinds of equipment and personnel and medical. I never, and to my knowledge, any others talked to the media about that. They just decided that was a message that needed to be transmitted. They showed what they thought was newsworthy, not necessarily what we thought they did. They obviously had their own agenda. Very important thing to remember is you need to tell your story, not the story that the media wants to tell. We did attempt to use any and all media that was there, both television and social media and newspapers and radio and any place that we could. We assigned people to handle social media exclusively. We formed a joint information center from our own public information officer, as well as those with the state and federal government and any other agencies that were willing to help us out. We had a rumor that there were 1,500 people missing. Well, golly, what we did is we asked people, if you know of somebody missing, would you let us know? And so everybody that had a brother-in-law that they hadn't seen for 5 years called us and said, yeah, my brother-in-law is missing and he happened to like Joplin, any chance he would be there. We have family members that are late arriving from the East Coast and the timing would have been about right. It was quite an interesting thing where the state of Missouri employed some 20 highway patrol officers who did nothing but go around and knock on people's doors and try and match them to a list of missing personnel. I did a lot of interviews, and this was one of the favorite spots that the media used to talk about what was happening and what was going on. Terrible truth number 2, keep it personal. This I kept reminding myself as the emergency manager on scene. Your job is not to do the work, but rather your job is to see that the work gets done. I remember sitting down to help at the phone bank, which I was glad to do, but it occurred to me, why am I here? All I can do is answer phones. The problem is broader than this. And so I found somebody to help with the phones and went back to my work. I advocate that we swim in our own lane. defer to others. When the media finds out that you're available and they all get your telephone number and they start calling your cell, they want to know, so what do you think about the job that the police department's doing? Well, you need to talk to the police chief about that. So we got some rumors that there are some problems with the distribution of medicines. May I direct you to the director of the Joplin Health Department or the Jasper County Health Department to visit with about that. Your city manager last night made this statement. What do you think about that? I think you need to go talk to the city manager. Need to keep a perspective. Your job is to do your job and do it well. That said, keep checking with other people. Ask for other perspectives. Also look to yourself. Post-traumatic stress is a truth of life. I went through post-traumatic stress counseling 3 different times. I'll just tell you right here, it's been 10 years. It was 8 years on after the Joplin tornado that I didn't get angry on May 22nd or that week around it. It finally started to fade somewhat. It's been a pleasant 2 years since then. And that was true of a lot of our people. Fortunately, the state and the federal government offered counseling services. We had a lot of ministerial alliances, people that have been trained in master's degrees in counseling, and we employed them to work not only with our response personnel, but also with our citizenry. The Federal Emergency Management and the Missouri State Emergency Management were there. Within the first 24 hours, they provided us support, assistance. The Corps of Engineers provided and oversaw the debris removal that was there, and provided money for housing assistance as well. Terrible truth number 3, politics is the only game in town. You all know the golden rule, don't you? Whoever has the gold makes the rules. And that is in the hands of the politicians. In emergency management, you learn very quickly that with the state, you get resources. With the federal government, you get money. And when the president showed up and did the tour, all of a sudden, the federal government was very interested in what we were doing and began asking, how can we help? What agencies can we do? Loans, grants, those type of things. This is an example of some of the work that was done and some of the other cleanup efforts that are going on. There were approximately 3 million cubic yards of residential debris. Just for perspective, I once looked up about the Twin Towers on 9/11 as to how much debris there was. And one article said they had approximately 600,000 cubic yards of debris. Ours was 5 times that amount. Federal contractors removed about 1.5 million cubic yards by August 7th. Our property owners and volunteers removed another 1.5 million cubic yards of debris. Here's some examples: tornado debris on the left, 10 weeks later on the right. We filled up 3 different landfills, 1 in the state of Kansas and 2 in the state of Missouri, just with our debris that we had. We had a lot of people register for disaster assistance, over 10,000 people. We had 586 families that were placed in temporary homes. After Katrina, the federal government did not like to call those mobile homes. They referred to them as temporary housing units. And we had them spread over 15 different sites with a lot of SBA money that we were able to do this, which was very effective in maintaining the population for the city of Joplin and the surrounding area. Here's a shot of what we called FEMAville and all of the mobile housing units that were there on land that the city owned on the south side of the Joplin Municipal Airport just across the road. Volunteers, volunteers. By the time it's done, we have registered separately over 182,000 separate volunteers who provided over 1.5 million hours of service. Somebody said, "Is that really true?" And I said, "Sure it is." This wasn't our first rodeo. We have their names. In order to be able to claim soft matching against any kind of FEMA disaster funds, you have to be able to say, where do these people work? And we have pages upon pages, people's names, what days they were there, what areas that they worked, what hours that they were there, what they performed, what duties they did. Volunteer management, it's a must. We learned a lot from our ice storm and from our area tornadoes that were out there. We brought in organizations with expertise. We brought in some federal organizations. One of the churches that we have dealt with takes over in the use of volunteer management, and we work with them. We opened a volunteer coordination center. We asked 3 questions. Can you do the work? Will you do the work? And can you get along with those that are already here? And if the answer was yes to all 3 of those, we said, welcome, friend, we have a mission. But if somebody didn't want to do the work that we thought needed to be done, we sent them on down the road. If they said, well, I don't want to deal with that particular organization, people that have a certain sexual orientation or ethnicity or religion or whatever, we said, you don't understand. We're doing this for everybody. If you can't get along with the people that are here, we don't need you. We treated volunteers like our own. We wanted to know, where are you? What are you doing? Let us assign you some work. We will provide the food and water and shelter and porta potties and give you an incident action plan. And we want to know when you're coming in and when you're going to depart. That way, if your family members or your organization calls and says, we haven't seen our busload of volunteers, we can say, we know that they left on Friday afternoon at 2 o'clock, and surely they should be arriving this evening. That's the way that they told us anyway. Home Depot was rebuilt. That was a good thing to see, as was Academy Sports. I was always amazed at the number of people that worship at the institution of Academy Sports. I almost got calls weekly wanting to know when that thing was going to be open. Some houses were being rebuilt. A lot of people, organizations, and volunteers were helping. A lot of work went on. Some challenges we had, as has been said before by Chad, 6 miles long by 3/4 of a mile wide. The path of the tornado, including down in the Newton County, was over 13 miles. Number of people, number of debris. We had a lot of people come in, resources come in. Special resources, the infrastructure, communications. Our severe weather continued for 3 days. We pre-planned on Tuesday night to set off the sirens because we had severe storms coming in with high winds. We didn't want people to be caught out in the open doing work in the evening. We had, like I said, a number of people that were missing. The President of the United States came in. We had senators and representatives from the federal and the state, dealt with the media. Medical services, animal control. We had a lot of pets that were lost, and some 1,308 pets that we know of. We were able to return 529. One of the neat things that the ASPC did was they had an adopt-a-thon where they advertised that if you wanted to pick up a Joplin pet, this was the weekend to do it. We had people from all over the United States literally show up wanting an animal from the Joplin tornado that they could take home and say, this is a rescue animal that we brought back to care for. A lot of things with the schools and the kids and throwing themselves into it. Some items about why we thought we were succeeding. We really pushed the teamwork aspect. We were not big into saying one particular agency lords it over the others or is the big push. It was totally a team effort. Pre-established responsibilities, local, state, and federal, all mutual aid systems all work together. We appreciate the can-do attitude. I tell you, this happened on Sunday evening before the sun goes down. Before the sun went down, I could already hear the chainsaws operating out there, that people were working, and a large amount of accountability. Who are you? What are you doing? What needs to be done next? What do you do in this kind of situation? Well, before the disaster, you collaborate with those that you may need in the future. You work out a plan and you exercise your plan. During the disaster, your priorities are people, scene, and then the property. After disaster, as I've said before, you list your needs, list your resources, and match the two. If any of you are in emergency management, this is my nutshell definition of 27 years of emergency management. It's listing needs and matching resources. Everything else is boilerplate. Some things that have changed. We now use web EOC instead of pretty much face-to-face in the Emergency Operations Center. We are all advocates for NWS chat. We talk constantly on social media. We rewrote a siren policy for Southwest Missouri. We gave out NOAA weather radios to every citizen in the city of Joplin that would receive them, some 4,000 plus different NOAA weather radios that we had pre-programmed. We bought and installed a NOAA weather radio transmitter on top of City Hall that now covers 3 counties in our area. Made sure that we were good with common radio frequencies and channels, and we have a closer cooperation via the use of the unified command system. Some updates, and these were brought to me earlier in some previous questions about rebuilding. And the first question was, how much have you rebuilt? How much is left? May I speak to that for just a moment? I've got a little bit of time here that I need to use. Over the years, it's been 10 years, I've had people call me up and say, so now you're fully recovered. And I said, no, and they seem to be surprised. But let me ask you a question. Why do you live where you live? For some of us, we like the spot, we like the money, it's the right price, it's close to friends, family, to work, to the running trails, to the golf course, to the swimming pools. It's near my doctor's offices, it's near where the pharmacy is, the family lives there, it's near to my work. I have a business, it's there in amongst my customers, it's on a busy thoroughfare. We all have reasons for being where we are. Now, in your mind, take a giant scraper and scrape the land 3/4 of a mile wide by 6 miles long and remove everything that's there. Why would you go back? That was a real big question. We did 2 complete surveys of our citizenry of what do you want back in this area? Do you want schools back in there? Do you want industry? Do you want running trails? Are we just necessarily going to rebuild our houses back the way they were? It was totally different. We had 10 schools that were totally rebuilt. The big box stores built themselves. St. John's, now called Mercy Hospital, relocated themselves from near where Freeman Hospital is to the south side of the city, which was interesting because when Mercy Hospital moved, a whole bunch of doctors' offices moved. When the doctors' offices moved, a lot of the houses began to spring up in the area, and the restaurants and the service industry began to spring up in that area. You might be interested in knowing that Mercy Hospital rebuilt their facility to EF5 standards, windows, roofs, doorways, full basements. All of their generators are now underground and vented to the outside. It was quite an effort. We had 28 churches that were destroyed. 1 church merged with another, and 2 moved entirely, 25 rebuilt. We had over 500 businesses that reopened. We had 30 that were rebuilt, and we now have 150 more that were new on top of that. I talked earlier about building code updates. Somebody asked me about trees. We lost some 17,000 trees to date. We have replanted some 15,000 trees. I told you about Mercy Hospital being rebuilt. The school system, under a FEMA grant of 75-25, 75% of the cost borne by FEMA, 25% of the cost borne by the local school system. They built a storm shelter at each school site. We are now using them as community storm shelters per FEMA guidelines. We upgraded our siren system. We put 2-way radios in each of our sirens. We have solar cell power backup. We have a program that enables us to remotely monitor all of our sirens as to how they worked, whether or not they did. I mentioned about the NOAA weather radio transmitter. Up to this point, Southwest Missouri did not have a common siren policy. We do now. Several of us got together in Southwest Missouri, particularly from Joplin, Springfield, and Branson, the 3 large facilities here, and we wrote a policy. We now, for 60 communities, we test our sirens on the second Wednesday of each month at 10 o'clock in the morning, weather permitting. We have agreed that we will activate our sirens when we have a tornado, either weather radar indicated or spotter indicated, with a path that includes our particular jurisdiction. We activate the sirens for 3 minutes on, 3 minutes off, 3 minutes on, 3 minutes off, until such time as the storm has passed. We also do this for winds of high winds, in our case, in excess of 75 miles an hour. The nice thing about it is many of the citizens in Southwest Missouri can go from community to community and know that the siren policy is much the same. Finally, just some parting thoughts. We are but ordinary people who found ourselves in extraordinary circumstances. We stepped up to meet the challenge presented to us. We've done what we thought was needed in order to recover and restore. And in doing so, we've been changed by this experience. How we approach the next challenge will in large part be affected by the change that is within us. Our mantra is adapt, adjust, adapt, and overcome. And that is by the mantra by which we continue to live. And that's my presentation.
Outstanding. Thank you, Keith. That was phenomenal work, and great job on over the past 10 years keeping up with all the cleanup and whatnot. I know there's a couple questions that came in through Slack, and I know we're running a little behind on the
Sure.
on the lunchtime, but one here, we can sneak in one here before we get to the scholarships. But Melissa Mainhart, she wanted to know, how did the Joplin tornado change your emergency management practices? So I know you kind of touched on that a little bit, but maybe kind of rehash some of that here shortly.
Well, obviously, for the first 3 years after the tornado, we emphasized weather awareness tremendously. Our weather sessions that we had were packed. Unfortunately, after about 3 years, it began to drop off in terms of attendance. People tend to forget, and we're a high transit area. And so we've had to go in there and really push the idea of being weather aware.
Okay, very good. Yeah, if you have a chance, get in to Slack and answer a couple of those questions if you wouldn't mind.
I'll do that.
There's some really great ones in there. So appreciate your time coming in, and thank you again for participating today.
Glad to help.
Up next is Mike Fowler, Sue here at NWS Des Moines. He's also the scholarship chair for the chapter, and he's here to present the Pam Dale and Tim Samaras award winners.
Okay, Kenny, can you hear me?
Yes, very much.
And what I'm going to do is, hopefully, can you see my screen now, Kenny?
Yes, scholarship presentation 2021.
Yep. All right, I promise, folks, I'll keep this pretty short. But as Kenny said, my name is Mike Fowle. I'm the Science and Operations Officer here at the office in Des Moines. And more importantly for today, I am also the chair of the Central Iowa NWA chapter for the scholarships. So we've come to what I feel is probably one of the more rewarding portions of our conference. We've obviously been treated to several really good talks already this morning, and hopefully I'm guessing we're going to have several more this afternoon. So I saw Todd Shea had mentioned something in there. The negative of the virtual talk is no fuzzy tacos this year, but and no cocktail hour. But hopefully next year, fingers crossed, we can resume all that. But again, I won't take too long. I did want to again really take a few minutes here and just recognize some very deserving students. So again, this year we had a tremendous panel of applicants for both of our scholarships, and I'll give a couple scholarship FAQs here. So the Central Iowa chapter here, we currently award 2 scholarships annually. We do the Pam Dale Memorial Scholarship, and that has been awarded all the way. That started back way back in 2005, so it's got a long history. And then our second scholarship is the Tim Samaras Memorial Scholarship, and we began awarding that scholarship a few years ago, back in 2017. But really what I wanted to really highlight here is that since we started awarding scholarships in 2005, our chapter here, and keep in mind we're a small nonprofit chapter, we have awarded nearly $30,000 in scholarships to deserving students over the years. So you wonder, where does some of your money go for the registration and such? And here's where it goes. It goes to very deserving students, and many of these students have gone on to be successful broadcast meteorologists. Some are in research, some are in the National Weather Service, some have PhDs. So we've had a great history of supporting some really, really tremendous students. So we're going to keep that going, hopefully, again this year. So let's start by awarding some scholarships. Let's give away a little money here. Let's start with the Pam Dale Memorial Scholarship, and this is in broadcast and/or operational meteorology. And there's a picture of Pam. So again, this scholarship is dedicated to Pam Dale. And Pam was best known as a broadcast meteorologist at KMGH in Denver. And also she started her career at WOI TV here in Des Moines, which is now ABC5. So Pam was a tremendous broadcast meteorologist, very popular broadcast meteorologist. But really what made Pam unique was her courage and tenacity to overcome various adversity in her life. She not only succeeded in her career as a broadcast meteorologist, but really she lived to help others. And that's really what this scholarship is all about. So just a little bit of background, she suffered a horseback riding accident at age 16, which left her a paraplegic. But obviously that did not stop her from becoming a popular broadcast meteorologist. She was also very active in the community. She really believed in community service. And I'll read just a couple of the various community activities she was involved in. She was a member of Easter Seal Society, the Mountain States Horse Rescue and Rehab. She was involved with the Paralyzed Veterans of America, the Junior Wheelchair Sports Association, the North American Riding for the Handicapped Association. She supported Miss Wheelchair Colorado and Miss Wheelchair America. And those were just a few of hers. So, wow, that's all I can say. A very involved person in the community. Unfortunately, as noted there, she was then diagnosed with, and she courageously fought cancer for approximately 2 years before her death in April of 2004. So we lost Pam way too early. She was only 40 years old. And then one of the final pieces of information to share is during her cancer diagnosis, she shared her stories in Denver, not only on a blog, but also on TV, to again educate folks to learn about the disease and to inspire others to try to overcome. So I'll just say in every aspect of her life, Pam was a positive impact on those around her. She was not only a gifted meteorologist and broadcast meteorologist, but really it was her courage, her strength, her concern for others, and her commitment to be the best person she could be that really should be an inspiration to all of us. So that's a little bit about Pam. So again, this year we had a very strong panel for this scholarship. But with all that said, I'm extremely pleased to announce that this year's winner of the 2021 Pam Dale Memorial Scholarship is Victor, and I hope I pronounced your last name correct, Victor. It's Victor Geyser from St. Louis University. So I know we're kind of virtual here, but we'll give an applause here for Victor. So congratulations, Victor. We expect big things from you down the road. So I'm not sure if Victor is on. Victor, if you wanted to just, again, we don't mandate any sort of formal acceptance speech, but I'm not sure if you're on and you want to say a word or two, feel free.
Yeah, for sure. I'd love to. Those who don't know me, Victor Geyser, I'm an undergraduate student at St. Louis University. I'd just like to take a short moment to thank the Central Iowa NWA for sponsoring the Pam Dale Scholarship. Obviously, it's extremely unfortunate that some people's time on this earth is cut short, especially when they deserve so much more. I'm young enough to where I never got to meet Pam Dale in person or see her on air, but I don't need to have seen her forecast to know the incredible impact she made on those around her. Her tenacity, strength, and courage are something I hope to emulate in my upcoming years as a professional, and I'm extremely humbled to receive this scholarship in her name, honoring not only her legacy as a professional, but as an exceptional human being as well. Pam Dale is certainly the right person to look up to moving forward, and I hope I can stand for everything she brought into this world. So thank you.
All right. Well, thank you very much, Victor, again, and well-deserved, and congratulations once again, Victor. All right, moving on to our second scholarship. This is the Tim Samaras Memorial Scholarship, and this is dedicated to Tim Samaras. And Tim was a world-famous engineer. He was an inventor, and obviously his big interest or his passion was tornado research. And Tim, again, had strong ties to the Central Iowa National Weather Association, and his presentations over the years were oftentimes the highlight of our annual conference here since he was first invited to speak in 2003. Some of the videos that Tim would have, some of the research that he would provide at the conference, again, was always a big hit, and he made a tremendous impact on the tornado research over his career. But I think even of greater impact from Tim was his kind, approachable, and encouraging spirit, not only at the conference, but his ability to kind of rise students up or challenge students to be better. There are numerous stories from the chapter where Tim had interacted with students, and they were always shocked at how he treated them. They were treated as equals. He was willing to answer their questions, and he had a passion again to motivate them, and that was again one of the real unique traits that Tim possessed that made him special. Because of his, again, not only for his passion for the research end of meteorology, again, he was an inventor. Tim often thought outside the box, very creative individual. But again, not only that aspect of his life, but really, again, it was that mentorship. It was inspiring the young folks. He really wanted to educate the next generation of meteorologists. And unfortunately, Tim's life as well was tragically cut short in May of 2013, again, while he was investigating aspects of the El Reno tornado. So again, we lost Tim way too early as well. Just a personal story with Tim. I didn't have a lot of personal interaction with Tim, but Tim was part of the TwistX group, of course, and I had an opportunity to interact with him after the 2010 Bowdle EF4 tornado. And what I remember about Tim is always his willingness to share data, to share imagery, whether it was photographic imagery or again any data he had. He wanted to share that with folks. So whether it was for outreach, whether it was for training, Tim was always willing to share that. And I had some nice conversations with Tim back in that time frame. And again, always appreciated his willingness to share what he knew. And again, that's really what made Tim special. So again, I think at this point here, we had a very strong group of panelists for the Tim Samaras Memorial Scholarship. So again, without further ado, I'd like to introduce this year's winner of the 2021 Tim Samaras Memorial Scholarship. And that winner is Sean Mellinson from Penn State University. So again, a virtual round of applause for Sean. And Sean, I thought I saw your name on there. Would you like to say a few words as well?
Yes, absolutely. Thank you so much. And hi, my name is Sean, and I'm a junior at Penn State. And I just want to take a moment to thank the Central Iowa chapter of the National Weather Association for such a very generous award and recognition. I'm extremely honored to be this year's recipient. From what I've learned about Mr. Samaras, he was a very driven and passionate person, a real innovator in the field, and I certainly hope to follow in his footsteps as I continue to research severe storms in my senior thesis next year in graduate school, as well as in my career. So thank you again.
All right, congratulations, Sean. Thank you very much for saying a few words. So that essentially concludes the scholarship presentation. But real quick, looking ahead to 2022, again, the hope is, as Kenny mentioned early on, is that we hope to have resume the actual in-person severe storms and Doppler radar conference back in March of 2022. And obviously, it's been two kind of crazy years with the pandemic, but our plan is we are going to invite not only the 2021 winners, Victor and Sean, but also, of course, last year we had the virtual conference, so we had the 2020 winners of the Pam Dale and Tim Samaras Scholarship. We'd like to invite those two as well to come back to next year's conference. Again, fingers crossed that it's back in person. And the 2020 Pam Dale scholarship winner was Nathan Gidley, just to recall, from Ball State. And the 2020 Tim Samaras scholarship winner was Cameron Gonteski from Millersville University. So again, next year we hope to have a kind of a big bash and invite all those folks to come back, and we can formally present their plaque and again get a chance to shake their hand in person. So we're very much looking forward to having all 4 of those in the house next year, as well as again the 2022 winners. So with that said, thanks for those of you who stuck around. Again, it's really the highlight of our conference. One of our crown jewels, so to speak, is to give away money and again to support these students. So again, I want to thank everybody that does register for the conference. Again, some of your registration money gets put to very good use to supporting these very deserving students. So with that said, I'm not going to hold you any longer to getting to your lunch break. And again, looking forward to some really great talks this afternoon. So Kenny, I can pass it back to you.
All right, thank you, Mike. Appreciate that, and congratulations to the 2 winners there. We'll take a short break. We'll start back up at 1 o'clock. Alex Krull, he's our treasurer of the Central Iowa chapter. He's also forecaster here at Des Moines. He'll be the session chair. And just a little, again, mention that there's a little bit of change in the agenda. Lee and I will start first, and then Rod Donovan will talk about the derecho in our slot at 1:35. So enjoy your lunch. Unfortunately, it's not fuzzy tacos together, but you can always get that delivered. So we'll see you in about 45 minutes. Thank you.
And just a heads up for all of our invited speakers for this afternoon, please be on about 20 or so minutes ahead of 1 o'clock so we can get everything tested in our speaker ready room. Thank you.
Thanks, John.
Hey, good afternoon, everybody. In 2 minutes, we will get started with our session. We will begin right at 1 p.m. Right now, I've got 12:58 p.m. on my clock, so we will start at 1 p.m. For our afternoon session. Thank you.
Worthy of the 60th anniversary of the Miss USA.
All right, good afternoon, everyone. Thanks for coming back for the afternoon session. My name is Alex Kroll. I'm a meteorologist with the National Weather Service in Des Moines and also serve as the treasurer for the Central Iowa NWA chapter. Before we get the session started, we would like to send another thank you to our sponsors for our symposium this afternoon, Midland USA for the Midland Weather Radios. We will be raffling off 3 of those. All paid registrants have already had their names inserted into the raffle hat. We will be selecting 3 of those and we will get those sent out to you. But we would like to thank Midland for their contributions today to make the symposium possible and also make the Tim Samaras and Pam Dale scholarships that our chapter has been putting on for the last several years financially possible for this afternoon. Our afternoon session here will be focusing a lot on the derecho, and we have a great lineup of talks, and we have representation from multiple agencies within the meteorology field. We have operational meteorology at the National Weather Service. We have broadcast meteorology. We have research, as well as emergency management in our lineup for today. So we'll go ahead and we will get started with our first talk. So our first talk will come from the National Weather Service perspective. This will be headed up by Lee Karloff, who is a lead meteorologist at the Chicago National Weather Service office, as well as Kenny Podradzik, who is a meteorologist here in Des Moines. So I will go ahead and hand it over to them. Kenny and Lee, go ahead.
All right. Thank you, Alex. You see my screen just to make sure, right?
I see your screen and your audio is good.
Very good. All right. Again, this is a collaborative effort between several offices that were impacted by the derecho. So it'll be Lee and I talking about what actually happened into our office. And really, I'm not going to get into a whole lot of science. I'm just going to kind of go through what happened that day because I was one of the forecasters that was there that day. And so there is some content provided by Brian Bargenbrook, for the Sioux out of Omaha, and Mike Fowle, the Sioux here in Des Moines, as well as Ray Wolf, the Sioux out of Davenport. So appreciate their contributions. And if you have any questions, you can ask them, right? So if we had an actual in-person conference, we'd probably go ahead and use Raytown here. The Ray Gun is what the company here is. Put together a nice T-shirt using the Storm Prediction Center's derecho track there. So the Hurricane derecho was pretty popular, trending on Twitter there for a while, but it's actually a pretty cool shirt. But a lot of the proceeds went to help the cleanup efforts and things like that. So it really went to a great cause as well. So it's pretty cool. So just to give you an overview, most of you probably already know this, but 770 miles that it covered 7 states, lasted 14 hours. So a lot of offices were involved with this. Unfortunately, there were 4 fatalities. A couple of those were, one was a down power line here in our area. And then I had multiple injuries and 26 total tornadoes throughout the different offices. And Lee will kind of hit on more of the tornado aspect of this derecho as it turned into a decent tornado producer in northern Illinois. we had hundreds of thousands without power, and not just for a couple hours, but for extended duration, just a couple days, even up to a couple weeks. And so that was really played a impact too as far as cleanup. And during a pandemic, it's mid-August. If you've ever been into Iowa in August time, it's really humid and hot, and really just unbearable time. So there was thousands of trees lost. I drove through Cedar Rapids later in that month, about 3 weeks after that, and there were still just tons of trees, piles of trees everywhere. It's just really sad to see. And it was estimated about 10 million acres of farmland affected just in Iowa. A lot of that was soybeans and corn. So you've probably seen a lot of the down corn. Is like at this time of the year, the corn's really mature, so they have it's really heavy, top heavy, so they didn't really have time to recover. There was a derecho about 10 years ago in July of 2011. That corn had time to kind of recover as it wasn't quite totally mature. So, and one thing too, I know Ray Wolf mentioned too, there's about 300,000 acres there of specialty crops. That's like grapes and other things that are non-soybeans and corn, something like that. So all in all, it looked up the NOAA estimated about $11 billion in damage from that derecho. So originally they came out with an estimate of $7.5 billion last year, but then I think they updated in January. So looking at the damage path, most of you might have seen this amazing image from Scott Lincoln out of Chicago, just highlighting the damage path there with at least the 60+ mile-an-hour winds covering a good chunk of this of Iowa into northern Illinois, and the maximum estimated winds were around 140 by the Davenport Storm Survey, but the measured winds was a home station out of Atkins, 126 miles per hour. Marshalltown, ASOS here in our area, we got a 99 miles per hour gust out of it. And so kind of put it in different perspective is, in the EF1, damage or greater, about 200 miles long, 40 miles wide. So that's around 86 miles per hour or greater is what that's estimated there. So looking a little bit closer as far as the damage, just kind of give you a little bit more perspective at it. The 80+ mile-an-hour winds was about 8,500 square miles. So that's almost the size of New Hampshire, certainly bigger than Massachusetts, Connecticut, and Delaware. But just to kind of put that in a little bit of perspective, and and then 100 mile per hour was about 2,300 square miles. So that's just bigger than Delaware. So pretty impactful. If this went through like a state like that, would just decimate it. So, pardon me. All right. So, for me, I was off for 3 days prior to this event. It's mid-August. I actually had a weekend off, so that's gold to a shift worker. So I was kind of just detached from all weather. So I came in at 7 o'clock that morning, got a briefing, and then 16 minutes later, the SPC issues an update on the day one outlook. So this is the original one at 12:29 a.m. that morning. So if you know our CWA, it's pretty much right smack dab in the middle of Iowa. So a decent amount of it was in the marginal risk. So we were expecting some severe weather potential that day. And then the update at 7:16 spread the slight risk further west to encompass the entire state, and then added the enhanced outlook for further east in the Davenport and Chicago's area. And at this time, they were kind of expecting the potential there for damaging winds and things and whatnot. So, and then looking at the 1 minute data from the clean IR, this is from 8 to 8:30 that morning. So you can really see the intense lightning data there, and as well as the cold cloud top. So, I told the departing midnight shift, I was like, this looks pretty darn intense. We need to get some more people in here. And so this was, I think, at this time, I know Omaha and Sioux Falls were having a couple of warnings out at the time. And so, from that on, from 7 to 8 is diagnosing the weather as far as figuring out getting people in. It's peak leave, and then during COVID, there's generally only 2 people in the NWS office at a time, unless we're expecting obviously severe weather, which we were. But normally we'd have a lot of people here already that we wouldn't have to call, but we ended up having to get about 5 or 6 people to come in, and they finally trickled in throughout by 10 o'clock. And then the SWOM CD comes out at 8:40, and so that was highlighting the potential there for damaging wind gust and a watch probability of 80%. And so that encompassed a good chunk of our CWA. So at this time, we're really kind of starting to ramp up operations. And at this time, this was Rod, our next speaker. He was the warning meteorologist for that, primary warning meteorologist, and he came in right at about 8:40. And so that's when our first warning went out, to about 10 minutes later after he got in. So he pretty much logged into AWIPS and issued a warning. And then a couple of minutes later, we had a watch dropped on us until the afternoon to encompass a good part of our central CWA. So, you know, I did make a pot of coffee that morning. I finally got a chance to get some, and then my wife called me and like, you know, I can't talk right now, so we'll have to get back to you. And then so it was getting a little bit crazy those first 2 hours of my shift. So again, additional staff made it in between 8:30 and 10 a.m. One of our forecasters who lives out west in Yale, I sent him a text right around 8 o'clock to say, hey, can you come in early on your evening shift? And he said originally it was going to come in at 11. And then I sent him an update. It's like, yeah, it's coming in a little quicker. So he was racing the derecho to come into the office. So he was actually, instead of the storm was chasing him that day. So I did write an AFD that morning. I started at about 7:30, and I looked at GFE, and it was still in my queue. And I was like, well, I got to send this out. But I did throw in a little bit of, winds when it's going to hit through the metro around 11 and 12 a.m. So it still came in maybe about 15 to 20 minutes sooner than anticipated. But it smashed through Des Moines and Ames area. So from throughout the afternoon, early afternoon, we were just dealing with phone calls, tweets, posts, radio calls on our local Micron network, into these chats. So it was one of the busiest shifts I've ever actually worked in the Weather Service. It was pretty phenomenal. So just before 11 o'clock, the SPC upgraded to mod risk, and rightfully so, with the amount of damage we were getting reported to us as it was blasting through the central part of the state. We dialed into the ASOS at Marshalltown before it lost power. And, Weather Service, just on a side note here, we spent a lot of time on graphics and, creating things like that for social media. But this happened to be our best tweet of the day, just a simple text as far as, hey, 99-mile wind gusts at Marshalltown. And that really just kind of highlighted the severity of coming further in eastern Iowa. So, that was pretty impressive. And then at 11:52, I know Rod used that information to put into his warnings. He mentioned 90-mile-an-hour winds and quarter-size hail. And then later we had another update at just after noon to mention even just 100-mile-an-hour winds in the hazard. So, and there was some really good coordination between Rod and the Davenport radar operator as far as what to put in the warnings and just kind of be consistent with that. So, a lot of times that kind of falls out, but he did a great job doing that. So, and one thing to mention too, I think the first warning for Marshalltown was about 11:19, so they had pretty good amount of lead time ahead of that. So our final thunderstorm warning was at 12:28, and then between 1 and 3, I had to finish up my forecast, write an AFD, tons of phone calls from the media. We had additional storm reports that we had to send out, gathering social media photos and and videos, and that's a time sink in itself, just gathering permission to use those photos and videos from people that post to our pages and stuff. So I went for a run after I got home at 3 o'clock, did some laundry, and then went out for some tacos. Luckily, my two boys were visiting my parents that weekend, so they didn't actually have to go to safety and whatnot. So my wife and I went out for tacos and a cold drink in the afternoon, so it was much needed. So this is from the Iowa Geological Survey. It's a real-time seismometer near Des Moines. And this just highlights the long duration of the severe winds. And it started just right before 10:30. And really it started to dissipate right around just after 12 o'clock in the afternoon. So, and these are 30-minute increments. You can see where the severity of it, so pretty much from 10:30 to maybe about 11:30. So that was one of the biggest problems with this derecho, is just the long duration, severe winds. And there's the great video here that's been shared and viewed a lot, that Cedar Rapids doorbell cam, about 30 minutes of just pure destruction of trees falling down left and right. It's pretty impressive and also sad. So this is another place near North Liberty. This is south of just south of Cedar Rapids. The peak winds there were 98 miles per hour, but really the over an hour of 58-mile-an-hour winds or greater. So that's why just the mass destruction of just trees and buildings and corn and soybeans and things like that occurred in that area. So, a lot of times, you get the severe thunderstorm warning, it lasts for, 5 to maybe 10 minutes, but this was not the case in the derecho. So power was out across a lot of the areas. This is captured at 2:14 in the afternoon. And obviously this was probably updated later, but at this time we had over 400,000 without power in just the state of Iowa. And this is a radio tower, WMT in Marion, Iowa, from Davenport, from one of their surveys, and they estimated for a tower like that to collapse like that was about 130 miles per hour. So that's pretty impressive. So the evolution for the peak intensity there was really kind of two distinct wind corridors, with the rear inflow jet as it moved into Cedar Rapids and Iowa City. And so there was that well-defined MCV, but then, you get the damage paths that were really evidence from that wind damage on the Sentinel. And that's one thing that I know if you probably viewed Kevin Skowes, I know he does a lot with the Sentinel data with tornado damage, but also it's fantastic for looking at straight line winds and things like that. So that really just highlighted where the biggest and most widespread damaging winds were occurred during that day. So, and then on to the last thing here. This is the satellite data at night. Obviously, you can see the day before the event, there was plenty of power, and then the night of, on August 11th, there was really no lights in that area. You can visibly see that, other than people that had generators, I suppose. So pretty sad to see on that part. So, and on that, it will move that on to Lee. I'll stop sharing.
Okay, yep. Thanks, Kenny. And Lee, we'll wait for you to start sharing now.
All right. You guys good there?
Yes, sir.
Awesome. Yep. Hey, well, hey, thank you, Kenny, there. And I just got to say, I love those, absolutely love those animated GIFs. I'll move this off of the screen so you guys don't see that. Really did sort of encapsulate the kind of hectic nature of that day. But as Kenny mentioned, I'll round out sort of the rest of this talk here by discussing the sort of change in character the derecho underwent as it crossed the Mississippi River into northern Illinois. And while you can sort of see that smattering of red dots, tornado reports there across central and eastern Iowa, the concentration of tornadic mesovortices, and even, as I'll show in a bit, embedded hybrid supercell tornadoes ratcheted up essentially as soon as this complex raced into our forecast area, which is this boxed area here in northeast Illinois, northwest Indiana. So this map shows the distribution of confirmed tornadoes that day after our damage surveys, as well as corridors of enhanced straight line wind damage. So those are these kind of gray outlined areas indicating winds in excess of 75 miles per hour. You'll also recall that image that Kenny shared at the start of his talk there, showing something similar, just a notable decrease in the breadth and magnitude of extreme winds across northern Illinois. But in the end, it seems like we kind of traded this wall of wind type aspect to a more staccato like areas of enhanced wind damage and tornado damage. So yeah, trading one sort of bad thing for another here. As it stands now, the 15 tornadoes, at least that we know of, arguably there were many more that we'll never know of here. This is tied for the second most in a single calendar day for our forecast area. This is behind the 2016 event, or tied with the 2016 event, and then behind the kind of infamous double derecho from June 30th in 2014. So I did just want to quickly highlight some of the science behind this. We're still sort of investigating. This is sort of ongoing research at the local office here, but from an established research perspective, we've seen the importance that wind shear over very deep layers has on sort of modulating MCS severity and longevity. So this is a figure from Mike Caniglio's 2006 work, which shows mean hodographs from a set of proximity soundings ahead of both mature and decaying mesoscale convective systems. And the sort of salient point here is the difference in the 0 to 10, 0 to 12 kilometer shear between these two cases. We're seeing about 50 knots for the mature subset, which is the solid line there, versus about 25 to 30 knots or so in the decaying cases. And if we sort of compare this conceptual model to what we're actually dealing with this day, this is the special roughly noon sounding out of the Quad Cities office there on that Monday afternoon. So outside of that slight veer back concavity you see there in the mid levels, this looks like a pretty close fit to those mature cases. We're talking about nearly 55 to 60 knots of bulk wind difference in that critical 0 to 10 kilometer layer here. So we'll look a little bit lower in the atmosphere. One of the unique data sets that we've got available to us at the Chicago office, with two pretty busy international airports in the backyard, is a fairly dense collection of aircraft observations. So these are centered essentially around Chicago, O'Hare, and Midway airports. And you can actually see the arrival and depart paths here, which is pretty interesting. Midway is a northeast to southwest oriented airport there. So you can see the southwest finals there. And Chicago O'Hare is an east-west. So you can see those kind of east-west arrivals coming in. And with this plot, we're focused on wind speeds from the aircraft around 2 kilometers. That's about maybe 6,000 to 7,000 feet. And each dot represents an aircraft observation, and each time step here is about 1 hour's worth of data. So plainly evident here, but I'll note something we didn't see in real time, just given everything that's being tossed at us here, was the pretty alarming increase in wind speeds immediately ahead of the derecho. We're talking 60 to maybe 90 minutes ahead of the derecho's arrival here. This loop ends at about 21Z. So you can see the median wind reports there for each hour in the top right increases from sort of a ho-hum 15, 16 knots in the morning when I got in to 35. There are even some 40 plus knot retrievals there just ahead of the derecho's arrival. So this is pretty phenomenal stuff. So you can see the impact this low-level mass response had as an enlargement to the hodographs really below 3 and even 2 kilometers. So these are both hodographs derived from the Chicago O'Hare terminal Doppler radar. The left image is about 90 minutes before the derecho hit. And then the right image is about 25 to 30 minutes before. So there's only a 1 hour difference between these two hodographs, and the root mean square error of these retrievals is actually pretty low. So we're pretty confident in a lot of these readings here. And the impact of those near 40 knot winds at 2 kilometers are readily apparent in this sort of right-hand image here. The 0 to 2 kilometer storm relative helicity just basically doubled in this time period to in excess of 200 meters squared per second squared. So these are just pretty remarkable changes we're talking about, considering the temporal scales of maybe 60 minutes or less between these images. So this is just another way to view this kinematic data in profiler form. So time increase is going left on this figure here. I've highlighted the sort of standard 3 kilometer level with the black line. And then this vertical red line is basically when the derecho arrived at our office here. And so if we move to the right of this line, this is just before, about an hour before the derecho's arrival. We see those high level winds I had mentioned there that Davenport sounding picked up. I think there's probably some augmentation of eastward advancing jet streak here you're seeing. But then here's this sort of notable, just kind of remarkable uptick in the 2 kilometer flow. Again, this is literally about an hour in these time steps here. So there's a ton going on in this image, way more than I have time to talk about in this brief talk, but we just thought this was really something else to see. And then $10 to anyone if they can find where the rear inflow jet is on this this image here. So we think the presence of this really enhanced deep layer shear with eastward extents, again, possibly augmented by an eastward advancing jet stream, played a pretty big role in altering the derecho's character as it moved into our forecast area. So this is a cross section from the Davenport Quad Cities radar just after noon. And you can see that strengthening sort of warm advection wing on the northern flanks of this system. This, essentially is a mini low pressure system, right? And so it's advecting all this warm air up on the north side. You've got these actual discrete supercells that are initially developing there across northern Illinois. And the main thing I want to point out here, though, is that taking a slice through the heart of this derecho, you see this sort of kind of up shear leaning complex here with an extraordinarily deep cold pull. I mean, some of the velocity analysis here would indicate, in excess of 12 to even almost near 15,000 feet with this cold pull. So there's, no worries that you're seeing these incredibly large swaths of extreme wind damage occurring across central and eastern Iowa. But now let's compare this a few hours later as this thing is just barreling towards our forecast office. And we've got these huge deep convective cores now developing aloft. This thing looks like night and day when you compare these two here. And you just don't get this type of huge suspended bounded weak echo region at 25,000 feet without a really strong deep layer shear in place. And so in this case, we've got strong effective deep shear cutting across our convective line. And, we'll take a breath here, but if we all kind of collectively head back to our mesoscale dynamics course and recall that linear forcing term in the dynamic pressure perturbation equation, this all sort of starts to make sense. Much like just jamming a log into a stream, this shear orientation produces that region of relative low pressure down shear of the updraft. And at the surface, this in turn forces a kind of vertical dynamic response on the leading edge. And we think this starts to explain the proclivity to generate these embedded hybrid supercell structures. We have the increased deep layer shear, the presence of these rotating mid-level updrafts in the presence of an increased amount of low-level storm relative helicity. So we've got a scenario now supportive of not only mesovortex genesis, but hybrid supercell tornado genesis as well. And so some of the streamlines kind of idealized in this case might look something like this. And the Yorkville area here is getting hit by this EF1 tornado. I think this is the 7th tornado of the day, if I'm not mistaken. So around this time, we're in contact with our primary backup office in central Illinois. They're on the on-deck circle now because we're obviously pretty concerned. Our office is right here with my little cartoon radar. And if this wasn't already bad enough to have a huge derecho coming barreling towards you, we saw reports of a huge fire that broke out at a styrofoam factory in Franklin Park. This is a neighborhood just east of O'Hare Airport. So you can see that sort of starting to show up there on the radar. And as well here, obviously one of the last places you want to be in a very elevated tower. I want to say O'Hare Tower, the primary is over 100 feet up there. They evacuated about 30 minutes after this image, and they went to what's known as ATC 0, and that's pretty rare. So essentially, there's no air traffic control present for a short period here, as this thing is just racing across the entire C90 TRACON. So this is a long radar loop. Apologies if this is a little blocky and skips on the connection here, but this is just sort of just a large overview of sort of the warnings and what happened on this day. The underlay is the RAP analysis 0 to 2 kilometer bulk wind difference. And so the colors themselves aren't important, but just wanted you to note that just incredible increase immediately ahead of the derecho's arrival. Those reds are about 40 knots or so that the RAP is analyzing. That was not present in the model guidance that morning. So obviously some storm scale effects likely ongoing here. One interesting thing I'll note too, outside of the warning polygons here, these cyan boxes are special marine warnings. And the special marine warning came out about 2.5 hours, something like that, ahead of the duratio. We actually would have gone longer with this. It's just we were kind of limited. 3 hours is the longest temporal length we can go for a warning like this. Lots of boaters out, even though we're in the middle of the pandemic here. There's a lot of marine traffic, and it takes them time to seek harbor, longer than say you or I to maybe get home and take shelter. So we try to get as much lead time with these, and seeing special marine warnings come out 2-3 hours ahead of an event, you pretty much have a high-end event like this to warrant a warning decision like that. So to wrap this talk up, I just thought it'd be interesting to quickly step through our operations that day. And just for some backstory, I think Kenny and I were in the same boat. I was actually called Sunday afternoon to see if I could fill in for the Monday day shift. I was actually going to be off that day. I was coming off of my midnight shifts, had a nice long weekend, as Kenny mentioned, beautiful time of the year to be off. And my coworker that day was actually with me on the midnight shift. So he also had a long weekend. We're sort of detuned from the forecast. And so I do my quick self brief that morning, and I see the marginal risk, don't really think anything of it. I think, oh, that's going to be pretty ho-hum day here. So boy, in for a shock the first couple of minutes of arriving into the office. So this is just sort of a timeline of how the day unfolded. My coworker got in at 7. You can see that double upgrade there 16 minutes later. I was the 8 a.m. shift here. So the operations tempo this day was arguably the most extreme I've ever worked. And this is after spending several years at the Fort Worth office working tornado outbreaks. I kind of liken our overall forecast message in the Weather Service to one of those big, heavy, multi-mile long freight trains. There's a lot of information parceled and packed in there, and it's really tough to get it moving off the line, or alternatively to make sudden stops and changes of direction. A lot of stuff has to change. So in this case, the forecast message just had to be enormously ratcheted up this day. And so these are just the various time steps here of the decision thresholds. You can see here, by 12:45, as Kenny had mentioned, just need to get bodies into the office. So coordinating that with the additional shifts. One thing that may also be underappreciated and something that I had actually forgotten was that the evening before this, there was all that civil unrest in the Chicago areas and surrounding areas. And we actually reached out to, we have a direct line to Chicago Office of Emergency Management and Communication. And we just reached out to them just to give them a heads up that, hey, the forecast is really changing against us here. And they had mentioned that we have like hundreds, if not, several thousand Chicago police officers out on the streets dealing with the remnants of the unrest. And so sort of providing that information, we were able to sort of open that line of communication to get them off the streets to start that safety process of informing them that this was all coming. So, and then another interesting thing that may, is unique to a Great Lakes forecast office was the meteo tsunami threats. And I think Davenport, the office, had passed along information about pressure jumps. They were noting 6, 7, 8 millibars in a matter of 5 minutes with this. And the line orientation with this duratio was not ideal to force a meteo tsunami. Basically, a large wave response bouncing off the Northwest Indiana shore and heading back toward Chicago. But this is sensitive for the folks of Chicago. 1954 killed almost a dozen people. It was a similar scenario. Big wind event comes through. And 2-3 hours later, the sun is out, people are back at the beach, and this wave arrives, 9-10 foot waves, and just swept several people into the lake there. Thankfully, didn't have anything like this this time. Again, not the ideal orientation here, but something as well to be cognizant of at this office. And we really appreciate Davenport. That it was heads up for them to pass that type of information along to us because we were able to utilize that in our forecast process there. So at this point, I will stop rambling here. Hopefully that kind of gave you all a kind of inside look between kind of Kenny and my talk here about how we sort of operated that day. But I'm not sure if we've got any time for questions here, but I'll turn it back to you guys here. I'll stop sharing my screen.
Okay, thank you very much, Lee, and thank you, Kenny. We did have one comment question that came in here into Slack regarding what was the public's knowledge of the risk leading up to the siren sounding in many of these communities. So either Kenny or Lee, any idea what the kind of the public perception was of the risk leading up to that day, and then suddenly the tornado sirens going off when maybe this wasn't the most well-messaged forecast event, especially with how poorly some of the models performed on this day.
Yeah, for Iowa, a lot of the counties, and it's not completely, I guess, consistent, but most of the counties do put the sirens on for 70-mile-an-hour straight line winds, which is good. And we've done a lot of messaging over the past couple of years, just trying to get that out and say, hey, your sirens are not just for tornadoes; it's for damaging winds. So. And as far as the public goes, there's still, I think, our warning said pretty good lead time throughout the whole event. And so I think they, I think for our area, they're probably maybe a little bit caught off guard, but further east as it goes, I think, and we did a good job ramping up all the messaging and just getting it out there. Just change, like what Lee said, just you got to really just change the messaging for the event. So.
Yeah,
Okay,
Kenny,
thanks.
I'll mention.
Yeah, Lee, any further comments, especially with the tornado threat that ramped up in Chicago?
Yeah, and Kenny mentioned this. We did sort of actually have the benefit of additional lead time with eastward extent, and I was actually a little surprised by the reach of social media. I believe the 3-day combined reach on the Facebook and Twitter post was something like 9 or 10 million individuals. And so the message got out there, be it from people looking at the feed and then passing it along to people they knew. So while the event was in and of itself a surprise, thinking of, back to the previous evening and the previous day, I think people knew to sort of change their plans, even though there was relatively short lead time there. The tornado threat, again, was not well anticipated, I'll say, from working that day. Just there's some very subtle features there that just were not seen in real time. And so I'd imagine that the Tor sirens going off, a bit of a shock. And I remember internally too, we were lamenting the fact that we didn't have WIAs for 90-mile-an-hour severes. Arguably that, is a situation where those would be really beneficial. So hearing that coming down the line, I think is pretty exciting. We'll obviously be using those in very rare instances, but a case like this, probably fantastic to utilize.
Okay, excellent. Kenny, Lee, thank you very much. And there was one additional comment that came in regarding the WIA and severe warnings. And keep in tune for news. I believe sometime towards the end of April or beginning of May, those IBW tags at the end of the severe thunderstorm warnings will start sounding WIA alerts. So keep in tune for news, because that is going to be one change that will be coming for this upcoming spring. Alrighty, our next speaker that we have will continue on the derecho. This will be presented by the lead forecaster at National Weather Service in Des Moines, Rod Donovan, and he'll give you a peek into what our operations were like here at the NWS Des Moines on this day of the derecho. So Rod, we'll go ahead and hand it over to you if you're ready to share your screen.
Okay, thanks, Alex. And I apologize, I'm James Spann's backup, so certainly won't be as good as the original, but we will try to give you a kind of an inside perspective of what went on in the National Weather Service Des Moines operations during the derecho. And Kenny touched on it a little bit. For those of you that were viewing the Central Indiana Symposium last week, you've already seen us talk, but we'll go a little more in depth with that. So as I mentioned, we do have a peek inside of what went on with our office. And I think that aspect may be interesting because, it's not from the outside, it might be we're just issuing warnings and that's really all we have to do. But certainly there's a lot of other things going on. And we have a lot of great speakers coming up that'll follow up with all of our green bin damage, the agricultural aspects and everything else that went on with this event. It's just really a truly impactful for much of Iowa and Illinois throughout. So this is a slide Kenny actually had set up, actually after the day is, was it a derecho or was it a land hurricane? And, obviously this is what we would classify as a derecho. It wasn't we weren't recovering from a land hurricane. It wasn't a level 2 hurricane. It was a derecho with wind speeds, upwards of 140 miles per hour per the damage surveys over towards Cedar Rapids. So, it did get a lot of press. Certainly, it was a prolonged wind event where we had winds that lasted from 30 to 60 minutes, severe winds. So that really ended up being a challenging aspect with it, and certainly contributed to a lot of the damage that occurred. So I apologize. These two screens aren't matched up, and Patrick will probably touch on this with the following talk, but this is the 0Z HER from the previous night. So like Lee and like Kenny, I was actually off the weekend. However, I knew I was going to be the warning meteorologist most likely on the following day shifts. And I took a peek at the 0Z HER, which ended up being probably one of the better runs with it. Click on the left-hand side, it actually had some convection going on initially, really dissipated it, and then had the main convection going and had really a pretty significant wind event going across. And on the right-hand screen, again, I apologize, it's not completely matched up. This is actually the wind forecast, 10-meter wind forecast. So you can see it really ramped wind up, going almost right in the exact area through, just north of Des Moines or towards Cedar Rapids onward across northern Illinois. So this really kind of alerted me a little bit to, now as we don't take these high resolution models or any models for certain, we have to really dig more into some of the more meteorology that it goes on with these events. I did dig a little deeper, and it did certainly pique my interest. And with that, I actually did call the office that night to see if they wanted me to come in yet. Want me in right away since we might have severe weather, and we'll get into some of those staffing issues coming up here. So as they talked about, we did have a rapid increase of the SPC outlooks throughout, much like we did with our forecast. Did have a slight risk cross mainly into Missouri. It was increased, as Kenny mentioned, and with an enhanced risk across much of Davenport's and into Chicago's and central Illinois' area. And then as the event was ongoing, it was increased up to a moderate risk as we were starting to get some pretty significant damage reports coming in just to our west, though we'll talk about that as well here. So staffing issues, COVID, we all were pretty new to it yet last spring. We were in phase 0, phase 1 staffing. So what did that mean? It meant we had 2 operational meteorologists in our operations area. We also had reluctance kind of to bring in extra staffing to the office. What happens if we bring in 3 or 4 people and have them all in one confined space, even if we are wearing a mask or not? We had vacancies. We had 1 lead forecaster and 1 meteorologist vacancy. We also were in the middle of summer peak leave yet. Typically, a lot of people tend to get in their last bit of peak leave, especially if you go into August, right before school starts. And for those that did start school, many of them ended up going virtual after that. But we had a lot of staffing challenges going into this event. So after a call-in, so I did not get a call overnight. I thought I might get one. So I did check in a little bit early on my TW shift at 8 a.m. So checking in TW still seems like a one-bag derecho setup. So I did get up early. I looked over the model data, what was ongoing, everything. And it just from personal experience, 1998 derecho, some other derecho, some other wind events I've been involved in. This really had to set up for what I thought could turn into a derecho setup. Now, certainly that wasn't certain, but really thought at that point, maybe we should get into the office. And then, Kenny responds. Kenny's just coming in as well. Yep, coming to the office. So I was leaving shortly. So like every National Weather Service warning meteorologist and me, that's the reason I'm in for the to be part of the warning aspect of it. I've been activated. I'm ready to go. So I'm coming in, much like Kramer does, and jamming all the way down. So 30-minute drive. Should say 30-minute drive to the office. So I do live in West Ames. So it did take a little bit to get there before I arrived. So my shift supposed to start at 8. I got left after 8 for the office. So what occurred? So storms are intensifying on the left-hand side. This is about the time I had half my lunch packed just in case I got activated to get into the office. I still had to pack a little bit more. So I left roughly 8:07, and this is what the radar looked like. So Des Moines, it's highlighted. Our county warning areas here. It's still in northeast Nebraska at that point. If you look at the LSRs, there's one severe LSR showing up. I believe that's Omaha's area, but the other ones are sub-severe at that time. And about the time I get to the office, what I have here is 1342Z. It's moving into northwest Iowa, starting to approach Denison. And you can see there's starting to be several severe reports at that time. So really starting to ramp up during my drive down. So at 1347, I should note that these are all in Zulu time. So 1347, that's actually, so 12Z and CDT time is actually 7 a.m. So we're at 8:47 a.m. Central Daylight Time at this time. DMX just had a Peewee personal weather station gust of 62 miles an hour west of Tacoma. So that's in Nebraska. And Sioux Falls mentions DMX, we are going to issue a severe thunderstorm warning just like OAX did. So this is what the warnings look like. Our area was the Denison Crawford County area as it is approaching. And at 1350, you see me joining chat. So one thing I did point out, I do have AWIPS warning perspective and auto scripts set up. So once I log into AWIPS, everything, I select my warning scripts, they all come up and I'm up ready to go pretty quickly. So this is not an advised thing. So typically we like to have our warning meteorologist spin up. I did do some self spinning up prior night and night before, but you don't want to have a warning meteorologist come in and have to issue warnings right away. But with our staffing levels, that's what happened here. And fortunately, I was mentally prepared to take that position. So at 13:53Z, 8:53 Central Daylight Time, I basically played Tetris, got a quick warning out for Crawford, part of SAC, and basically went with the generic 60 miles per hour quarter size hail. And that gave me some time to spin up further. As you can see, this is still, Omaha's area still undercuts us here a little bit, which will be the main area. So it gave me some time to actually spin up further during that. And I just wanted to point out also, the National Weather Service Omaha also issued a severe thunderstorm warning along the severe gust front. There's actually extreme winds, 60, 65 miles per hour going across Omaha, way out ahead of the storms. And that's going to become a problem for us as it goes across our southern forecast area, ways away from the storms. So at 14:10Z, 9:10 a.m., I increased it to a 70 mile per hour wind tag. So Kenny did touch on this a little bit. These 70 mile per hour wind tags across much of Iowa, our emergency managers have set that as a standard to at least activate the sirens, the tornado sirens across the area. And it's not an easy thing being that we tend to take that into account. Should we activate the sirens or not? Because it's not necessarily our call, but that is the policy. So once we put that 70 mile per hour tag in there, we know that sirens are going to be going off, and we don't want to false alarm that any more than we need to. So it does take a little bit of decision making to actually put that tag in there. And then note on this base velocity, there is some bad data in there, but at 14:51, Omaha did send us a message saying Aspinwall personal weather station just recorded a gust 80 miles per hour at 9:29. So thankfully, the National Weather Service Omaha was watching out for us, because we only had, I think at this point, we may have finally gotten our fourth individual into the office. But we didn't have time to look under a lot of this. We look at under the Wonder Map personal weather station page and try to go through each individual one. Unfortunately, Omaha was doing this for us, so kudos to them with the collaboration. Note they didn't catch it quite until 22 minutes later, so we didn't see it prior to then. But notice, and this was a problem with our personal weather station, even the Marshtown 99 mile per hour wind gust that Kenny showed, that actually went out when the electricity went out. So we didn't necessarily get the peak wind gusts with all of these. Aspinall, I will note the next day it did have some erroneous wind gusts. We're not exactly sure if this was legit or not. It wasn't certainly in the correct location with these yellow circles right here, but we had to take it into account with it. And that was our one report that came out. Otherwise, we weren't getting that many reports yet. And it might have been because people were losing power and losing self-service when this was going on. So wind was not our only threat, especially early on. We started getting some intense updrafts going on. And anytime other hail study I've done, 65 dBZs to 30,000 feet tends to get 2-inch or greater hail. And a lot of times they end up being baseball size or greater. But, we have this one storm up in southeast Sac County that was producing very large hail. So we do know we're getting at least some 70 mile per wind gust. Maybe that Aspinall report is correct. But right around 10 a.m., we got these intense cores going up as well. And also note, we have this QLCS tornado threat developing. Is that really going on? We got all these notches starting to go on around the front edge, southeast of Glid and down here. And we'll touch on that a little bit. Kyle and Jason gave a great presentation yesterday on the QLCS tornado environments and 3 ingredients method. And we'll briefly touch on that here in a moment. But in this case, the wind-driven hail became certainly a legit threat. So the staff's beginning to realize, by 10:13 a.m. that our office is coming in the path of it and starting to become alarmed. What should we do? All our cars are out in the parking lot. We're in a wooded area. Do we need to call our loved ones? We're all going to be personally impacted as well. So, everybody needs to stay calm. We need to stay focused on our task at hand. But, it's certainly becoming that we may be certainly hit by 70-mile-per-hour winds. We're certainly not completely sure what's going on. I should mention also another warning meteorologist aspect, especially with these morning wind events, is, we got really impressive velocities go on, really stretching way back. One of the big warning meteorologist quandaries tend to be is how much of this wind's actually getting to the ground, how much of that cold pool is getting to the ground, and it tends not to be all of it. So in this situation, we're getting 70-mile-per-hour winds. So we're not exactly sure. Some of us is showing up over 100 knots at this time, that this is all getting to the ground yet. So we're still sticking with the 70-mile-per-hour wind tags, but we'll be increasing them shortly. And then note that we do have a warning now coming into the Western Des Moines Metro and right up to our RDA and office. So our first 80-mile-per-hour wind tag, you can see velocity is increasing greatly, pushing that 100 knots. Not too far from the RDA with it. And at that point, the Aspinall report still our only significant wind report. So why is that? And mentioned again, I think everybody's losing power and we're just not getting the reports coming in. We're starting to get that classic rear inflow jet, the notch on the front edge, very reminiscent of the 2011 event that I was a warning meteorologist as well. At 1550Z, we're starting to get 70-mile-per-hour winds at our office. And our office is located about a quarter mile north of the RDA. You can see these impressive winds coming in just off to our west. So this is, again, all 100+ knot winds, and actually ended up being a big swath of really wind-driven hail through here, basically through Slater, Huxley, and just to our north, Madrid, and back to the northwest. So it really ended up being a pretty significant damage here. Actually, in here, it underperformed what the radar was showing, but still significant enough, 70 to 80-mile-per-hour winds. But, we did issue that big 80-mile-per-hour wind tag for the entire Des Moines Metro. It set all the sirens off. And as I believe Lee mentioned, and then Alex has mentioned possibly later on, WIA tags were not at this time in effect. So people weren't getting these alerts. That was one aspect we were discussing, and I'll come up on this in a minute. All severe thunderstorm warnings were the same, whether it's for 60 miles per hour, except for the sirens, the 70 tags that the GMs were activating sirens. But above that, we had one product that we could issue, for a generic severe thunderstorm or this high-end derecho event. And we'll discuss maybe the discussion regarding tornado warnings shortly. This is what our office looked like. Kenny touched on it also. Phones are going off the hook. Nonstop texts coming in from loved ones. We're checking on kids that are home alone. And I'll touch on it a little bit later. My one son was working at a golf course that was north of Ames, and he calls, kind of panicked a little bit. They let him off work, and he's supposed to be driving home, and want to know if he could drive to our place, which was, directly, basically perpendicular to what the wind path would have been. So I answered the phone quick. I said, I didn't have really time. I said, yes, drive quickly. And at that, he had about 10 minutes to get home, and he got into our garage, right as the wind hit. We ended up having about 70, 75-mile-per-hour winds at our house. But yeah, it was extreme panic, and we're trying to stay focused and get warnings out at the same time. So it was crazy. And the one thing, I will post to people is we had a few individuals that were calling and tying up our phone lines that were not severe weather related and outside the path. Do not do that to your National Weather Service office, because that was really caused an impact to our office, tying up our phone lines and allowing us to get actual legit reports so we can get it out to the public. Because it's just really non-productive for us and took up staff time and certainly caused some issues getting out some, legit reports and significant reports. So going back to the QLCS tornado aspect, what Kyle and Jason mentioned yesterday. So we had 40 knots of 0 to 3 kilometer shear, but it was actually angled at about 20 degrees. And if you took it to line normal, it was around 15 knots. And looking at the other aspects, our 0 to 3 kilometer cape, our vortex stretching was actually pretty low. Our surface vorticity wasn't great as well. So with us starting to get higher reports, 80 plus mile per hour winds, typically our QLCS tornadoes tend to be lower than that, though. One thing I didn't point out earlier, our line had actually sped up to around 60 to 70 miles per hour. So with QLCS tornadoes, that right side of a QLCS tornado tends to have, you have to add. So if your tornado's spinning at 50 miles per hour, and your line's moving at 70 miles per hour, the right side of those winds are actually going to be 120 miles per hour, while the left side is going to be basically dampened out by the line motion. So, it can end up being a more significant type of wind associated with QLCS tornadoes, but with the widespread wind, we opted to stay with the severe thunderstorm warning and not really focus on those QLCS tornadoes. Now, we did start getting some more notches off to the east towards Marshalltown. Do we issue a tornado warning for those? We do know we got it at this point. We're realizing it's turned into a significant wind event. Another one down here, it actually looks a little weaker by the SRM, but above the SRM tag, but we ended up having 2 small tornadoes here, and I'll touch on those in a little bit. But we opted to stay with the severe thunderstorm warning. Another aspect, I mentioned I was the warning meteorologist for the 2011 derecho that went across in the middle of the night. And this was at basically 4:30 a.m. Central Daylight Time, July 11th, 2011. So that's going through my mind. You're thinking about it. In that case, I did issue a tornado warning near the bookend where we thought the more significant winds were occurring. And in that case, an individual took shelter a few minutes prior to a tree falling through his bed because his daughter got the tornado warning that we issued. She wasn't paying attention to the severe thunderstorm warning. That didn't concern her because generic severe thunderstorm warnings, we issue them all the time, right? But she called her dad. He got up, got out of his bed, went downstairs, took shelter. Tree fell through his roof and through his bed. So it likely saved his life that we should have tornado warning in that event. So I'm thinking, do we pull out the tornado warning, even though it's not legit? We're not, our most biggest concern at this point is actually the winds. Not even really the mesovortices we didn't think there was a huge risk of them, mainly because the line normal shear and the low level stretching wasn't lined up well. But we stuck with those severe thunderstorm warnings, and then that'll be something we'll always think about. So our first 90 mile per hour wind tag came at 1652 Z. So that's at 11:52 a.m. CDT that comes out. And notice the impact statements. Now, if you're not looking at the impact statements, which maybe a lot of people are getting, they're doing the rip and read. You get the severe thunderstorm warning, and then you get the tags at the bottom. You're not seeing the impact statements. The impact statements do say life-threatening, flying debris may be deadly. Mobile homes will be heavily damaged or destroyed. Homes and businesses substantial. It really matched what actually did occur with this event. And one thing I'll think about, so did mention the 100 miles per hour in the hazard tags. Now, did that go anywhere? In retrospect, probably not. And in retrospect, I should note, probably ramped up these wind tags maybe a little slow. We probably could have got these out a little faster, but with the information coming in and everything, again, once it hit central Iowa, cell service basically went dead. Power went out everywhere. Just all kinds of distractions going on also in our office. I'm sure emergency managers and everybody else were having to deal with their own issues. So it was kind of difficult getting some of those reports in. So changing up gears a little bit, chat with partners. And here's some of the chats that we had with our partners. Now, I mentioned early on, we only had 3 people in our office. Kenny was busy trying to catch up on the forecast. We had Rogers in there. He was busy with a few other things and trying to get social media spun up. So I was the morning met, and also I was trying to get out some information, especially early on, to our partners in NWS chat. So we're increasing to 70 mile per hour winds, and the reasoning, you try to get the reasoning out, mainly for some of the broadcast meteorologists are in there why we're doing it, and they can understand why we're doing it as well, because they might not have time to be looking at the radar. Updrafts and storm organizations increasing, reports from Omaha, which was greatly appreciated. The 70-mile-per-hour wind tag for the Western Metro, 80-power tag, and then likely 100-mile-per-hour winds with that book in their TAMA right now. They're likely. Office collaboration. So I was touched on earlier. I thought the office collaboration with this was outstanding, and really, as we all quickly ramped up with this, with Omaha collaborating initially, being proactive, collaborating with us. NWS Pleasant Hill was proactive, and we'll discuss a little bit what they gave. But Omaha, 49 knots of red oak. OEX, okay, yep, got it. That's what that outflow coming through that we were concerned about, and we both decided not to issue a warning on at that time. Did it have 60, 65-mile-per-hour winds? And that'll be our area where we had some missed events with this. Storms didn't get in there. It was this outflow well away from the storms that moved across. So I went with Omaha because I was busy up here. We both agreed this is it's outflow. It should dampen out at some point. We'll go with SPS and not go with the warning at this time. Collaboration Davenport. Hey, Davenport, I just brought a rather large 80 tag to our border. That's something, from office to office, we kind of, you could grumble, oh, that office just brought a huge 80 tag toward us. But in this case, it was legit. And I actually felt bad throwing it out that big, but we had a huge tag that came out and it covered a huge area that had 80 tag. And, Davenport, thanks much. They actually lined up with an 80 tag then. So we had good collaboration of our tags going into their tags. And later on, I increased to a 90 tag. And actually, in that point in time, I called them and said that it's just much easier to call. We discussed what we were getting. We're getting that 100-mile-per-hour wind gust now. We're increasing to an 80 tag, etc. And just note that the polygons aren't showing up because the IEM took a hit with the power as well. Also, more collaboration with them. Thanks for the heads up. We're going all the rest of the way across with that southeast corner. That was the outflow. Davenport did ask about any reports. We did get a report near Chelsea. That was where the arrow's located, near that one notch, by the way. 80, 90 miles per hour. Davenport also wouldn't be surprised 100 plus there based on past similar events that I'd seen. So, we had really good collaboration with Davenport going from passing off from us to them. Also included SBC. So one thing you don't want to forget, NWS folks, make sure you include SBC on this stuff because they are trying to monitor, but certainly we're not seeing everything that we're getting. So if we're not getting the local storm reports out, make sure you collaborate with SBC. So SBC, we're getting gusts in excess of 100 miles per hour now. SBC, I think, extremely impressive. They had upgraded to 1630Z. They had already increased to the moderate risk, but they continue to enhance their messaging as well from information coming from us. And finally, Pleasant Hill. Look where the star is at and where Lamoni was. So our focus was up north. At this time we weren't issuing warnings. We talked to Omaha. We decided not to issue warnings, and then Pleasant Hill sent in. Did you notice the 54 knots at Lamoni? And no, we did not because we were focused up north. So thank you very much for NWS Pleasant Hill. So one thing I'll point out to that, there seems to be some animosity between offices collaborating. If you see something, do not hesitate to say something to your neighboring office in case they don't see it, because we did not see it. And if it wasn't for Pleasant Hill chiming in, I wouldn't have issued a warning further south to cover the rest of these 60, 65-mile-per-hour winds that went across. So use your surrounding offices if needed. They're there to help you. They're not trying to, overrule what you're seeing or anything else. They may have a different perspective or something else. So taking into account what they're seeing, they're trained meteorologists and warning meteorologists as well. So thank you, Pleasant Hill, for pointing that out and helped us get out warnings the rest of the time. So we issued a warning. They lined up and issued a warning next to us as well. So well collaborated, and we went into Davenport's area as well collaborated. So some challenges with the low lead time. The outlook phase had to rapidly ramp up with that, and that's going to happen. So we talked, some of the emergency managers are talking this morning, the EMs, the practice these events. And we try to do that internally as well, but you can't. With these extreme events, it's very hard to do that. But, the practice really helps out. COVID staffing was the challenge we talked about. 60, 70 mile per hour winds. Actually, our southern 2/3 of our forecast area had 60 plus mile per hour winds, which is just amazing. One tag is in siren activation was at 70 miles per hour. So, we had talked about that thought process early on. The NWA tags, which they are coming soon. So, if you got your cell phones, hopefully those WIA tags will be coming for the 80 plus, and I believe it's baseball's highest hail. That'll be coming soon. That should alert everybody, certainly much more than weather radios do now, because everybody's got their cell phones sitting by them. External distractions, they were all over the place with that. Storm directly impacting the office. And we heard trees popping. We heard the trees falling down. We didn't know what that popping was initially. It ended up being big oak trees dropping right behind the office. Issues with getting reports due to the widespread power outages. Warning polygons. I drew way too many warning polygons during this event. Warning polygons in AWIPS is set to a 0.01 degree lat-long resolution in AWIPS, which really needs to go out to thousands, because you end up getting a 0.3 to 0.6 nautical mile snapback, which you might see those little gaps in there. That's why. It's not the warning meter also it's this current limitation in AWIPS. So that ended up being an issue. And then trying to draw the warnings back to cover the extreme winds going on for 30 to 60 minutes. The 12 county limit due to NWR become an issue. Fortunately, I kept it under 12 counties, but that's certainly an aspect. And then, really the line itself, I don't mention it here, but the line that was moving at 60 to 70 miles per hour. So our warning time across our office ended up only being a little under 4 hours. That entire thing moved across our CBA in less than 4 hours, which is just incredible. But really made for extremely long day, and we were extremely mentally tired by the time that was done. How rare were wind tags? So we did mentioned the 90 wind tag. That was the first 90 mile per hour wind tag our office has issued since this is courtesy of Darryl from IEM. Since started having the tags in there, April 2010. That was also the first 90 mile per hour wind tag Davenport issued. We had, I believe, these are first issuances, I believe, not updated the SVSs. So this is the first SVR issued. It have 180 tag or 280 tags, I believe, from our office in this, and then one was upgraded to an 80 tag with that. But this is a number count. So since 2010, last 10 years or 11 consecutive seasons, 190 tag, 1480 tags, 159 70 mile wind tags, and you can see Davenport's percentage wise, same numbers, but 0.04%. So we brought our numbers up to 0.04% for 90 tag now. Let's hope we don't have to keep pushing those up. Obviously, that's an extreme wind. 0.5% for 80 tag and a little over 5%, close to 6% for 70 tags. Davenport's a little higher on both of those. So for me, I talked about personal distractions. I had a 15-year-old and 11-year-old home alone. Talked about my older son that was working, driving home. So I'm getting these messages across my cell phone during this time. So distraction is going to happen. And, Jane Spann, who, his house unfortunately was hit yesterday. He obviously had a big distraction yesterday. And he, take 10 minutes to compose himself, talk to his wife, and came back. And, from all accounts I saw, he saved a lot of lives from his on-air coverage as well, in addition to all the warnings that were issued down there and all the other broadcast meteorologists down there and others that were involved. So, should I drive home? Everybody has damage. I was coming to our office. Our entire office that was working that day had damage at their places. So I've never had, one other time I might have had that was August 2001 at Grand Forks office with 100, it would hit 101 at our office. But this is the pictures that we're getting. Water's coming into our basement now. The power is out. Now, my main concern was everybody okay? And once I had everybody was okay, I was able to focus on what was going on because everything was superficial. It could be fixed with that. So, not everybody reacted that way. And everybody has different reactions. So some did not, respond quite as well with that. And we had some challenges of getting around that in our office. So, and that will happen. Had something happened to somebody at my place, I would have had a completely different reaction, I'm sure. So, that's, you just don't know how you're going to react to that until it actually happens. But that task at hand, we had to complete the mission, and we had to try to keep saving lives and property as this thing moved across. Also, what is your starting lineup? It's all good to get everybody, practice and experience, but when these high-end events hit, you need to have your right people in the right spots. So this is kind of an example of the World Series last fall. If we have 3 spots to fill, and I have Clayton Kershaw, Mookie Betts, or Austin Barnes, and at that case, Barnes is our catcher. Kershaw, are we going to put him at right field, or are we going to put him at catcher? I think we better, in this case, Mookie Betts, is he our pitcher? Green Bay, at this point, you need to have your right people in the right spots for your operations to perform well. And that just doesn't include warning operations. So in this case, Clayton Kershaw was the pitcher. Austin Barnes was our specialty catcher, and Mookie Betts is our all-star right fielder. So, Kenny in our office is really our social media expert, and we're really glad he was there. Initially we started off without him on that, and he really ended up helping out with that. So don't be afraid to change up. Just because you have assigned spots initially, you may need to change it up and get people in the right spots. And once you get your experts in the right spots, things will flow much more smoothly. So, the lower end events, certainly that's where you get the experience. Take advantage of your experts once you get into the high events. And certainly your experts are helping out elsewhere, tutoring, throughout, but, make sure you have them in the right spots. This is quick satellite data. We talked about that wind-driven hail from that Sentinel data. I'll skip along from that. This is actually some grain bin rollers. Let me go back 1 second. So satellite down. I'm going to skip through these real quickly. You can see this presentation later, but grain bin rollers on satellite. Some of them went up over 2 miles, and this is what the grain bins looked like ahead of time. That place was actually hit previously during the derecho show of 2011 also. This is actually a tornado track that we ended up finding. Craig Kogel and I found on Sentinel data afterwards. The storm was moving at 70 miles per hour at this time. So this track was a little under 3 miles. So it was on the ground for under 3 minutes, closer to 2.5 minutes. We had 2 other tornadoes that were on the ground for less than 30 seconds. So a lot of that had to do with some of those environment limiters that we talked about earlier with it. This is the power outage time lapse throughout. So we all had power outages. I was out for 22 hours. Some of our staff was out for 5 days. I believe some places in Cedar Rapids are out for weeks. This is the middle of August. So, it's really high impact with that. Warnings wise, while we verified 18 out of 18 and the warnings look good, personally looking back at myself, could have done better, could have got the warnings faster, could have increased the wind tags faster. So it certainly wasn't perfect. And, we're always looking for ways for ourselves to improve with it. And finally, this is how I ended the day, cutting up trees at my place. Next day, we're still not done. We're doing everything. We're doing Weather Channel interviews, interviews with everybody else. So, the work didn't end from there. So thank you. And pass it back to Alex.
Okay, thank you very much, Rod. Just one comment on the Dodgers for Clayton Kershaw. Pitching them in the playoffs didn't work very well between 2015 and 2019. So maybe not always the best lineup, but worked well in 2020 for them. We have quite a few questions that came into Slack, Rod. So if you have the opportunity, once we're done here, go in there. But I think the one question that's been really common to ask here is the thought on PDS severe thunderstorm watches. We have a few people that are asking about that. So we'll go ahead and if you have a moment, comment on PDS severe thunderstorm watches, which was issued for this event downstream.
Right. And that was part of the thing that really came into, collaborating with SBC as well. So, I think if we had someone on from SBC, they could comment more on it, but certainly the PDS thunderstorm watches are very uncommon, and they're only going to pull them out for these, likely most of the time, these derecho type events where they are becoming life threatening with it. And then hopefully that's, it really, the SPC gets that out there, but then it becomes on to us, everybody in the weather enterprise, to get that information out to the public. Kenny mentioned we did have, I believe, 4 fatalities. 2 of those were in our area. One person was on their deck when a tree fell, watching it coming in. And as we're in an area, we had the 90-mile-per-hour wind tag. The other one, was a result of after with an electrocution. And I believe Davenport's area, the individual's out on a bike trail. So was our messaging not good enough? So the PDS, watches should be used, but we have to get that information out as well. And I think we really need to educate the public more on those as well. And that kind of falls on us with the weather enterprise. But yeah, us collaborating with SBC really and then SBC taking the initiative, getting that PDS watch out, and they are doing the same thing. They're ramping up quite quickly with it, and but we just really, this same. I'm kind of repeating myself, but we have to get that information out to the public as well to make it effective.
Okay, thank you, Rod. There's several other questions in Slack, so if you have the moment, take a peek in there and continue with the discussion. But I think in the meantime, for the conference, we will go ahead and move on to our next presentation. Our next presentation comes from Patrick Skinner in Norman, who will be talking about the use of CAMs during the derecho event and the performance and maybe some of the limitations of using these models for high impact events like this. So Patrick, it looks like you are sharing your screen and I see it. So go ahead and take it away.
All right, thank you very much. And yeah, and I'll be talking, we've seen really great overviews of the events and how they're forecasted and the radar evolution of those events. And so I'm going to talk more about the predictability of it ahead of time and how different numerical weather prediction models handled the environment and the evolution of the derecho before it happened. So as you can see, there's an awful lot of names on the co-author listing here. And I just want to mention this actually grew out of a really long email thread that we had at SIMS and SSL and SBC after the event, where we're just sharing observations of the event and then start to talking about, what if we ran this experiment with the Warm Forecast System? And that's really how the research grew out of. And so it's a nice opportunity for us to have a really highly collaborative group of people working on the same project. And okay. So Kenny and Lee and Rod have given a really great summary of the impacts of the event and an overall summary of what happened. So I won't spend much time on that. But just to highlight, some of the really big issues about this. Obviously, it's now up to estimated 11 billion in damages. It's the costliest single thunderstorm event in U.S. history. Sadly, 4 fatalities. And as you can see in the Sentinel imagery here, the before on the top and the after on the bottom, you have just an incredibly wide and extensive swath of crop damage across most of Iowa, and really terrible damage in Cedar Rapids and in many towns across Iowa, and people without power for up to 2 weeks. So that just speaks to how intense the event was, and it's certainly extreme in any sense of the word in terms of the magnitude of the events, also the duration of the severe winds. I know one of the SBC forecasters that we're working with said that he's been working 20 years, and this is top 3 in terms of intensity of derecho events that he's seen, if not the highest. So it's really an extreme event and really high impact. But despite that, well, actually, I take that back. I'm going to go to the how it was forecasted a little later. First, I'd like to show just a radar evolution of the event and talk about sort of the time period we'll be most interested in for this study. So this is a loop of MRMS composite reflectivity between 03 UTC and 22 UTC on 10th of August. So you cover the period from before the derecho develops out through it's crossing Lake Michigan. And then I've overlaid local storm reports on top of that. So you can see all the blue squares indicate wind reports. You can see that they fill in most of Iowa during the afternoon and most of northern Illinois. And then you see a lot more of the tornado reports pop up as you get into Illinois, like Lee talked about. Now, let this loop through one more time, and I want to highlight a few different areas in the evolution of this event that are going to be important for how well the weather prediction models handled their forecasts. So the first one is going to be this area in northeast Nebraska, and this is early in the event. So as we're going down, you can see there's multicellular convection along the surface front that dies off by 9 UTC. So there are storms in northeast Nebraska, but they're generally weak and short-lived, and they're generally gone by 09 UTC. And afterwards, you can see more robust convection that it initiates in southern South Dakota and northern Nebraska, like right along the border. And that's elevated multicellular convection, but as it gets towards 11 UTC, that congeals into an MCS. So now you have an elevated MCS that's approaching Iowa. And then really anytime after 13 UTC, I'll let it loop through one more time, that MCS is becoming surface-based, and you can see that the wind reports really start flying out of it at that point. Then you get extensive wind reports along the whole remainder of the track. So at that point, it's become a progressive surface-based derecho and is really a damaging wind event. So those are the 4 time periods that I'll focus on during this talk. And I'd also like to show for reference how was this event forecast by SBC and what's the evolution of their day 1 outlooks. And primarily, I want to show the 0600, the initial day 1 outlook, And as you can see, most of Iowa is in a marginal risk for severe storms or even general thunderstorms in western Iowa. And they note in the text of that the main issue with this forecast is the difference in model solutions. So the model forecasts vary considerably concerning the distribution of instability. So what they were left with was conflicting basically conflicting forecasts from different convection allowing models. And that didn't give them any confidence in any of the solutions from the different CAMs. And because of that, they were going to rely on observations, which makes sense. And so luckily, as they're very good at relying on observations, by even 2 hours later, they noticed the elevated convection initiation on the Nebraska-South Dakota border. And that led them to have more confidence in one particular CAM solution that did predict the possibility of an MCS across Iowa that day. And note the possibility for a weather watch, and then we're able to do a double upgrade, which is very rare in the 1300 day one outlook, and start talking about, I think, even a PDS watch in the 1340 mesoscale discussion. So they're able to really rapidly identify the potential for this event developing as the observations came in. But from our perspective is we want to know what would we have to do with the convection allowing models to maybe provide more lead time or more anticipation that this is possible before the event starts to happen, because that did not happen with the available convection allowing models that they had. And just to show you what forecasters were working with in 0Z forecasts on the night before the derecho, this is the high resolution ensemble forecast V2, probabilities of wind gusts over 30 knots, and it's for a period between 14 and 18 UTC. So right as the derecho is crossing Iowa and Des Moines. And you can see that the coloring here indicates paintball plots or swaths of wind from different models that make up this ensemble. And then the contours indicate the likelihood that any grid point is going to have greater than 30 knots within a, I think, 40-kilometer radius at that point. So you can see it's left with a really broad area of 10% likelihood of wind, and then one model, the HER, actually does predict the system to produce winds across Iowa, but none of the other ones do. So forecasters are left with a situation where they couldn't really be confident in any one of these solutions. They're just left with a highly uncertain forecast about what's going to happen the next day. And so our science question then is, could an additional convection allowing ensemble guidance have better predicted the directional potential on the 10th of August? And for that, we're going to use the Warn-On forecast system. And just for some background, WAFS is typically used for shorter term forecasting. It's used for forecasting individual thunderstorm hazards between the watch and the warning scale. And the general principle is that we use rapidly cycled ensemble Kalman filter data assimilation of Doppler radar and satellite cloud water path observations. We do it every 15 minutes. And the idea there is that if we're able to assimilate enough observations of existing thunderstorms into the model, we'll be able to accurately analyze those storms in our initial conditions. And if we have an accurate analysis of the storms, then if we issue a prediction based on those storms, we'll be able to accurately simulate it for a few hours at a time, and provide something that helps to expand the not necessarily the lead time of warnings. Well, I guess the lead time of warnings, or at least the lead time of anticipation you have before a severe weather event. And so we thought this was a neat opportunity to run WAFs in a different manner than we have in the past. So we're going to run it over a larger domain than normal, and that's indicated by the green shading in this plot. And for reference, each one of those circles there is a WSR88D site. So we're going to simulate radar data from all of those sites, as well as those cloud water path observations. And we're going to run it between this 03 and 020 UTC initialization time. We're going to issue a forecast every hour between 03 and 20 UTC, and we're going to run all of them out until 22 UTC. So effectively, we'd have a 19-hour long forecast at 03 UTC, and then an 18-hour one at 04 UTC, and so on. And so that can give us a chance to see how does this forecast evolve as we get the event going, and where's WAFS able to maybe add value that wasn't present in some of the other CAMs. So I'm going to show you a loop of the WAFS forecast initialized at 03 UTC now. And this is the ensemble 90th percentile value of the max wind gust in the model. So this is 18 different forecast models that we're running, and we're taking basically what is the 90th percentile value at each grid point across those 18 members, and plotting that. And anything colored orange corresponds to greater than 50 knot wind or severe wind, and anything colored red is significantly severe wind. And so this is data that are output every 5 minutes. So this is a 19-hour loop with an image every 5 minutes, so you get this nice movie quality to it. And then you have the actual observed LSRs overlaid on that. So the dark contours here indicate where the model has thunderstorms predicted at any 5 minutes. Sort of a light gray shading there is of paintballs from all the different members. So there's a lot of information here. But what I think is most important is the swath of winds that it predicts. So this is a sort of a reasonable worst case scenario, but it's predicting this really large swath of damaging winds across Iowa and northern Illinois. And it's certainly not perfect. It's displaced to the north of the highest density in the wind LSRs here in Iowa. But in general, this is pretty good. We were really surprised by this. This was not the result we expected. Because honestly, we thought that WAF's strength is typically from assimilating observations. And so if it's before the storms develop, there's no reason to think WAF's is going to do better or worse than another model. However, in this case, the initial conditions actually must have been very favorable for derecho development. So we got an accurate prediction right off the bat. And that gives us an opportunity to explore, why is this prediction accurate, whereas there's so much uncertainty in the different other camps? And so that's what I'll talk about for the remainder of this talk. So as for why did WAF's members predict the Iowa derecho, this is going to be a loop here on the left eventually once I animate it, but there's going to be the shading here corresponds to the ensemble mean of the most unstable cape. So just to give you a sense of where there's potential instability anywhere in the atmosphere. And then the green contours show you the dew point values at 700 millibars, and the wind vectors are also at 700 millibars. And then the gray shading as it gets going are going to be anytime any member in the ensemble predicts radar reflectivity greater than 40 dBz, we're going to shade it gray. So you can see where the storms in the ensemble exist. And so letting that loop forward, you can actually see in the 700 millibar dew point wind vectors, a strong area of convergence develops and moisture pooling in the Nebraska-South Dakota border. And that precedes this elevated convection initiation at around 0.9 or around 9 UTC. And almost every member predicts this elevated CI, and it has a nice long fetch of extreme cape out ahead of it. And so that allows it to grow upscale and then turn into the progressive derecho that it did. And there is a northward error in the location of this elevated CI. So that does lead to the northern displacement in the derecho track. So it's interesting to see that you have this error in the convection initiation location actually translates into an error in the track of the resulting convection of MCS. So that's looking at the most unstable cape. We also wanted to look at where to be able to predict when these storms were able to become surface-based and severe, and actually found that it did a pretty good job of that. So now we're showing the same loop, except with surface-based cape, and you can see that you have no surface-based cape where the convection initiates. But as it gets into western Iowa, it starts to intersect with the surface boundary and hits that reservoir of surface-based cape. And that corresponds with several things. You can see in the paintballs that they get larger in general and more cohesive and more of a bow echo type shape. And they also accelerate, it looks like, forward as they start to hit this reservoir of surface-based cape. And then that corresponds to a much higher density of wind reports in the observation. So that's a promising sign for being able to predict the evolution of the system, where it was actually able to capture the transition from elevated to surface base and the initiation of a lot of the most damaging winds at the surface. And so that's looking at just the 03 UTC forecast, and so showing some of the ways that WASP is able to provide an accurate guidance of the derecho in this case. But we also wanted to look at how did these forecasts change with time. This was actually our original goal with the study, because our expectation was that we would have a poor forecast in the first one we issued, but as these storms begin to develop in the observations, you would get a rapid improvement and hopefully a rapid change for the forecast so that it's able to better predict the eventual track of the derecho. So looking at it 0300, this is going to be the MRS composite reflectivity at the time the forecast is initialized, and then this is a swath of the likelihood of greater than 50 knot winds using a 15-kilometer neighborhood. And just for reference, that's pretty small. Most next day cams use a 40-kilometer neighborhood for producing a plot like this. So it's saying that there's a lot of agreement among ensemble members in the track and the intensity of this derecho. And so they all have produced high likelihood of severe winds across Iowa and Illinois. However, it is displaced northward from the storm reports. And if we jump ahead 2 hours, we now see some of those elevated storms along the surface front in Nebraska that were short-lived. However, you're not seeing a whole lot of change in the WAF's guidance. So it's still displaced northward, still very high likelihood that there's going to be a damaging wind event across Iowa. Moving forward to 700, and it's basically the same story again. However, when you go to 900, now you've had elevated CI in South Dakota. And it'll just toggle back and forth, and you can see there's a notable shift southward in the WAF's guidance in terms of the highest probabilities of damaging winds. And that continues as it assimilates more observations. So at 11, you're starting to get the first development of the MCS sort of along the South Dakota-Nebraska border. And now you can see that you've had a further southward shift in the WAF's guidance, and you have high probabilities of wind that pretty sharply outline the region of the greatest density of severe wind reports. So this is something that the rapidly cycled assimilation of radar and satellite data get you, is that as the forecast evolves, you're able to correct initial errors in that forecast and improve on the original prediction. So at this point, by 11 UTC and all subsequent forecast WAFs was very consistent in predicting the track of the derecho along the track that it ended up taking. So that's looking at the WAF's guidance. I also wanted to look at why did other CAMs miss the event. So I was going to go back and look at some of the individual members of the HRAF forecast that we looked at a few slides back. And in this case, each of these CAMs predicts spurious convection along the surface front in Nebraska. So this goes back to that original area we're looking at where these storms developed and then died within about 4 or 5 hours. And so I'm showing the truth, the enormous composite reflectivity here in the upper left panel, and then the HER reflectivity in the upper right, and then the Nisselwerf and the NAM nest in the lower ones. And just for reference, the Nisselwerfs and NAM nest were chosen pretty randomly. They're representative of all the non-HER members of the HRF, at least for this case. And so jumping at 4 hours, and now you can see that those storms in Nebraska are starting to die, and that's not the case in the Nisselwerf and the NAM nest. Both of them have weak MCSs in eastern Nebraska moving into Iowa, and extensive spurious convection throughout even southeast North Dakota, southern Minnesota. The HER also has spurious convection in Iowa, but it's a lot less extensive than the other members of the HRF. By 11, you can see something that I initially expected was that maybe they would struggle with the elevated CI in the Nebraska-South Dakota border. That did not occur. All 4 models have a pretty accurate prediction of where those storms would develop. However, if you look out ahead of them in the HER composite reflectivity, you have almost no convection in Iowa and Illinois, whereas in the Nisselwerf and the NAM nest, you have much more extensive convection. In the NAM nest, in this case, it's actually had an MCS that's gone mostly across Iowa and died. So that'll show up in the next plot. So looking at how that spurious convection translates into predictions of the storm environment, we're going to look at the most unstable Cape and 700 millibar wind vectors here now. So still is composite reflectivity at 11 UTC in the upper left panel. And in the HER, though, you notice there's now an extensive reservoir of Cape available to the developing storms, the elevated CI. However, there's some cold pools that are likely spurious or associated with the spurious convection, but there's still positive Cape there. Whereas the Nisselwerf is completely wiped out across all of western Iowa. There's almost no potential of instability available to these storms. And the NAM nest is somewhere in between, where there's still considerable potential instability in eastern Iowa, but western Iowa is pretty well wiped out. So as you'd expect, if we go forward into the longer term forecast now, if there's no instability in the forecast, there's not going to be any storms in the forecast either. So going at the 1700 UTC MRMS here, and then the HER, so 17-hour HER forecast. And you see the HER's done a very, very good job of predicting the location of this derecho or of the MCS, and the timing of it too. And I would mention that, the HER and the WAFs share a lot of the same initial conditions. So they're not identical, but they both are initialized in essence off the HER DAS or the HER data assimilation system. And that's probably one reason why WAFs was able to have an accurate prediction of this prior to CI. And then if you look at the Nisselwerf, you have no storms in Iowa, as there's a very large derecho ongoing in reality, and same with the NAM nest. So you have pretty dramatically bad forecasts if they were maintaining that original convection longer than it did in reality. So it's a pretty subtle error where, you know, there were storms there was CAPE there. And so you're basically asking a model to correctly predict these storms to die and maintain the available environment for the derecho to develop in. And most models didn't. Luckily, the herd did. So it wasn't, you know, that they all got it wrong. There was still some evidence that this is a possible solution. However, it was an unlikely one in the HRF. So that's a overview of what I was going to show. I've got a couple of addendum slides here, but in terms of the takeaways, that the anticipation of the derecho was limited, at least prior to basically this elevated CI that occurred overnight, by inconsistent zero-Z convection allowing model guidance. And the inconsistency was driven by this varying evolution of this nocturnal convection. So these were pretty innocuous storms, and whether or not a model predicted them to develop upscale into a weak MCS or die off made the difference in whether or not that model was going to predict a progressive MCS to develop later in the forecast period. So getting the forecast wrong in the first few hours of the forecast had really strong ramifications in terms of the forecast quality later on in that period. So that's a positive sense from WASP standpoint, because it's saying that if you get the first few hours of the forecast right, then you might be able to have a more accurate forecast for a longer period of time. And so that's something that did happen with WAFS and HER, where they were able to predict these short-lived storms were indeed short-lived, and they resulted in an accurate forecast of the derecho. And also, there is evidence here that, you know, the rapidly cycled assimilation of radar and satellite data does allow WASP to correct an initial northward displacement in the derecho track. And overall, we think that, you know, this frequently updating CAMs and CAM ensembles, they do offer the prediction for improved prediction of these highly conditional events like this derecho. I point out that, you know, one thing about the HRF is that it only has 8 members. So you think about it, if you had 16 to 20 members there, it may be subtle differences, but maybe there's 2 or 3 members that predict the derecho, whereas a lot of the other solutions still only have 1 member. So you're able to better refine the probabilities that are predicted by that. It's still highly uncertain, but it's at least more of a clue that that derecho is a plausible scenario for the next day. And along those lines, just going into future work, you know, one thing I've been trying to think about is, and this is based off a question I got at a different seminar, this is did the WAFS or HRF provide the better prediction? And truthfully, the answer is they both got it right. These are probabilistic forecasts. So, you know, as long as they're not predicting 0 or 100% for any single forecast, it's right. The question is, you know, once you do it for 100 times, do you predict 80% chance of rain in 80 of 100 forecasts and it only happens in 10? In that case, then you have a very badly calibrated system. So we don't know which one of these is actually right, but we can sort of guess at it just based on the looking at the output of the individual members. And one of which is that WAFS is probably overconfident. In this case, WAFS is fortunate that almost every member has an accurate prediction of the track of the derecho, but ideally we'd want to see some members that predicted that there would be no derecho. So in that case, it's under-dispersive or overconfident in its solution. And by comparison, the HRF then is giving an accurate prediction that it's a highly uncertain forecast, and that was true. So that may be representative of what the actual forecast uncertainty was, but from a practical sense, it didn't give forecasters anything to use because they didn't know whether any of these solutions was more likely than the other, and that allowed them to downplay or sort of discount the potential for derecho in Iowa in the zero-Z guidance suite. So there's an interesting give and take here between, you know, you want an ensemble to have some measure of spread so you can estimate uncertainty, but what kind of spread is the kind of spread you want? So this is now a loop of all the different WAFS members' reflectivity valid at 18 ETC from that 0300 WAFS forecast or initialization time. And I wanted to point out that, you know, there's 2 things here. One, every single member does have some evidence of a bow echo in eastern Iowa. So in that case, WAFS is really under dispersive. It's not giving you a lot of diversity in the different kinds of solutions that can develop here, but there's a lot of differences in terms of the timing, the size, the intensity of the bow echo. So there's still useful spread here in terms of the evolution of the event. So in this sense, you know, what kind of spread is the right spread is actually kind of conditional on what kind of forecast questions you're asking. And it's not an easy concept to create a one size fits all solution to. And that's something I don't necessarily understand well. So it's something I'm interested in learning more about in the future, but I just wanted to pull that up as a bit of a thought exercise. And then also talk about some other avenues for future research on this event. One thing I didn't talk about that Lee did a great job of covering was all of the different QLCS tornadoes that occur in Iowa. And we have a graduate student at University of Oklahoma who will probably be looking at that. That's Kelsey Britt, and she's gonna use object identification algorithms to try to identify areas of rotation in the MRMS reflectivity and azimuthal wind shear, and also in WAF's updraft helicity and composite reflectivity, and see how well, if at all, WAF is able to anticipate the locations where these QLCS mesovortices develop later on in the period. And this is just a preliminary example of that, where you can see they've different QLCS rotation objects highlighted with the background reflectivity overlaying there. And as you can see that the algorithm still does need quite a bit of refinement, because some of them flip on and off from one forecast to another. So it's a difficult thing to automate the detection of these things, but something that we're working on. Another aspect is we'd really like to work with SPC forecasters and then also the NWS forecasters in Iowa to understand the timeline that they had for issuing the products and how their forecast thinking evolved. So thank you to Kenny for providing a really great overview of that for the Des Moines office. And then to go back and sort of retrospectively assess, if this WAF's data were available the evening of the 10th, how would that have changed how you would have had your thinking basically in issuing products early in the development of the system. And finally, we would like to diagnose factors that resulted in the overprediction of that frontal convection and the HRF members, which I suspect are going to be very subtle, and then compare evolution of the HER to WAS forecast, because they do have a similar initialization. Are we able to see basically WAS be able to distinguish itself from the HER as you go forward in time? So is WAS assimilates more data than the HER, so is that additional data going to improve the forecast as you get closer and closer to the event? And I think that's about all I have to say about this. I do want to note that we do have WASFIC guidance available for the event at the URL located there, and we will start running WAFs in real time. We don't run it every day. It's situational. We typically run it during the spring because it's an experimental system, but real-time forecasts will become available in April, hopefully during the early period of April, if there's an interesting event, and then we'll run it for almost all of May, and those data will be available on that website as well. So thank you very much, and I'm happy to take any questions.
Okay, thank you very much, Patrick. That's certainly interesting to watch a model perform relatively well, or at least provide a solution that was closer to reality after spending several months looking at other models that we had operationally available to us on this day that struggled with it greatly. We did have a couple of questions and comments come into Slack, and I see more people are typing out here, but the first question that we'll go ahead and direct your way comes from Penny Sable. And the first comment is that the HER seems to, in a lot of events, nail the forecast in one run, but then completely change in other runs. And so I think what this is referring to is that if I recall from the night before, the 0Z run of the HER actually did pretty well, at least having some kind of MCS move across Iowa, and then it took that away in subsequent runs. Do you have any comments about cams that currently flip-flop like that and maybe could increase the uncertainty in the forecast?
Yeah, it's a great question. And I mean, my comment is that that's certain from a cam developer perspective, that's certainly an undesirable quality. You want to have, if the model flip-flops, you want it to be correct, that it's realized that the previous forecast was an error and it's going to lock into a solution that ends up being correct. And so having a jump back and forth is certainly an undesirable property. And that's something I wanted to mention, that's something I hope we'll see in the WAS forecast, because they were very consistent, is that they ended up not fluctuating from forecast to forecast as much as the HER did. And I think that would be attributable to, just the more rapidly cycled data assimilation is important for getting the initial conditions as accurate as you can. And if you have small errors in the initial conditions, that can have really large impacts in the resulting forecast.
Okay, yeah, very interesting. And then we still have time for one or two more questions if anyone wants to come in here. I did see just a comment from Bill Gallus, essentially mentioning that the fact that the 25-kilometer run accidentally didn't have convective schemes show that the derecho will suggest that it itself was relatively easy to forecast if there wasn't false convection the night before. So is there any comments maybe regarding how if we have a way to eliminate convection in particular models that we should be doing that, or how we can better predict the environment and make sure that previous storms are not modifying the environment in a false way?
Yeah, I completely agree. Well, so if you one way is to look at a coarser non-convection or resolving model, because that then, if that's giving you a better prediction of the environment, you can sort of overlay the CAM locations of storms on that and sort of, mentally swap in the environment. In terms of CAM initialization, though, it's a really difficult problem where you can use data assimilation. There are some models, including the HRF, that they start from a cold start where they have no hydrometeors in the domain when they begin the forecast, and all the storms just develop, naturally as according to locations of convergence and instability. And so you can get really different representations of convection early in a CAM forecast. And when you're using that to predict storms that are 24 hours out, as I mentioned, as Bill noted, there's, you're in really big trouble if the first few hours go really haywire. Then there's not a lot of reason to trust the remaining 24 to 36 hours in the forecast.
Okay, very well. Patrick, thank you for your time and for the presentation. At the current moment, I don't see any other questions that have been directed towards you in Slack yet, but if you do have any questions, go ahead, put them in Slack, and we'll have Patrick go back and check those later. But in the meantime, we will go ahead and carry on to our next presentation then. Our next presentation is from Nick Stewart, who is a meteorologist with KGAN TV in the Cedar Rapids, Iowa, which covers much of the East Central Iowa television market. And he will have the broadcast messaging point of view from the August 2020 derecho show. So Nick, looks like your screen is up and going. So I will go ahead and hand the presentation over to you now. Thank you.
Yeah, sure. I mean, living in Cedar Rapids during that event, it was truly quite the remarkable event. And as you've probably caught on already with all these different presentations, the way it ramped up from the morning hours through the early afternoon was incredibly fast. A lot of damage in Cedar Rapids, including to my home. The central right photo is actually my apartment. I live on the top floor, and we lost the roof. And when the roof came off, it also ripped all of the water suppression system. So, yeah, that was water is not fun to deal with. So unfortunately, I can sympathize with James Fan today. They're dealing with that. All right, there we go. So in terms of the station situation, what is my role during severe weather? Well, here's kind of a tidbit from May of 2019.
Folks, I mean, look at that roping out right in there. There it is. We are just north of Kelowna. I want to stress to you, if you're down there in Johnson County, this is a dangerous storm, a confirmed tornado. You're seeing it right there on the ground.
And like we've talked about it already a few times, this conference is that anytime you can get live video, you can show people what's happening, people will react. And so our mission at our station is always have somebody out there to provide live video, live reports. That's something that's so critical to us at our station. I think a lot of broadcast meteorologists and stations do an excellent job at trying to do this because, again, people will react if they see what's happening. Really, when you look at the day of what just happened, Eastern Iowa went from a 1 out of 5 marginal risk to a 4 out of 5 moderate risk, including a PDS severe thunderstorm watch, and really just less than 6 hours. And so it was a really, really quick ramp up of messaging on our side of things, trying to get the word out of what is going on. And the problem here is that, yes, we had that slow ramp up in the morning, but when you're looking at just a strictly TV perspective, the timing that a lot of this happened was incredibly unfortunate. That enhanced risk upgrade came out about 45 minutes early. The Storm Prediction Center did a great job jumping on it. However, at 7:16 in the morning, it was after our CBS morning newscast was over with. And so the next time we have scheduled news time is at noon. And look what happens between 7 a.m. and noon. We have that severe watch that goes into effect for our Western counties, a moderate risk upgrade. Again, well before they're traditionally issued, normally 11:30. This was before 11 a.m., but still before our new newscast. And then we had that PDS severe thunderstorm watch going up at 11:25. It gave Areas like Cedar Rapids, plentiful warning, upwards of an hour of warning with that watch if you knew to look for it. And that's just one of the biggest problems here is a lot of people were not weather aware. We're pretty somewhat weather savvy here in Iowa, I would say. We generally know if something is in the forecast, but if you tuned out after you watched the morning news, or even worse, but when you went to bed Sunday night, you had no idea what was coming. And this is what came through Eastern Iowa. This just shows some of our sky cam views. The top left camera there, that's from Iowa City. You can see it cuts out because we lose power at that site. Our Coralville sky cam and the top right camera actually has backup generator power and therefore stayed up during the entire time. The bottom left is from our Cedar Rapids sky cam, just kind of showing the before and after. You can just see the complete and utter destruction to the tree canopy. Cedar Rapids lost 60 to 70% of its trees, including, every block you go down, you lost trees. And then the bottom right there, all of our sky cams also have weather stations connected to them. And it's fun looking back at the data. And you can see, as has been alluded before, the winds weren't that quick gust front at the leading edge. We had gusts over severe thunderstorm criteria for an hour in most of our area. The top gust of 87 there in Coralville, still an 80-mile-per-hour gust, not too long after that. So just really, really remarkable event. Of course, the power situation was so brutal as well. The top left image there, that is 48 hours after the derecho. And Lynn County, where Cedar Rapids is located, was still 90, almost 91% in the dark. 6 days later, there were still 93,000 people without power. And by people, I mean homes or businesses. So it's actually more people than that were without power. And 10 days, coming up on 2 weeks, there were still 25,000 customers without power. And the top right GIF there kind of shows the slow ramp up of electricity. That morning right after the derecho was just startling how dark it was. I remember going out to my friend's home. Again, we lost our home, so we had to go somewhere. And, in a pandemic, it's such a weird concept because, we don't go to friends' homes. We weren't doing that, for like 6 months. Suddenly I have to live with them. It's just a total, trying to adjust to what is the new normal, what is the biggest problem now? And of course, this was the derecho. And you can see the slow ramp of electricity finally being restored in the week that followed. And when it comes to the news staffing side of things, I think it's really great, hearing from the National Weather Service side. It kind of gives me some context of we were all pretty much just ramping up in a really quick fashion. I remember sending a text to my news director, who those that don't understand newsrooms, the news director is basically the big boss of the news department. I sent her a text, I think the most underrated text ever. This has potential to be a big problem this evening. Quite the understatement, I would say. Our dayside reporters, which work in the late morning, early afternoon, none of their assignments were changed. The nightside reporters, they were all called ahead of time, letting them know that they might have to come in early. Our morning anchors, all told they will probably have to stay late. Our weekend meteorologist, Sarah Flynn, who is, she just started working with us that year. She was called in on her day off, and then I was coming in early to help with the live video side. So our game plan was in place at this point. We knew where people were going, what their strengths were during severe weather, and we kind of took it from there. When you're not on TV, you have to utilize what you got. And social media was one of our biggest allies in terms of getting the word out. We started doing a Facebook Live at 10:21 in the morning. We reached 8,900 people, kind of that preliminary heads up for much of the area, because at this time, storms were still more than an hour off to the west. At 11:30, we were almost doing 2 simultaneous Facebook Lives, one on our main Facebook page. We reached about 21,000 people that way. That was with the addition of the PDS, particular dangerous situation, severe thunderstorm watch. I did one actually on the road in the Storm Chaser talking about the PDS watch and kind of what we were doing and all of that. Here's kind of just a bit of a summary of some of those Facebook Lives. And you can really just tell, again, this is about an hour ahead of time, just how we were kind of ratcheting up the verbiage and our communication of what was about to come.
A rare, very rare PDS or
Just a heads up, Nick, for me here, your video's audio is cut out.
We are talking
Okay,
about
sorry
the
about that.
potential for widespread 100-mile-per-hour wind gusts, according to the National Weather Service and the Storm Prediction Center. So here's what's going on. Here's a watch outlined in blue. It includes almost all of eastern Iowa. There's a powerful line of storms going through the Des Moines metro right now and is really going to race down Highway 20, Highway 30, and Interstate 80. If you are in eastern Iowa, you need to take this storm, and today particularly seriously, okay? If you have loose objects outside on your porch, bring them inside. They can become projectiles in really strong wind gusts. If you're parked underneath trees, move your car away from those trees. Treat any severe thunderstorm warning today like it may be a tornado warning. We're Highway 100, we're going to be heading down Highway 30, and we're going to try and meet this storm likely on the Tama-Benton County line, and then we're going to try and follow it across Benton County before it'll
jump there.
Serious situation that's unfolding, and there have been some more updates since I was last year on Facebook Live. We have a severe thunderstorm watch that has been issued. Now, we've heard of severe thunderstorm watches. Perhaps you've heard of the term before, but it is a PDS watch, meaning particularly dangerous situation watch. This came from the Storm Prediction Center, and they, along with the National Weather Service, have put out this watch and indicate that there is a threat for wind gusts that could be up to 100 miles an hour. Now, they are saying that is likely. The Des Moines Metro has been I've just been hearing incredible stories out of the Des Moines area, and it is going to be a very serious situation that's going to evolve here in eastern Iowa, and particularly near and south of Highway 20 is where my greatest concern lies. So Sarah is here with me too, and you were saying that all of Ames is without power.
Yeah, they lost power. I know in Boone they said a lot of places lost power. There's a lot of trees down, power lines. I mean, you have 80-mile-per-hour winds. Just a couple of weeks ago, we had 70 here, and we lost power across the area. So that is expected, I would say.
Yeah, I would say we are going to have to get ready here for power outages, for trees to go down, unfortunately for crop loss.
So that was kind of a ramp up on social media. You can kind of see that an hour ahead of time, we were really trying to ramp up the messaging. And quite frankly, is you're talking about 100-mile-per-hour winds. But what does that mean? I mean, to a normal person, they hear 100-mile-per-hour. What does that mean? And so we were trying to kind of find ways to describe what that wind might do. We talk about the power poles coming down, the trees coming down, taking objects off your yard and all of that. We tried to find ways to really just tell people what 100-mile-per-hour winds might do. And quite frankly, we didn't really know what it was going to do. We did our first TV cut-in at 11:49 in the morning. This was kind of discussing the new warning, which was issued for Cedar Rapids and Iowa City, the breakdown of the PDS watch, what it meant, the hazards. And one note, that cut-in actually ran for 5 minutes and 5 seconds. Typically speaking, we do cut-ins for severe thunderstorm warnings. They may last 30 seconds to a minute. We try to make it a lot more thorough. We have kind of meteorologist discretion in terms of how long or if we do cut-ins. Again, we did another Facebook Live at 12:07. This was just basically a live view from my storm chasing vehicle. Also, I was commenting and answering Facebook Live questions as they were coming in. But look at the reach, 47,481 people. Just proving once again that live video is interesting. People tune in to live video. And in a lot of ways, this is how people got their warning ahead of time. We did then carry over our main TV programming over to Facebook Live. This was nearly 40,000 people reached here as well. My biggest regret here is that we didn't do this earlier. There were some technical issues why we couldn't do it. We have fixed those issues, but there were some issues why we couldn't get live with this sooner. However, as things are really going downhill in Cedar Rapids around this time, we were telling people, to take shelter. And now we're live on Facebook. So you can take us with you. Check us on your phone, get away, take shelter. You can take us with you that way. Obviously, it wasn't just Facebook. We did a lot of stuff on Twitter as well. And it's just fascinating watching kind of the ramp up of messaging. We start talking about a line of strong storms with some gusty winds. We're talking about wind being the main threat, showing the MDs, the weather scale discussion. So we talk about the watch being issued. There's my tweet at 10:55, Eastern Iowa, prepare now. It's right around 11 a.m. is when we really started ramping up the messaging and the potential for significant severe weather in Eastern Iowa. Again, just kind of talking about things. And I think it was Des Moines that talked about, the National Weather Service in Des Moines talked about just those tweets of just text, very basic information. Those did really well on our platform too, on our pages. When you just see substantial damage to Tama County, winds of 100 miles per hour, that was one of our best performing tweets of that day, because it's simple, people see it, and I think they kind of get the gist of how significant it is. In terms of the TV timeline, we did do a cut-in at 11:30, that cut-in at 11:49, which you talked about. Then at noon, we started our traditional noon newscast with weather. Then we took over normal programming at 12:06. There was actually about 2 minutes of news that we did before we're kind of like, we probably should just take this over. And then at 12:30 is when the storm actually hit Cedar Rapids. One thing I didn't actually know we did until about a week ago. One of our executive producers at our station leveraged the app that we push people to all the time and sent out a push alert to everybody that had our alert, our app, our news app, which is upwards of 25,000 people. It simply was just take cover now. And when you click on the link to the app, it takes you to our live coverage. And so just another way of unorthodox ways of trying to message this just unbelievable event. I mean, how do you do it? We were trying to just grasp at straws of doing everything we could possibly do to try and get the word and wording out. A bit of a longer format video here. This just kind of breaks down some of our coverage. Of course, I'm a TV guy. I got to show some TV coverage. So this is some of the stuff that we did that day.
We do have a severe thunderstorm warning for 80-mile-an-hour winds for Benton, Iowa, Johnson, Keokuk, Lynn, Washington counties. That's until 12:45. So they were putting this out for an hour to give you that kind of notice. And right now we have an incredibly intense, significant line of thunderstorms coming through the area. And we have a very strong thunderstorm that has produced winds of 99 miles an hour in the Marshalltown area. That is in the report from the airport. Williamsburg around 12:15, Newhall around 12:20, Vinton around 12:30, Cedar Rapids around 12:30 to 12:45.
And right now we are marching west on Highway 30 through Benton County. I'm gonna give you a look outside right now because you can already see the big shelf out here in the distance. It is a wall of water. It's essentially a hurricane over Iowa. Very intense winds now racing down Highway 30. There's a lot of leaves flying through the air, a lot of damage. Look at all the leaves and debris flying through the air right now. The core of those winds, upwards of 100 miles per hour, probably about a mile or two behind us.
You want to stay away from windows. You have reports out in Des Moines of some of the sliding glass windows that have been broken, fences going down, and we have just these incredibly strong winds that are going to be moving through. I'm going to time this out here because I know a lot of people have that question of when is it coming here? So it's moving, it's getting right to Williamsburg and Sigourney now, and moving very fast to the east at around 70 miles an hour, heading towards Williamsburg about now. Sigourney in the next couple of minutes, around 12:20. Vinton around 12:30. Cedar Rapids 12:30 to 12:40. Is about when this is going to arrive. So we have about 20 minutes or so before the winds start to really pick up, and we could be experiencing winds that perhaps get as high as 100 miles an hour.
We are on Highway 30. We're near the Van Horn area. Here's the strong winds. We are just in the core now. All right, Jason, if you want to pull over safely, you can do so. We are now in the core of really intense winds. We got a big burst right there. You can see we're going probably about 40 to 50, and you can see the wind is going faster than we are. The rain's going faster than we are. Intense wind with the storm right now. Right now, we are right near Van Horn. This is coming right towards you in Cedar Rapids. Very intense winds flying with the storm right now. You can see debris flying up the road. I wouldn't be surprised if we do see power lines go down at some point as well.
This is continuing to the east. So Nick is about here. This is coming to the east towards Cedar Rapids. And it is likely a bit weaker on this north side here, but still weaker means like 60 or 70 mile an hour winds as opposed to the 80, 90 mile an hour winds. So this is an intense thunderstorm that is going to continue to the east.
We lost the window. We lost the back window.
Okay, so we're gonna, if you guys can take Nick's mic down, we're gonna let them make sure they get to somewhere safe. But an incredibly intense thunderstorm is coming through. If you know anyone who's on the roads right now and that can get off of the roads that are on anywhere from around I-380 south of Waterloo to Cedar Rapids, on Highway 30, 151, Highway 6, Highway 1, I-80, incredibly intense thunderstorms, very low visibility. This is a dangerous thunderstorm that is going through right now and going to continue to go to the east. This will do more widespread damage than what we will get with just a tornado, unfortunately, because we're not talking about just one singular thing. We're talking about a big swath, big area. Highway 30, County Home Road B66. This is in Benton County. The camera is rocking. There are just cars totally stopped. Visibility is down. This is the intensity that is coming to Cedar Rapids and Iowa City. This is an incredibly dangerous thunderstorm. Lightning is ongoing. There are likely going to be power poles that come down and trees that come down. If you have to head out the door right now, try to wait. This is not something that you want to be driving out in. So there is the shelf cloud starting to come in, and we are going to be experiencing very low visibility, very strong winds here very shortly. Oh my, the doors just blew open in the studio. Wow. The doors just got blown open. Wow. You can just hear the intensity. Yeah, there it is.
It's 12:30, but it feels like very nighttime out there.
Yeah, I mean, wow. We have these very intense thunderstorms. It is very eerie. The building, oh my gosh. The building is shaking. It sounds like something fell on the building. I think we need to, we're gonna just assess how things are here, but the lights are shaking.
Yep.
Please stay inside of your home.
Please, if you're driving, pull over. Lots of cars have pulled over. Take shelter. Get inside a store. This is again tornado force, hurricane force winds. Our building is shaking.
Yeah, we have a very intense winds going on. We're gonna go into our master control to take shelter. We advise you to do the same. Very intense winds are going on. I'm gonna hope that you can still hear me while I do this. Here's a live look inside of our studio. Here's why we're not in it right now. But the lights, the ceiling is shaking. We can hear everything shaking in there. So this is why it's so important for you to be in that lowest level of your home. Here's a look at Broadcast Park right outside. So, I mean, yeah, everything's pretty much down. And
there are not many trees standing out there.
No, and things are coming down. There's just like leaves splattered. It's likely going to look like a bit of a, like it reminds me like after a hurricane, you step outside and you're dealing with this very widespread damage. We do have.
So, you kind of watched, through that, just trying to find different ways to talk about what's happening. I mean, some of the one-liners there, this is a dangerous thunderstorm right now. This will do more widespread damage than with just a tornado. This is an incredibly dangerous thunderstorm. This is not something you want to be driving in right now. We really tried ramping up the messaging as best as we could, because again, we're trying to communicate something that people have probably never experienced before. It's something that you probably don't see. A lot of people gave people a lot of flack for calling it, an inland hurricane and whatever. But it's all just semantics. I mean, I understand the meteorological standpoint of it, but we're just simply trying to communicate something that people can relate to. And this is all that we can possibly relate it to. Was kind of that hurricane. Inside the Road Warrior, the vehicle that I was chasing in, you can see the bottom right photo there. The back windows blew out. In retrospect, would have loved to turn the vehicle around into the wind, but we had a lot of issues with the wind and visibility, and we didn't know if it'd be safe to find a place to flip over. One of my friends screenshot me on a radar scope and spotter network there. You can kind of see the velocity data overhead. And then of course the west, I'm talking TV talk here, the left side of your screen, that is the actual weather station data that's mounted on our storm chasing vehicle. And what you can see is that in 7 minutes time, we had a drop of pressure from 1016 millibars down to 991 millibars, a very steep drop in pressure with that storm that came through. We measured 92 miles an hour and then 99 miles per hour before we had to shut everything down due to the water coming in to try and save the electronics inside. I would say that where we were was in that swath of 120 to 130 mile per hour winds. I think we easily were at 130 during the storm. We finally get to Cedar Rapids here. I want you to note this tower here on the left side. That is our TV station. We're right below that tower. This is the destruction that's the block behind our building. I guess you don't really need audio. But I mean, this is just one block in Cedar Rapids. And you can just see the absolute devastation to the trees. There's a lot of roof damage as well. Cedar Rapids really isn't a stranger to major disasters. We had obviously the floods of 2008, floods in 2016. A lot of bad things have happened to Cedar Rapids. And, unlike those disasters, this one affected the entire city. Every square mile, every block was impacted. Roofs off homes completely missing. I mean, this is what we were trying to warn people of. And severe thunderstorm warning doesn't do it. So it's just one of those situations where it's so difficult to communicate something like this. Obviously, we had a lot of destruction to the studio as well. At least $250,000 of damage to our studio. For a week, we essentially were renting diesel trucks to run out and power the generator at our transmitter to keep us online, because the transmitter site, all the high tension lines were out there, and about 2 to 3 weeks, they're running fuel there every single day. One interesting note too, the tower above our studio is rated for 100 mile per hour winds. In 2007, we had a pretty bad ice storm. I thought it was kind of fitting that the Joplin situation mentioned this ice storm helping preparedness too. That ice storm did some damage to our tower. They decided to add a 4th set of guy wires to keep our tower sturdy in the event of significant weather. That additional guy wires, set of wires, likely kept the tower from collapsing during the wind because it was not rated to withstand that kind of wind for that long. And if you know anything about these towers, they don't fall north or south or east or west. They're built to come straight down to minimize impact to the surrounding area. That tower would likely have fallen straight on top of our studio if that ice storm of 2007 didn't happen. Just one of those weird oddities. So, of course, covering the aftermath, management reached out to all of our reporters, photogs, producers, everybody to make sure everybody was okay. We had some people, that had, some damage, but thankfully we had no injuries besides myself that had some pretty gnarly cuts in my hand from flying glass. There was gridlock traffic everywhere. So trying to go out and cover the storm became incredibly difficult because you had roads blocked by trees and power lines. And then you have all these people that were out on a Monday, on Monday morning at work. Now they're trying to go home. They're trying to do something to check on people. And there's so many people out. And of course, all the streetlights are out. There's just so much destruction where it made it so difficult to really move around. Some of our reporters walked to work from a few miles away. Cell service was becoming increasingly spotty. Cell service actually worked, I will say, relatively well in the heart of Cedar Rapids until the following day, when likely the generators powering those cell phone towers for backup, those generators likely started failing. And that's when we really started seeing a reduction in cell phone situation. This is just one of the things that you had to deal with. This was me trying to get home to my apartment to check on it. Would not ever recommend doing this, but desperate times, desperate measures. That's just some of the scenes. I mean, and again, this was like a common thing. I mean, every block had road blockage, and what I don't show here, you can see kind of down the road, that whole street was blocked. So I had to come back through this anyway. All these cars were probably doing what I just did, realized they couldn't get through and had to come right back. We'll skip that for now. Actually, we do have some time. I have till 3:20. All right. So this is kind of some of our immediate coverage after the fact. Talking about, talking to some people that were right near a station and just some of the destruction that kind of came after.
I'm an island, so I'm like, ooh, what's out the window? Are you sure? And then all of a sudden it looked like you were on TV in Florida, you know.
I want to go back to that. One thing I wanted to note there, again, like on Florida, we talked to so many people that referenced it appearing like a hurricane. And so that's why I feel like our messaging there, that's like the best thing that we can compare it to. And I hope people were able to kind of relate to that. I keep hitting the wrong button. I'm sorry.
It's a dog and cat, I guess. So, and then we were just downstairs, and through all the windows we heard shatters and just clunk, clunk, clunk. And then we started hearing water come in our basement, and it was freaky, like nothing I've ever experienced before. I was just shaking. And just take a look at this. This giant tree has fallen over. It has literally busted the window of this car. There's damage to the house, not that much damage to the house, but there is damage to that house. And this is just a huge tree. I'm literally just standing in the middle of it. I'm standing by rubble in between it. There's panels from the roof. It is just an insane sight out here. And unfortunately, this is how the entire street in front of Broadcast Park looks. Like, it's bad.
Karen, this storm was vicious. This is just a piece of debris that was here in the lawn that I picked up. It blew from our facility, which is a good 30 to 40 yards away. It landed here after crashing in one of our vehicles. What impressed me the most, and what was really inspiring, was just how quick residents were to get out of their homes, to get in the streets, to help their neighbor. Take a look at this video that I shot. This was just minutes after the storm today. This is at F Avenue and Collins Road in Cedar Rapids, and you can see here massive trees down. You had one house with a tree on the roof. There was actually a branch that smashed through the roof down into the living room where the couch once was.
I want to stop right here just to note that you saw how many like trucks and things were already out and about. And like the rain is still falling at this point. Like people tried to start responding to a storm like they normally would. The problem was this wasn't like a squall line with a few trees down. Like the whole town was destroyed. And some of these trucks here actually came from Rockwell Collins or Collins Aerospace now, right across from our station. And they were using some of their heavy machinery to help the surrounding area kind of clear roads.
Residents didn't waste time, like I said, to get in the street, start moving debris out of the roadway to the curb so the traffic can flow through. I spoke with a few residents today. They say they will never forget the sound of this storm.
The first gust of wind wasn't as bad. It just kept picking up, and then we heard the branch go through the roof. And we were like, oh my God.
We're sitting there talking about moving the car across the street where there's no trees, but then we're like, nah, my dad's over exaggerating like he does. And then out of nowhere, boom, just a piece of wood hits the side of the house. Makes a loud bang.
It literally sounded like a hurricane was coming through Cedar Rapids, Iowa.
Another hurricane reference.
And I know that's crazy because we're obviously not by any water, but that's literally what it sounded like because I was like, oh my God.
Now back here in Broadcast Park, you're taking a live look now at some of the more extensive damage. This is near Old Marion Road. You see this one tree down, but the more significant damage is over here to our left. This tree's been here for decades. It just got slaughtered by the winds. You heard chainsaws earlier roaring. You have a family over here that's working to clean up the debris here at their home. This is a story we will continue to cover for many weeks ahead as we continue to recover. But luckily, the good news so far is we have not heard of anyone hurt.
I'm on the northwest side of Cedar Rapids near the intersection of Ellis and F Avenue, and you hear the railroad sirens going off. There's not a train coming. This is on top of the tracks.
So the amount of destruction in Cedar Rapids was really just remarkable. Coming from the TV side, some of our lessons learned. Getting Facebook Live of our broadcast up sooner is of critical importance. We were late by about 22 minutes. Again, we were dealing with some technical issues that we have finally fixed. But in the event of the lead up before the storm, Facebook, Twitter, and the web reached such a huge audience when TV was not. That day remains our highest day in terms of engagement and reach on social media on any of our platforms. We already knew this, but like those special longer cut-ins for high impact weather were needed. The assessment of wall-to-wall coverage earlier on, that's something we probably could have done. We took it over at about 12:06. We theoretically, I think, could have done it probably around like 11:45 when the warning started really mocking in our western counties. So some things like that. And of course, you want to practice that safety plan. You watched in the broadcast, our meteorologist in studio knew where to go. They went to the master control, which is like the control room for the building to go. The problem is that wasn't updated in the pandemic era. we had to kind of assess what is the bigger issue here. Is it the pandemic? Is it the derecho? And so we were making some changes on the fly in terms of getting people to shelter. So just one of those things to practice your severe weather safety plan, and also a huge kudos to our engineering staff. They do religious work on testing the generators, testing the backup everything, testing all of the maintenance. And we did not go off the air at any point during the derecho, which I still think is pretty remarkable. We had some satellite dishes that were destroyed in our farm, but none of the ones that transmitted our signal. So everything on our end stayed up during the derecho. And to everyone that might be an emergency manager, a government entity, a city official, utilize us. We are your best friend. We, the local media, I can't always say the national media, but at least the local media, I have control over that. We have great reach and resources to get that information that you want out. You can control the messaging through us. We, the local media, want to help and share your message. I cannot communicate that enough. Like, we live in your communities. We care. We have a lot of rumors that built up after the derecho. I mean, various things about fatalities and all of this. And we were able to clarify and report on this is not the case because we got comment from officials. So thank you all. And then of course, like, our main agenda is just serving the community. I mean, that's what we're here for. We're here to help you because, again, we live in the same community. And with that, I'll wrap it up. I do want to do a shameless plug, though, for our weather special, the Iowa Derecho in Their Own Words. It's an hour-long special. It takes place between noon and 1 o'clock during the derecho. It covers a bunch of different perspectives from survivors of the storm, people that went through it. It's just a really interesting story to put together. And it does it kind of 24 style in real time between noon and 1 o'clock. With that, I'll take any questions you guys might have. You also can reach out to me via my email or my Twitter account there.
All right, thank you very much, Nick. Very interesting to see the perspective, and probably some of the best videos that I've seen of the event came out of Cedar Rapids and from your station and several towers out there. Taking a look in Slack, at the moment, I don't see any specific questions, but certainly a lot of comments in there for you. But I think one question that I have here is that we definitely always see broadcast meteorologists break into TV when there's tornado warnings, but it doesn't always happen with severe thunderstorm warnings. And a lot of that has to do with the fact that severe thunderstorm warnings, the damage and threat tends to be very narrow in area. But now that you've gone through this particular event, has your viewpoint on breaking in for severe thunderstorm warnings changed, or has it changed any of your protocols for breaking in for something that's not a tornado warning?
It's interesting you say that, because actually in April, before the derecho, we had a really significant severe weather event come through Cedar Rapids that produced baseball-sized hail across the metro, right during like the late evening rush hour. And I made that executive decision to do basically a 20-minute cut-in because we considered baseballs falling out of the sky a problem. And so we stuck with that. And that was kind of the first instance that I can think of where we kind of bended the rules a little bit on our official protocol for severe thunderstorm warnings. As it stood, we would go on air for a warning, a quick break in, just here's a warning, here's the counties, here's what to expect, follow us on social for more information. They tend to be pretty quick. We've amended those protocols for 2021 where it still has, break in for a quick cut in, but then it also has or can stay longer via meteorologist discretion. It's still on the meteorologist interpretation of the threat, whether or not they want to continue with coverage or not. I don't think we're we don't want to overhype things, but in situations like this, kind of that's why we kind of amended the rules. So that's a good question.
Okay, thank you very much, Nick. I'm still seeing more comments come into Slack, but at this moment, I don't see any specific questions. So I think we'll go ahead and we will move on to our next presenter. But if you do have any questions or more comments for Nick, go ahead, put those into Slack. And Nick, if you have the chance, go ahead and then comment back on that. So our next speaker, as we have another Nick, we have Nick Abuasali. He is the mayor of Marion, Iowa, which is a town that is just northeast of Cedar Rapids within the Cedar Rapids, Iowa metro here. And this viewpoint will take a look at the local government response to the damage that was caused by the 2020 derecho. So Nick, if you're available, it looks like your screen has been shared successfully. I will go ahead and now hand it over to you.
Great, thank you so much. And thank you for the opportunity to present today. if you can see that I've entitled this "The Power of Community." This presentation, and the word unity and community is highlighted because that's kind of been our theme for the entire year with everything that we've gone through with the pandemic and the derecho and other challenges. And so it just highlights the importance of community and the importance of working together when major challenges come along. So it seems a very appropriate title.
Hey, Nick, just one quick comment. Do you have the ability to maybe go full screen with your presentation?
Okay. Let's see. Is that
there we
work?
go. Yep.
Okay.
Thank you.
Perfect. Okay, so just a little bit about Marion. Marion, as you said, is a city right next to Cedar Rapids, north and east of Cedar Rapids. It's a fast-growing city, about 40,000 people. It's the 14th largest city in the state of Iowa. Even though it's a newer, we have a lot of newer neighborhoods, a lot of new construction. Marion is actually one of the oldest towns in the state. It's older than Lynn County. It's older than the state of Iowa. So we have a lot of mature neighborhoods, older neighborhoods with lots of trees and very mature trees. So that's where a lot of the damage happened with the homes and the buildings was in those older neighborhoods. So on the day of the derecho hit, I don't think anyone here was really expecting it to be that severe. I recall my wife had called me at work and said, you know, there's a bad storm coming. You know, we're hearing from Des Moines. There's a lot, you know, heavy winds. So we talked about, you know, bringing in the cushions from the furniture outside, maybe bringing in some plants and that kind of thing. But no one ever expected that it would be what we got. And we heard later that this area was basically the epicenter of the fury of the storm, that the winds were up to 140 miles an hour. I was at work, of course, and then I just recall that I was on the phone and I looked out the window and it just became completely dark. And then the power went out. And so we went to the basement and we sat out the storm for about 40 minutes. I work in a 12-story building in downtown Cedar Rapids. And we waited till the storm ended. And what this photo on the left is the picture of the skywalk in our building after the storm. Trying to get home, you know, was an ordeal too. Streetlights weren't working. There was lots of traffic. All the roads were blocked. It took me about an hour and a half to get home to Marion from downtown Cedar Rapids. Tried every way I could to get there and had to turn back. I finally found a way from the north off of County Home Road and came down that way into Marion. So I didn't get to see a lot of the devastation in Marion because I live in a northern neighborhood where it's basically new neighborhoods, not a lot of trees. But then I got to my house and this is what I found because it's just wide open. Two sides of the house had all the siding sheared off, roof damage. The patio furniture had gone up and over the house and ended up across in the backyard of the houses across the street in pieces. We found our siding two blocks away. But still hadn't seen exactly what happened in the rest of the city. We got our house secured, and we had 8 rooms on the west side of our house had to have the walls completely torn out and new insulation, new drywall, new paint, all of that. But then after I secured my house, and that's what I think everybody was doing, then I took a tour of the city and was shocked by what I saw. It was really overwhelming to see all the houses with the roofs torn off, the older buildings, the historic buildings in our uptown. Just drove around and you know, most of the streets were still blocked, but the city crews were out already trying to clear the streets. And just some of the pictures here of the devastation. The picture on the left there was from a yard that had 43 very mature trees, and they ended up with 4 trees left after the storm. Couldn't even recognize the house. There's more views of the destruction of the historic homes and historic buildings. And I do have a video I wanted to show. So
If you needed to change your window, hitting the escape button on your keyboard may get you out of full screen there. If that doesn't do it, then clicking on those 2 arrows that are pointing in towards each other should get your browser back. And then if you need to, you should be able to minimize. And then if you need to pull up the video from another source.
if it doesn't work here, we can.
I wonder if you just go through the rest of this presentation and do it.
Okay, we might come back to the video at the end.
Okay.
Okay, so is the screen still minimized here?
I can still see your screen. It's like right now I see a picture of a big oak tree down, and then it looks like the picture to the right then of some debris.
Okay. Not advancing. Okay, sorry about that. Okay. So obviously the immediate impacts was, there were no power. There was no power. All the power lines were down, and cellular communications were very spotty. Texting was very spotty, and so communications was very hard. And so trying to get a hold of people to figure out what our plan is was the most difficult thing at first. But my instinct, I went to the fire station to find the fire chief, who in our city is sort of the head of the response to any kind of a disaster. So I headed to the fire station, and from there we just started organizing, calling people, and gathering. So the city crews were, like I said, were out immediately trying to clear the streets. And it was really all hands on deck for not just the city staff, but the entire city. I'm just really proud of how our city responded, because everyone just rolled up their sleeves, pulled together, and everyone just came out and said, what do I need to do? What do you need from me? And that just, in that kind of a situation, it just means so much to have everyone working together. For that couple of weeks, everyone set all their differences aside. If you remember, we were in a divisive election year, and everyone set their differences aside and just worked together and shared in the effort. So in a lot of ways, we were prepared for it because of the pandemic. In the pandemic, we were collaborating a lot with the city, with our community partners, coming up with solutions to keep people safe and to help everyone through the year. And so we just sort of shifted focus. The same people, the same leadership. We've shifted focus to the derecho for those few weeks. I recall one of our city buildings, which is a Law Park facility, had a generator and air conditioning. So we went out there and we kind of set up shop for a few days until we got electricity at City Hall, or got power at City Hall. So we went out to Law Park, and the chamber president showed up, and she said, "Where do you need me?" And we just sort of decided at that moment kind of how we were going to set everything up. The city manager and the city leadership team were working on the cleanup, and we sort of organized the humanitarian effort. At that time, we set up a hotline for people to call if they needed help, and another hotline for people to call if they were willing to help. And through that, we had one person that was matching up needs with volunteers to provide help and services and supplies to people that needed them. I called a city council member and said, "I'd like you to organize a neighborhood canvassing team." And so we called for volunteers, and then we had dozens of volunteers every day for about 5 days walk through the neighborhoods to talk to people, to see what they needed, and they just wrote it down and brought it back to headquarters. And then again, we matched up those needs with volunteers and make sure people were getting the help that they needed. We set up a donations hotline and a link that people could call or online make donations. We then realized that we needed to have a place where people could receive supplies and food, and we set up a emergency distribution center in the Uptown. And initially, we wanted to do it at the Marion Food Bank, but that building had down power lines and wasn't accessible. So we found an empty storefront in the Uptown, right on the main street, and called the owner. And right away, they said, "Here are the keys." And immediately, supplies and food were being delivered. That ended up being a place where they just served so many people, and it was a place where people came for information, for help, for supplies. We ended up having not only food, but pet supplies, baby supplies. We gave out gift cards for people so they can use them at the grocery store. People were coming from the entire region, as far away as Vinton, to receive help at this place. And it was just a kind of an amazing place. Every day we'd get a truckload from a different state, wherever people were sending help, and we'd unload it. And the next day, by the end of the day, it was all gone. But then the next day, more stuff would show up. It was kind of a really, as heartbreaking as it was kind of a cool experience to be part of that effort of everyone joining in and helping everybody, and seeing that all come together. And then, of course, we had the national organizations that sent help with food, prepared food, they set up in mobile home parks in the various neighborhoods and offered prepared foods. And so we were sending volunteers to help with that. And then by Wednesday, our city council had a special meeting, and then we hired the cleanup crew that was going to come and start the debris cleanup, and they started by the following Monday. So that was very quick. Our disaster recovery fund, which is the donations, we ended up receiving about $70,000 in donations, and that was all given out over the next few weeks to businesses and to residents in grants. And some of the money also went to resupply the food bank, as well as towards replanting trees. And then we set up as soon as we had power back at the city hall, we set up a incident command center, so everyone could be together in the same room. So there was no duplication of efforts. There was good communication. Everyone was in the same room. There were a clear direction every morning as to what was going to happen that day and who was taking care of what, and everyone just did their job. And really proud of how the entire team pulled together. Despite whatever damage they might have had to their own homes and issues they had to deal with personally, everyone came together and just took care of things and took care of the city. Communications obviously was very important in a time like that. People want to know, first of all, that they haven't been forgotten. I think that's the biggest thing. And we wanted people to know that they haven't been forgotten, which is why we sent the teams of volunteers into the neighborhoods. I personally walked through neighborhoods and drove through neighborhoods, and people really appreciate that, knowing that someone was looking out for them, and they want to have access to information. So with communications being so unreliable, we tried many different ways. First of all, we had a very vigorous social media communications campaign, but also we had people sitting at tables at the grocery stores and in various locations at City Hall. City council members, the library staff, staffed those booths, so where people could actually walk up and talk to a person and have a list of announcements that they could take with them about where to get help and what they need to do. We also obviously had the hotlines. We had the website. We did press conferences, and just tried every way we could, every avenue that was possible, so we can communicate information to people. Social media was really important. I know I was on social media several hours every day, just answering questions. People would tag me with issues, or if they saw a neighbor that needed help, or someone needed something. There was a lot of issues with insulin and oxygen and those types of things. So then people were tagging me. I would communicate with them and then get them the help, direct the information to the right people and get them the help. If I could myself, I was going to their homes and charging their cell phone or whatever, taking food, providing supplies, or getting the information to the volunteers. Any way we could, just again, to take care of people's needs and make sure that they knew that they hadn't been forgotten. We also leveraged all our relationships with the state legislators to get the governor's attention. And she did have a conversation with me maybe on the 2 days after the storm. And through that, we were able to get the National Guard to Marion to help out with the clearing the roads for the crews who were reconnecting power. She visited us 2 or 3 times. And then through her, we got the attention of the national government, FEMA, and the president, of course, who visited the Cedar Rapids Airport. And we had a chance to meet with the president and again, make the case for assistance. So some of the statistics, we expect when our cleanup is done, and we're pretty well done with the cleanup. We have, I think in April, we'll be finished with cleaning the waterways, the tree debris in the waterways. We will have cleaned up about 1.2 million cubic yards of just tree debris. This photo is taken in the first week. So that became a mountain, and we're actually sending the debris now to where it's being ground up and sent to a quarry, an old quarry. We expect to clean up about 10,000 cubic yards of construction debris. We've estimated that 41% of our trees in the public right-of-ways have been lost. And this is just a picture of, just to make the case for the loss of our tree canopy, which I think we all took for granted before this. But this is on the left, you can't see that there's a house there really. And then on the right is after the storm, and there's the house. So that's the scene that's repeated over and over again throughout, not just Marion, but in Cedar Rapids, the entire county. And as I said, we lost a lot of our public trees, and it's a surreal experience driving around town and places. Sometimes it feels like it's the first time driving down that street or in that area because there's so many trees that are gone. This is a very familiar scene that you see now around town, where trees still being cut down, just piles of trees everywhere. Our estimated cost for the cleanup is $43 million. The local share of that is estimated to be about $6.5 million. And positive stories that came out of the entire experience is that, as I said, it was a unifying event. It brought everybody together. It helped us realize the importance of community. Another positive story was the Splinters Project. Some high school students with Iowa Big got together and started this project where they engaged chainsaw artists to make artwork out of the tree debris, and they sold it in an online auction and were able to raise about $26,000. 40% of it went to the artists and 60% went for replanting efforts. So just another positive project. Another positive thing is, it helps us, or we will have replanting efforts, and we can do it in an organized way. And we all realize the importance of our tree canopy. I think, like I said, we all took our trees for granted before. And that is the end of my presentation.
Okay, thank you, Nick. If I recall you having trouble getting your video up earlier, did you want to try sharing that again, or do you think you know where that's at?
It disappeared. That's it. Well. I got work. It's not going to work. Sorry about that.
Okay. No, that's all right. No, thank you very much for the talk. It's great to see what the local response was. We've had the opportunity to see emergency management talk and speak from the FEMA perspective of things, and we've had the operational. So let's see here. I do have a couple of questions now that are coming into Slack here. So the first one is from Rod Donovan. And it's he asked, what is the #1 piece of advice you would give for communities that are undergoing severe storm recovery?
Well, obviously, you know, it from a community leader standpoint, I think, you know, communication is very important. Like I said, I think people look to their leaders in a time like that to give them the information they need, and they want to know what they should be doing, even if they, you know, sometimes you think, well, people can figure it out on their own. They do look to their leaders to give them guidance. So I think that's very important. Communication is always very important. Communication with your team and collaboration. You know, in Marion, we collaborate a lot, and everything we do, we involve as many people as possible from all different sides to make sure that we have as comprehensive a solution as possible to any kind of issue. So I think, you know, thinking that you can solve all the issues on your own, you know, is in my opinion, is not the right approach. It's, you know, everyone has something they can add, and I always look to form a team where everyone can make a contribution and solve the issue. And I think you get a better result that way. So communication and collaboration, I think, are the two important things.
Okay, very well. So we have a couple more questions in here. So the next one comes from John Wetter. There was a lot made at the time in the media and even the national media with delays in getting support in a timely manner. How much do you think that may have impacted the speed of the response?
Okay, so I'm not sure I understand the question. I guess can you read it again?
Yep, there was a lot made at the time in the media and even in the national media with delays with respect to getting guard support in a timely manner. Do you think that the media stories impacted the speed of the response in the area?
Well, obviously media always helps in something like this in terms of drawing attention to the issue. I mean, it's well known that the national media certainly didn't cover the derecho. So we were counting on our state government to make the case with the federal government in order to draw attention of FEMA. We were, like I said, the governor, I spoke with the governor 2 days after the storm. And, you know, after that, we were able to get the National Guard, at least here in Marion and in Cedar Rapids too, within a few days. But certainly, I mean, if that's the question, I think the media coverage certainly helps to make the case in a disaster like this.
Okay. And then the final question we have in here is, within the town or county, did you change any building codes, or will you be changing any building codes after this event?
Well, I think that's been discussed. Well, you know, that's certainly something that our building department will be bringing forward in terms of any needed code changes. We haven't done that yet, but it's been discussed whether or not we need to upgrade any of our building codes, because we did have a lot of roofs fly off of the buildings. Those were mostly the older buildings, the historic buildings. So, but that's certainly something we're going to be looking at.
Okay, thank you very much. At this point, I'm not seeing any additional questions in Slack, but if you do, you can go ahead and put them into there, and then we will relay those to Mayor Nick. But at this time, we're going to go ahead and move on to our final speakers for the conference. So our final speakers will be Mindy Benson and Craig Sash. Mindy is currently the emergency manager for Blackhawk County in Iowa, but prior to that served as the emergency manager for Tama County and served in Tama County when the 2020 derecho moved through. So she is here to talk about the impacts in rural Iowa. And then Craig Sash is an agriculturalist from Tama County that will speak about the impacts to agriculture as a result of the wind event. Do we have Mindy and Craig available here? I haven't seen any screen sharing come on just yet.
No, I actually haven't even seen them on the call yet.
Okay, Kenny, I know you were having other communication with them beforehand. Have you had any updates recently?
No, I have not. I know she was just driving into Des Moines when I called her at about 2:30. I'm not sure where she was in transit, but I know she said she had another presentation. I'm not sure if it was before or after this one. So
it was
after.
It
sound like so.
Yeah. Okay. Well, it's in the meantime, one of the things that we can do, let's go ahead and do our Midland Weather Radio drawing and get that going. So John, if you want to, can you put the Midland logo slide back up if you have that ready?
Let's get the one that actually, there we go.
Okay, so once again, so it's financial contributions to our conference. A big thank you to Midland USA for providing financial assistance to our conference to make this possible, as well as providing funding for the 2 scholarships, the Tim Samara Scholarship and the Pam Dale Scholarship that we have handed out to 2 students today. And for their sponsorships, we'll be raffling away 3 Midland NOAA weather radios. And so the way that we're going to do this is we're going to go through all the registries, and what I'm going to do is put a number into a random number generator, and then wherever that number lands in the registry list will be our winners here. And so earlier, to test it out, I had already chosen one, and so the first number that came up for me was number 68, and this was from Jax Smith. Jack Smith is our first winner of the NOAA Weather Radio contest. And so I will now go ahead and put in 2 more numbers into our random number generator and get our 2 additional winners here. And so our next winner would be Chad Crilly, who was one of our invited speakers earlier from Joplin, or rather from, I believe, from Jefferson City, but was speaking about the Joplin tornado. So Chad, I don't know if you're still here or not, but I will go ahead and add you to the list, and we will follow up with emails on how to get your NOAA weather radio that is sent to you. So that is our second winner. And then finally, let me do one more generate here. It looks like our third and final winner would be Austin Perot. So Austin, you are our third winner. And so I will go ahead and mark that down. And then I will have Kenny get into contact with you on how we will ship your Midland NOAA weather radios to you. But congratulations to everyone who's won. And once again, thank you to Midland Weather Radio for providing assistance and being a sponsorship for this year's 2021 Extreme Weather Symposium, being sponsored by the Central Iowa National Weather Association. So at this time, Kenny, do we have our 2 next scheduled speakers yet in the room yet?
I have not seen them come in yet. Let's take a short break, and I'll give her a call and see. She's technically not slated until 3:55, but so maybe she's coming in here shortly. So,
hey, Kenny and Alex, while we're waiting, this is Rod. Just a quick pass along. I'm gonna take over screen share just for a second, if that's okay, while we're waiting for those two to come up.
Yep, that would be fine.
Oh, me, I cannot. John, can you give me screen share for a moment?
All right, you should be good to go now, Rod.
Okay. So one thing to pass along, so we had John Stopkati and Aaron Johnson's presentation yesterday. I just wanted to point out that we have one other thing. I did send out the QLCS sheets that from the TWIP team that was referenced by Jason Shulman yesterday. But also on my screen, you should be seeing now, TWIP team just sent out to the National Weather Service Central Region offices this supercell based reference sheet. So what I'm going to do, so now that it's public to the National Weather Service, I will also send that link or send this file out to everybody afterwards. So this is going to have a lot of great information regarding supercells, including radar features, EDRRs, a lot of the stuff we talked about yesterday, separation vector angles, distribution, the survey, low level V, and this is some of the more information, ZDRs, some more of the applications for it. Just keep going along here, the KDP foots, etc. We talked about, we had Matt Wilson on yesterday talking about separation vectors as we've gone through in his place file also with it. And then finally, a couple of these last pages here. So a lot of good information that John referenced yesterday. We're planning on, we'll have a laminated copy of this and the QLCS sheet, certainly in our warning operations, but I'll plan on sending this out to the registration list, and I'll hope to get that out soon. And hopefully everybody's getting these. We are blind seeing everybody, so hopefully a lot of this isn't falling into your spam email, but look for this. The other sheet should have came out earlier this afternoon, and I'll send this sheet out later today. All right, thanks, Alex.
All right, thanks, Rod. Anything? I saw an email go out earlier, I think, from you regarding LSRs and then scoring for the radar workshop. Any update on the scoring for the teams and verification that you want to provide for our radar workshop participants?
Right, and so right now, as the local Southern offices are going through all their LSRs, so there wasn't a lot of LSRs that came out with the offices yesterday. They must have got pretty busy with it. So we'll be working with Daryl, and we're going to try to get the most up to date as possible with them doing storm surveys. A lot of this stuff might not show up in LSRs, but we're going to do the best we can with scoring over the next couple of days, and they get those sent out.
Okay. Yeah, Rod and Alex, I just got off the phone with Mindy. I believe she's in the room. She's ready to share her screen. Mindy, can you hear us? Maybe.
I still don't see her user account on the session.
Yeah, I don't either. So.
Do you want to verify that she would receive the correct link?
Yeah, she did. I sent it to her. She said she was in the room. Maybe she's in the wrong Zoom one. Maybe that's it. I don't know.
Didn't accidentally go to the radar workshop one from yesterday, and we also
Maybe that's what she's in. I'll call back and verify.
Okay, I don't see any breakout rooms that we have that they may have possibly have gone into here. Just going through Slack, definitely seeing some very devastating pictures for those of you that either lived in Cedar Rapids or had friends and family, all the pictures and all the before and after. And it's really weird to look at satellite in the Cedar Rapids area of some of the older trees that were there, and what it's going to be like driving up and down some of those streets where before you couldn't see far up the street in the summertime because you had so many trees with leaves, and now you can see a couple of miles up the road. But definitely we've had some interesting presentations, and I really have enjoyed so far these derecho presentations. I actually was on mid shifts when I was getting ready to start mid shifts, but I actually started my day of the derecho watching the cumulus clouds form from my bike, and I was going to keep going for about another 45 minutes, and I get a severe thunderstorm watch on my phone and realize I probably need to turn back around and go let the dog out before we get hammered. And sure enough, I ended up losing power for 3 days here on the north side of Des Moines. So we'll see, I'm gonna do a double check, see if Mindy Benson or Craig Sash is back in our Zoom session just yet. Looks like I'm getting a couple comments that they may be in Slack successfully.
Muted.
Okay, I think I hear you.
There it is. Wonderful.
Yeah.
Sorry about all the technical difficulties, everyone.
Oh, that's all right. It's the world we live in right now, doing all these virtual conferences. So
Right.
if you're ready, it looks like I see your screen. So if you want to, you can put it into full screen mode, and I will go ahead and hand things over to you.
Well, let's make sure I get it to work here. There we go. Okay, perfect. Well, thanks everybody for allowing me to come and do this, or Zoom and do this, I guess we should say. This was kind of, I was with Tama County at the time that the derecho happened. I am now with Blackhawk County, so I have somewhat moved on from the derecho, but not technically. So you'll see that I'm now with Blackhawk County Emergency Management, formerly with Tama County, but I'm still very well involved with helping Tama County recover and keep everything going with the FEMA process. So we'll just kind of jump into it and start going. So, you know, of course, our wonderful August 10th date of 2020, that's what everything looked like in Tama County prior to the day that will live in infamy with the rest of us. So that morning, you know, mid-morning, we kind of saw the forecast come out for our county, and we saw that PDS. It's like, what has this ever truly happened for us before? So as, you know, emergency managers, we all kind of hone in on things like that. You know, what is actually going to happen? What does this mean? So a lot of us, including myself, we get logged into NWS chat, we pull up our radar, we see what is going to happen that day. That way we can see what storm reports are coming for the west or the south or wherever it might be, so we can pay attention to damage reports. And right before, it was maybe 20 minutes before the storm is going to whack Tama County, I guess that's kind of our official derecho terminology now that we're being shared around the state. The Des Moines office called us and said, you guys are going to have a severe wind event or a big wind event come into your county. So just to let you know, and I don't really remember much else from that phone call other than you're going to get very high winds, you know, at least 70, 80 mile an hour threshold. So at that point in time, I used our PA system, as we call it in our office. We have the Tama County Human Resources Director, Tammy Wise, was also in there. So I used our PA and I literally yelled down the hallway and asked her to help me start calling offices, because we didn't really have a great notification system in a short time to let a bunch of people know in our county, whether it be our 12 communities plus the Meskwaki settlement and our 9 outlying county offices, to know what's going on in a short amount of time. So as I'm calling them, I was calling the communities, Tammy was calling the county offices. I was seeing the continuous, constant flow of data and updates coming in on NWS chat. And I really got a fast sense of what was coming down the pipe towards us. From Boone County and Carroll County and Story County, and knew that this was not going to be a pleasant day for us in Tama County. And just kind of a jump ahead a little bit, since that storm and my time after the storm, I had since changed how we notify cities and county offices of what is impending of the weather. And then pulled up the weather teletype information that comes out on inlets. And of course, my eyes immediately jumped to Tama County, dangerous storms, hazards, how it was indicated to us, of course, what the impact was going to be. And of course, that extremely dangerous situation of what's going to happen. You know, my stomach kind of dropped immediately, because I've been in public safety and doing this for 20 years now, and knowing what all of this means for us, and just knowing we have people that I still can't notify. I can't get this information out to the public fast enough. I can't get this information out to people who might be camping, might be traveling. It bothered me to know that I can't get this information out to everybody across our county to keep them safe. And wondering what was going to happen if we had somebody that was stuck outside. So I took this picture out my back door, and this picture actually doesn't do the storm justice, because the storm, you could just feel it when you open the door. There was such an intensity, and you could hear it rolling. There's just no way to really put it into words. And the colors of this picture just does not do it any justice either. It was more of a dark blue and a green color. And I went back in and was talking to our maintenance director who was at our building at the time. And I told him, I said, there is a lot of green and a lot of black in this storm. And he goes, oh, it's just hail. It's not going to be a big deal. And I just told him, I said, something in my gut is not telling me that it's just going to be hail. This is going to be much, much worse than we ever anticipated. So he goes, oh, it's not a big deal. We'll be fine. Just don't worry about it. So I said, well, you want to put some money on that? And he kind of chuckled and walked out the door. So we started pulling up the radar even more. And this was a radar shot that I got from Chad Hahn in Des Moines as it struck Tama County and the Tama Toledo area. So as you can tell, we really got a pretty good indication of what hit us at the time that it hit us. And right after it came through, we were still dealing with a lot of flying debris and travelers and everything else. And we just knew kind of that moment of impact and moments thereafter. As I'm trying to update everybody on NWS chat, so broadcast media and National Weather Service and anybody else on NWS chat could know what was going on. I was trying to give them updates. I wasn't even on there maybe a minute or two when the storm hit and the power went out. I don't have a backup generator at my office, so I was not able to keep everybody in the know of what was going on. That was just it. And as soon as the wind hit our building, literally sounded like the roof was picked up off of our building and slammed back down on top of it. I'm really surprised the windows held on our building. So I think it was about 11:44, it made it into the west, just the western edge of Tama County. And about 11:52, it hit Gladbrook, Montour, Lincoln, the Meskwaki Settlement, Garwin, Toledo, and Tama. And it just continued to roll east just at that furious wind speeds. About 11:58, it hit, of course, Chelsea, Vining, and Traer. About 12:01, it hit Cloutier, Elbron, and Dysart. And of course, Tama County is about 722 square miles, and it hit every community in our 722 square miles. There wasn't one community that didn't have some type of damage, whether it was a tree down, broken window, shingles off of a roof, or a complete building collapse. We had damage in every portion of Tama County. It was just something we had to deal with. And as one single emergency manager, it was really hard to figure out which direction to go in first. We had, at one point in time, 100% of the county without power. There was power poles snapped, power poles across the road, power poles at angles, lines across the road. Citizens couldn't tell if it was a cable line, if it was a power line. It was just kind of sheer and complete chaos at one point in time. In the midst of this wind going through at anywhere from 70 upwards of 100 miles an hour or higher, I did call on a portable radio and asked the dispatch center to set off what outdoor warning sirens we have access to, and that transmission never made it one block from my office to the sheriff's office. Our radio communications were just kind of obliterated due to the wind speed, and the antennas on our radio towers pretty much bent facing due east. And we also lost a radio tower, which I have a picture of. We just were kind of, I want to say dead in the water for just the time that the storm was coming through. So if this will play, I won't play all of it because it is about 8 minutes long, but this is a clip that I got from the DOT on Highway 30. And it shows the camera a little bit of how the storm, everything was fine. You can see the trees start to blow at this point in time, and then it just hits. And we had, I believe, 2 semis that were blown over, one on Highway 63 and one on Highway 30. Neither of the drivers were injured, but we still had issues getting responders to them because of all the lines down and the trees down as well. So knowing that, kind of in my mind, what I'm thinking at that point in time when this is going on is, okay, I know counties to the east of us are hit, counties to the south of us are hit. It's going to hit to the west of us. I don't know what it did to the north of us. How are we going to get responders or additional responders into us if this is a mass casualty, if this is a mass fatality? We don't have enough law enforcement to help with directing traffic around all of this debris. We need to figure out how to get this debris off the roadway, where we're going to put it. What are we going to do if we have a mass casualty incident? How are we going to get everybody treated? We only have 7 ambulance services and 3 first responder units in all of Tama County. A few of our ambulance services have 2 ambulances, but the next question is, do we have enough responders that are available that aren't injured or don't have issues at their own homes to get to their stations? And are their stations available to get to, that we can get their doors up? We can get people in their rigs to get out of their departments to go check homes. How many homes do we have that are damaged or destroyed? Do we have people that are stuck in homes? Or do we have people that are worse in their homes? Do we have lines that are down, arcing, sparking, or worse? Do we have fires in any buildings? Do we have any hazardous materials incidents? Do we have any anhydrous leaks at the co-ops? Do we have enough places for shelters for people that are not without homes? Pets, do we have animals that are running at large right now? Do we have farm animals that need to be corralled back in? Do we have community buildings to use for those shelters? Do we still have a humane society to take animals to? Do we even have radio communications right now? And that all of that is just filtering around in my head and so much more. And the next thing that popped into my head is, we're on our own. As Tama County, we are on our own. We cannot call for immediate response from responders around us, mutual aid agreements, because the mutual aid agreements, those people are also dealing with this as well. So if we're going to get help, it's going to be coming from hours away. We're on our own right now. This is our part of our communications issue that we had. So Tama County sets off 5 outdoor warning sirens across the county, one of them being the fairgrounds sirens in Tama, or outdoor warning siren up in Gladbrook. Little did we know, when the storm hit Gladbrook, they had a large tree that sat right along the electrical line, and that tree took out the power that goes to that siren that you see in the background. It'd be right back here. So we were not able to set that siren off. Had no idea until a couple weeks after the storm, and someone from the fair board called and said, hey, you probably want to get this fixed. This picture of the tower over here, that would be our Vining communication tower. The wind took the top half of that tower out, and the top half of that tower, we have microwave receivers and antennas. We didn't know that tower was bent in half at the time. So that communication tower was lost. Luckily, we are in the process at Tama County of building a brand new 7800 megahertz radio system. So that tower is being decommissioned and the equipment is being put on a brand new tower. But just kind of for Tama County and what we have, the dispatch center received 441 routine calls. So that would be on the administration lines, and 911 calls in 5 hours. So that was pre and post storm. So from the hours of 11:47 a.m. until 5 p.m. on the day of the derecho. So that's 88.2 calls in 5 hours, or 1.47 calls per minute. And that's 2 dispatchers in the whole entire center working nonstop. This is a picture of our secondary road shop that sits just right north of Toledo. It's on K Avenue, 280th Street. Not that a lot of you are familiar with Tama County, but it's kind of north and a little east of Tama County. We had just called out to this shop to let them know this storm was coming through. There was approximately 5 or 6 employees out there. They do not have a safe room in this shop. They have a bathroom that is kind of a plywood structure right in the middle of their shop. As soon as we called out there, told them what was going on, right after they hung up the phone, maybe less than a minute or so, the wind picked up. They have those hoop buildings that have the fiberglass or the plastic tarps on them. They saw that blow by their building. They realized that something was majorly going on and they needed to seek shelter. So they pushed some heavy duty shop carts up against by the doors, kind of made a bunker and went into the shop or went into that bathroom. Right as the last guy went in there, that the end of the building that you see there that's kind of leaning and gone, it peeled back and left the end of that building. About that time, the roof came in and that was it. If we wouldn't have had that phone call from the Des Moines office when we did, those guys would not have had any pre-warning and somebody would have been seriously hurt or killed at this shop. I can't thank the Des Moines office enough for that phone call that helped us out tremendously with saving some of these guys from serious injury out there that day. We had a lot of grain bins and a lot of farm ground damaged from the derecho. If I get this to play, this is I'm not sure it'll play, but Kip Ladegi, he's a Bremer County emergency manager. He came down and took a lot of drone footage for me just because I knew I was not going to have time to go out and fly the drone myself to take footage of the corn that was flattened and the bins that were damaged across the county. I wish I had the amount of fields that were damaged and or destroyed and the number of bins that were flattened, damaged and or destroyed. I was not able to get a hold of Farm Bureau to get an approximation, but it was just not a pretty harvest for the farmers in Tama County. We also had a lot of secondary responses for gas leaks that we had to go handle. So this is the co-op in Chelsea. They had an extremely large bin that blew down, which blew into a gas line and caused that gas line to rupture. Don't remember if it was an 8-inch or a 10-inch gas line. We had to evacuate a few homes around this structure in Chelsea just because we were afraid if it was going to ignite. The wind speeds and the directions, we took some precautions and waited for a line to come in and shut that down and repair the line. So these are just some photos that I actually had requested. Since I wasn't able to take a lot of photos myself, I called and kind of put out an all call across the county for people to send me their pictures, send me some information that they have. So that way we could show everybody what we were dealing with. The tree damage and the tree devastation in and around the county was probably centrally focused the worst in the communities of Tama, Toledo, and Vining. Again, everybody had some sort of damage, but Tama, Toledo, and Vining seem to have gotten the hardest hit. The big concerns we have now, or that I have now for my previous county, is along the Iowa River Valley. And also we have several creeks that do have some flash flooding issues. It'd be Wolf Creek, Salt Creek, Deer Creek. I have some concerns for those in the future, just because we do have so much tree damage in there, is what's going to happen with those because they're not getting cleaned up. Private landowners don't have the resources to get those cleaned up that they need to. And we have a lot of flooding issues, sometimes some flash flooding issues with those. And how's that going to impact the future of Tama County, the crop area, the wildlife area in through there? I've tried to work with Homeland Security to see what we could do. DNR kind of put some information out there that we need to get this looked at. We need to see what kind of programs we can get for the private homeowners. to get that area cleaned up because it's going to get worse and it's going to cause more problems down the road. We had also, just kind of give a heads up, since we had a very widespread across all of the county power outages, every home had issues with spoiled food in their homes. So we took it to the city councils, let them know, as kind of good will towards your citizens, bring in some dumpsters. That way people have the outlet to throw away all of that spoiled food that was in the refrigerators. So we set out dumpsters in a lot of the communities, had them just out there for at least 4 or 5 days. So that way people could get things cleaned out, get all their spoiled foods out of deep freezes and refrigerators taken care of. DHS was very nice to come in and work with the food program to get things cleaned up. Streets department, when this initially happened, when kind of go backwards a little bit, when this storm initially hit, we couldn't get through any street. Every street was covered with some type of debris, whether it be a tree, part of a home, a roof, trampolines, swing sets, you name it, there was something on every street. So the streets departments in these communities had to kind of think outside of the box, and they put the snowplows back on their vehicles and pushed paths open to get the streets cleared, or at least a path cleared through the streets so we could go out, do our grid searches, make sure no one was hurt or injured or worse. And then the cleanup started at that point in time. It was not an easy task. It was a very monotonous task. They kind of gridded the city off, went block by block, and started taking trees down and putting them on the berm, the shoulder area of the roadway. I can say we had a lot of headaches and some heartaches over trees that people had on their properties. There was a lot of hurt feelings, unfortunately, with the trees, but it's something that we had to do. We also had to make sure we separated, the debris from the trees and went that path. We had a lot of long hours, and we also had to take COVID into consideration during this entire time, because we had people that were coming up COVID positive in shelters. We had responders that were coming up COVID positive. So then we had to take a step back and say, okay, now what are we going to do? We had this responder come up COVID positive. He was in the fire department helping us out at that time. Now we need to go have people tested. So it really threw a lot more of some worrisome times into an already stressful situation. It did not make things easy for us. And so then, make more late nights and more early mornings even worse. People were asking, well, what about the power? How do we get power back on? So we needed to figure out a way to get the communities informed. So we started having town hall meetings, but outdoors. That was a wonderful suggestion by Kip Ladegi again. He said, you need to have town hall meetings, but let's do them outdoors. Find a large parking lot, have people come in, have them stay at their vehicles, get a PA system and start announcing information to your citizens or your community members that way. So we had the mayors from Tama and Toledo, Alliant. I think we had fire chiefs, streets department, whomever we could think of that needed to provide information. And we started doing that. We did that through the first week. On the weekend, we noticed people weren't showing up as much. So then I started doing Facebook live feeds to give the information that was needed. So that worked out really well. Just kind of giving people that information, it helped kind of ease people's tensions about what's going on, when can I expect it. And unfortunately, Alliant couldn't tell them when to expect it because from what I understand, there was the Alliant terminal in Marshalltown that sustained heavy damage. And we also learned that Alliant was sending their crews out to, I believe it was the East Coast, for the storm that was pending out there. So they had over a couple thousand Alliant workers heading to the East Coast for their storm when this storm hit here. So it threw kind of that monkey wrench into the system, as well as they were preparing for the East Coast storm. And then we had the storm here in Iowa. So they were recalling everybody to come back here. And it took them, I believe, 48 to 72 hours to get people back into the central Iowa area to help out. So, you know, we have different issues than they had in the metro area, but kind of in the grand scheme of things, we all had those same issues that we had to figure out. How do we get the people that have the damaged and destroyed homes a place to stay? We didn't have as large of a non-speaking English as their first language community, but we still have a large Spanish population in Tama and Toledo that we had to communicate with. We still had homes that, like you see in this picture, that have a large tree through them. How do we find these people to get them the information? And how do I, as one person, do all of the damage estimates to send to the state to see if we will even qualify for a presidential disaster declaration? So it was, for me, getting up at 4 o'clock in the morning and working till 1, 2 o'clock at night, trying to sleep, you know, when it's hot outside and you don't have air conditioning and those creature comforts of home again. And also, as a, you know, living in Tama myself, what is my home like during that first day? What is my house still standing? Do I still have any property left? Do I have a roof left? I have a dog that I love dearly. I don't have any children and not married, but do I still have a home to go home to? And is my dog still in the house? So I knew before I could really hone my focus into what I was doing, I had to go home and be a homeowner for at least 5 minutes to make sure that my home was okay. And knowing that people were going to start coming in and asking, you know, this is hard thinking back on it, but can you help me? I don't have a home to go home to. I've lost everything. Can you help me? And it's still hard thinking back on it, because there's still some people that need that help and they haven't gotten very far in rebuilding yet. So leaving Tama County knowing that I still have people to help is still a little difficult for me. But like I told them, I said, you know, I'm not that far away. You can still call me at any time. The landscape of Tama County has changed tremendously. I know the farmers really suffered through a lot of things as well. And a lot of our businesses have suffered also. My old office was in with Tama County Economic Development, and Catherine Olendike worked really hard to keep all of our businesses within Tama County. We did lose one business. They went somewhere else because they could not rebuild in the same spot. They didn't want to rebuild in the same spot. And they decided to move out of Tama County. So that was one that wasn't going to be able to stick around, but we have since brought a couple more into Tama County, which was great. But just knowing that the damage and devastation that we had, and it's not our first derecho. Our first derecho that I heard was back in 1998, and it hit the far southeast corner of Tama County. Of course, then we had the one in 2011 in July that hit the central portion of Tama County, and then this one we had back in August. And it sounds like this one was actually the worst. We had South Tama School, the middle school lost the roof, and I don't believe they're still back in the middle school yet. They've had to rearrange their entire school buildings and do some modification to their school days and their school classes to get everybody into the buildings. We had a lot of, as you can see, cemeteries that have had some damages. The Tama County itself, the county aspect of it, there are 29 buildings across Tama County, and 20 of the 29 buildings were damaged and or destroyed. Vehicles for Tama County, I didn't even have the last count of how many vehicles were damaged or totaled. This is downtown Toledo. They had to take out the first 2 or 3 of those buildings. Radio communications, of course, was just damaged. Antennas still were bent. They have not been fixed because the new Tama County communication system will be coming online here hopefully this summer. Toledo, Tama Police Department lost a garage. So the county infrastructure as a whole also took a hit too. I believe the grand total for Tama County was over $3 million. That's just the county portion. That's not including the any of the cities. So just the county price tag was over $3 million for damage. So as you can see in this picture, the city of Toledo had to take down buildings because of the damage done to them. They weren't structurally sound anymore. And, you know, they've been rebuilding. They have been in the process of trying to get homes back together, get people back in homes. I'm not sure how many people have left the area. I know there's been a lot of homes up for sale because of the damages. And people keep going. They've been very resilient. They've been very helpful towards each other, but they're still scared. I have a lot of parents that I've run into since the storm asking me, how do I help my kids feel better about what's going to happen this spring? And I'm really not sure what to tell them. I just tell them, you know, reassure your kids, talk to your kids about what the storms are coming in, what the storms are going to do, watch the news, and don't lie to your kids. If there's a tornado warning, let them know it could happen, but we're not going to panic until, you know, you hear the outdoor, if you're outside, you hear the outdoor warning siren, we're going to go inside. We're going to get a weather radio to help us prepare. We're going to help you by getting preparedness gear together. We're going to get that pack for our home. We're going to put things in our car, just letting them know that we are going to be okay, but we still have to prepare for the next time, because there will be a next time, and people are now more aware of that than ever. It's just, what is the next time going to be like, and how bad is the next time going to be? I even had a brief panic moment. I hate to say it. It was kind of that PTSD moment when I heard the data tones go off for the severe thunderstorm warning that was in Marshall and Grundy County. I believe it was last week or the week before. So it's going to happen to the best of us. It's just, you know, how are we going to handle it? And you just got to breathe through it. For the agricultural side, I know the gentleman that owns the hog barns in this picture, he didn't rebuild. He couldn't afford it. The insurance paid him out for it. And like he said, he goes, I just can't afford to put the money back into the hog barns because this storm was just too much for me. So he is going to wind up selling that property to another hog manufacturer, and they're going to rebuild for him instead. But he just didn't have the time. He was actually in the barns when these went down. So he hid behind one of the cement walls while the roof came down. Luckily, he was not injured. I don't believe he had much loss for the hogs, but it was still one of those things that he, you know, has to deal with as well. And he was a deputy for 20 some odd years. But there's a lot of stories like this that I know are bothering people, and they have to work through also. But if I can sit and listen to them for just a little bit, it helps. So this storm was not easy for us to deal with. I know it's not easy for people in the metro to deal with. And I hear people ask me all the time, well, why did Cedar Rapids get so much press attention on it? Like I told them, I said, it's better that we didn't, because then we could clean up and kind of get what we needed to get a lot faster. So, and like I tell them too, don't look at the pictures too much, because then that just kind of brings us back to where we need to be. On the anniversary of it, we'll celebrate that where we are today and just keep moving forward. So, yeah, as you can tell, the crop damage, it's really hard to, there's still some fields that were not able to be, they all had to be tilled under because of how flat the corn was. You drove by the day before and you couldn't see across the field because the corn was so tall. And the next day after the storm, you drove by and the corn was just flat. The bins have, a vast majority of the bins that were damaged have all been rebuilt. A lot of them have come back taller. So that's a sign of progress. Some of the homes are still boarded up. A lot of the corn cribs that you see have been taken down. So it's the old stuff that needs to be rebuilt. And this picture here was really kind of, it took me back because he was walking on his bins that once stood. These bins here are on Highway 63 by the Garwin corner. Those have since been rebuilt. There was at least 6 of them that were all damaged and or destroyed. They're all back in one piece now. That's Heartland Co-op. Heartland, Tama Benton, and FS all had a lot of damage, and they are since, a lot of them are back up and fully operational now, and they're rebuilding and building a lot more. Hopefully we should be about the end. I didn't realize I had this many pictures of everything on there. John Spear, who used to be the photographer for our local newspaper, went out and took a lot of pictures for us, and that helped quite a bit because I wasn't able to document a lot of the damage. This is one of the, this is down by the co-op in Toledo. This is Dozal's. It's a farm co-op in Tama. This picture with the thunderhead and back, it just kind of resonated with a lot of people. And they're like, you know, we just can't take any more storms this summer. It just was a little bit too much.
And Mindy, this is Alex. We are beginning to run a little bit short on time. I had Craig Sash listed as one of the speakers. I don't know if he's in the room or if he was still planning on presenting or not, but if he had any slides.
Yep, there's just pictures left, so that's quite all right.
We unfortunately have not heard from Craig Sash and have not seen him in the room here at all. So I presume that we will not be having his presentation today.
Okay. Nope.
Okay. If you haven't heard from him, yeah, just go ahead and finish then.
Nope, there's just some agricultural pictures on here that I threw on there in case Craig showed up and he could talk over them. So that was just kind of the idea that we had together, and he was just going to talk about the ag half, and I was just going to let the pictures roll. So I was just, that was his part of it. I was just ad-libbing until he got here. So.
Okay. Yeah. I just wanted to make sure that we had time for him to come in, but yeah, I have not seen him come into the room yet. So, but yeah, if you have any final comments, it looks like we got a few more pictures left to go.
Yep.
So.
No, we had some wonderful volunteers come in. I know that we had Samaritan's Purse come in. They were a wonderful operation to help a lot of families in Tama County. We had a lot of feeding operations come in, which were wonderful for us. An outfit out of Nebraska came in and fed people for 3 or 4 days. These are the pictures of them. Big cars lined up down the block for hot meals. And all of the, there's the outfit, Hot Meals USA, that came in and fed people. They came in with a full kitchen, made meals. It was just, it was amazing how many people they fed. Casey's, Quick Star, Fairway, Hy-Vee, everybody just did a phenomenal job of feeding people. The Iowa beef, or yeah, Iowa, a pack, Tama pack in Tama and Toledo donated 60,000 burgers to feed people. So the communities all came together and did a magnificent job of doing everything. So yeah.
Okay, thank you, Mindy. We do have a few questions that have come into Slack here. So if we can, since we're towards the end of our symposium here, I'll go ahead and ask them. So we have Brandon Lawrence, who's a broadcast meteorologist here in Des Moines, asked, for county emergency managers, how can the local media outlets help you during the post-storm cleanup and assessment process? We have a unique challenge of balancing reports from many counties and cities at one time, but I'm curious how you think we can assist you in getting the word out to people in your community, if there's any way to do it.
Partnering with broadcast media, so that way if we have information about where people can go to report damage and how to report their damage, a lot of counties have apps or email that they can send information to where the damages is, how to report the damage, what information we need on damage. That is a great partnering tool. That way we can maybe do a Zoom, or now we can do a Zoom, or if we need to do some type of live broadcast media, that's the best thing we can do together, is just partner together. If we need to set it up on NWA's chat, or if we need to do face-to-face, or if we need to do like some type of They're waiting for you. Okay, we need to do some type of live broadcast media. That would be wonderful.
Okay, sounds good. It looks like you need to go, right? We do have one more question, but if you have to go, that's fine too.
No, but it's quite all right. I was double booked today and it happens.
Okay, that's fine. So the final question I have here in Slack is asking, would the grain bin damage be less if the bins had been full?
The full bins were the ones that you noticed that didn't have any damage to them. The ones that were the most heavily damaged were either just slightly full or completely empty. Those were the ones that sustained the most damage, were the empty bins.
Alrighty, and then we had one more question come in. Have you changed the siren policy for Tama County and coordinated those with the neighboring counties?
Yes, I actually, prior to the derecho, we did not have a wind threshold policy to set off the outdoor warning sirens. Since that, I partnered with all of the local fire chiefs and the Emergency Management Commission to get that wind threshold policy. It mirrors what Iowa Emergency Managers Association has. I believe the threshold was sustained 70-mile-an-hour wind, and the outdoor warning sirens will be sounded at that point in time. So when we do get that teletype on inlets that has 70-mile-an-hour winds, then the outdoor warning sirens will be set off at that point in time.
Okay, very good. That's great to hear. That's also good to know from our end at the National Weather Service. We always like to know what the impacts are going to be when we make that decision and when we issue the warning. So, Mindy, thank you very much for your time. I know you were busy today being double booked, so apologize that we did have some of the technical difficulties, but we're glad we were able to get your presentation in here. I think there was a lot of great information in this derecho session of the conference. So,
yeah, if anybody ever has any questions, just certainly get a hold of one of the emergency managers across the state. We're more than happy to work with you.
All right, sounds good, Mindy. Thank you very much. And with that, with the end of that presentation, that will bring us to the conclusion now of the 2021 Extreme Weather Symposium for the Central Iowa NWA. So I would like to thank all of our speakers this afternoon. I think we had a great lineup and we got many new perspectives from the derecho, ranging from operational meteorologists to research meteorologists, broadcast meteorologists, as well as in the response from FEMA officials and local government as well. So at this time, I will now go ahead and hand our closing remarks back over to our chapter president, Kenny Podradzik, for our closing remarks. So thank you, everybody, and have a great day.
Yeah, I just want to second that, what Alex was saying about fantastic stuff today. Appreciate everybody's time that they put in for their presentations, as well as the chapter members putting in the time to get this organized. I know it's there's a lot of work to be that has to be done to get something like this organized, and doesn't always go perfect, but I think it went pretty well today. So I really appreciate everybody's hard work on that as well. So, and just one last thing. Typically on a Friday afternoon at our conference, we have an open bar in our poster session. So you're gonna have to do that on your own tonight. Now, one last thing though is we do plan to do our in-person conference next year. It's March 24th through the 26th of 2022. So that's a Thursday, Friday, Saturday again. So save the date on that, and look forward to meeting a lot of these folks that presented today and even more. So that concludes. That's all I have. So thank you again for your time, and have a wonderful, safe year.
Hey, John, do you need any help closing out any of the Slack things or anything related to Zoom that you need help with? Any help with recording or anything like that?
I just had to find my mute button again. Nope, I'm basically just watching everyone filter out.
Okay.
And then once we reach a good threshold, I'll stop the recording and get all of that. Yeah.
Okay, sounds good. Thanks for getting the slides up there for our sponsors in there. I think we did it the number of times that we promised. So.
Yes.